Welcome to SQL Full Course. Whether you are just starting out or aiming to sharpen your database skills, you are in the right place. SQL or structured query language is an essential tool for managing and working with databases. It's highly valuable in fields like data analysis, software development, and database administration. With SQL, you can interact with databases, retrieve value insights, and make data-driven decisions. Throughout the course, you will dive into SQL fundamentals, learn to write advanced queries, and explore topics like joins, subqueries, and database design. By the end, you will be equipped to handle real-world projects. We will cover an introduction to SQL and databases, core commands, data manipulation, advanced techniques, database structure, and SQL for data analysis. SQL is a powerful tool for managing and analyzing data, and this course will equip you with the skills needed for success. Before that, if you're interested to make a career in data analytics, check out Simplilearn's postgraduate program in data analytics. The comprehensive course is designed to transform you into a data analytics expert. The program covers essential skills such as data visualization, statistical analysis, and machine learning using industry-leading tools and technologies like Excel, R, Python, and Tableau. Join now to advance your career and become a data analytics professional. You can find the course link in the description box and pinned comments.
Today we will learn about what is DBMS. So let's start with an example. Imagine a library where all the books are meticulously organized, categorized, and cataloged. This library can quickly provide any book you request thanks to its efficient management system. Similarly, a database is like this library, but for data. Whether it's customer information for a bank, patient records for a hospital, or product inventories for an e-commerce site, databases efficiently store and manage data and making it easily accessible and updatable. So now we'll see the different types of databases that cater to various needs, just like different sections in a library cater to different genres of books. Understanding these basics is crucial for appreciating the advanced functionalities of database management systems. So in technical terms, a database is an organized collection of data, generally stored and accessed electronically from a computer system. Databases can store various types of data, such as text, numbers, images, and more. So let's begin with understanding what a DBMS really is. Essentially, a DBMS is software designed to manage databases. It helps in storing, retrieving, and updating data efficiently. Think of a DBMS as a sophisticated library system, where each book is a piece of data, and the DBMS ensures that each book is organized properly and can be easily found and is kept secure. Imagine you walk into a massive library filled with millions of books. Each book represents a piece of data. In this library, there are librarians who know exactly where each book is and can quickly find any book you need and ensure that the books are safe and well organized. This library is like a database, and the librarians are like a DBMS. And in the 1960s, as the amount of data grew exponentially, we needed something more efficient than manual methods. This led to the creation of DBMS, a software specifically designed to manage, retrieve, and secure data efficiently. Today, examples of popular DBMS include MySQL, Oracle, and SQL Server, which power many of the applications we use daily. Now that we have a clear understanding of what a DBMS is and its importance in managing data, let's delve deeper into the heart of these systems. Just like any complex machinery, a DBMS is made up of several key components, each playing a crucial role in ensuring the smooth operation and management of databases. So let's explore these components in detail. So DBMS consists of several key components that work together to manage data efficiently. Let's look at these components. Number one is database engine. This is the core service for assessing and processing data. And then comes the database schema that defines the logical structure of the database. Then comes the query processor that interprets and executes database queries. Additionally, there are other components like the storage manager, which manages the physical storage of data, and the transaction manager, which ensures data consistency and handles transactions. So let's understand this with the help of an example. Imagine a DBMS as a factory that processes raw materials into finished products. The database engine is like the factory floor where all the action happens. The database schema is the blueprint outlining how everything should be organized. The query processor acts like the machinery executing specific tasks based on instructions. And the storage manager is the warehouse, ensuring all raw materials and finished products are stored correctly. Lastly, the transaction manager. It's like the quality control team, ensuring everything is consistent and transactions are smoothly handled. Now let's explore the core functions of Database Management System or DBMS. These functions are crucial for efficient data management and ensure that the systems operate smoothly and effectively, from storing and retrieving data to managing transactions and ensuring data integrity and security. Each function plays a vital role in the overall operation of a DBMS. So let's start with the functions of DBMS. So DBMS stores large amounts of data in a structured way and retrieves data efficiently and allows update to be made easily. So let's start with the functions of DBMS. The functions are data storage, retrieval, and update. So DBMS stores large amounts of data in a structured way, retrieves data effectively and efficiently, and allows update to be made easily. Then comes the transaction management that handles multiple operations on the database while ensuring data consistency. It manages transactions to ensure they are processed accurately and securely. Then comes the data integrity and security that ensures that data remains accurate and consistent throughout its life cycle. That implements security measures to protect data from unauthorized access and breaches. Now moving to the advantages of using DBMS. So using a database management system offers numerous advantages that enhance the efficiency, security, and usability of data. So let's explore these benefits in detail, from ensuring data consistency and integrity to improving data sharing and providing robust security measures. DBMS plays a crucial role in modern data management. Additionally, it offers data abstraction and independence, making data handling more flexible and manageable. So imagine you are running a large company with numerous departments with hundreds of employees. Managing data manually would be chaotic and error prone, but with a DBMS, data consistency and integrity are maintained, ensuring that everyone works with accurate and up-to-date information. The system also promotes improved data sharing, allowing different departments to collaborate seamlessly. Enhanced security features protect sensitive data from unauthorized access, just like having a robust security system for your company's valuable assets. Furthermore, the separation of data from applications, known as data abstraction and independence, allows you to update or change your applications without affecting the underlying data structure, making your data management more flexible and efficient. So now moving to types of DBMS, that is database management system types. Data management systems comes in various types, each designed to handle different kinds of data and use cases. So let's explore the main types of DBMS. Number one is relational DBMS, then comes NoSQL DBMS, then we have object-oriented DBMS, and then we have hierarchical DBMS and network DBMS. Each type has its unique features and applications, making them suitable for different scenarios. So let's start with relational DBMS. It stores data in tables with rows and columns and uses SQL, that is structured query language, for querying and managing data. Examples are MySQL, Oracle SQL Server, and then coming to NoSQL DBMS, that is designed for unstructured data and big data applications. And it supports a variety of data models including document, key value, column family, and graph. Examples for these are MongoDB, Cassandra, Redis, and more. Now coming to object-oriented DBMS that stores data as objects, similar to object-oriented programming, that supports complex data types and relationships. Examples for these are DB4O and ObjectDB. Now moving to hierarchical DBMS that organize data in a tree-like structure with parent-child relationships, and that is efficient for specific applications like directory services. And the examples are IBM Information Management System, that is IMS. Now moving to the next, that is network DBMS, that uses a graph structure to represent data and its relationships, and it supports many-to-many relationships between data. And the example for these are integrated data store, that is IDS. Now imagine you are managing different types of libraries. A relational DBMS is like a traditional library with books organized in rows and columns, easily searchable with a catalog. Now coming to NoSQL. So NoSQL DBMS is like a digital library that supports various media types and formats, handling massive and unstructured collections efficiently. Then comes object-oriented DBMS. That's like a specialized library for complex collections, where each book is an object with detailed attributes and relationships. Then comes hierarchical DBMS. That is similar to an archive with a tree-like organization, making it easy to navigate through related documents. Finally, a network DBMS. That's like a web of interconnected libraries, supporting many-to-many relationships, making it easier to explore interconnected collections. So with that types of DBMS, now coming to common use cases of DBMS. So database management systems are widely used across various industries to handle massive amounts of data efficiently and securely. So let's look at some of the use cases where DBMS plays a vital role. From banking systems and airline reservation systems to telecommunication networks and financial systems, DBMS ensures data is managed effectively to support critical business operations. So talking about banking systems, it manages customer data, transaction records, and financial statements to ensure accurate and secure banking operations. Now we talk about airline reservation systems. So DBMS handles booking information, flight schedules, and passenger details to streamline the reservation process and improve customer service. Now coming to telecommunication networks, that manages subscriber data, call records, and network performance metrics to ensure reliable and efficient communication services. Now coming to financial systems, that supports trading, risk management, and compliance by managing large volumes of financial data with precision and security. So imagine walking into a bank and being able to access your account details instantly. This is made possible by the DBMS that manages all customer data and transactions seamlessly. When you book a flight, the reservation system quickly retrieves available seats and schedules, thanks to DBMS handling all booking information and flight schedules. In the telecommunication sector, DBMS ensures your call records and subscriber data are managed efficiently, providing you with reliable service. And similarly, in the financial industry, DBMS supports various operations like trading and risk management by securely managing large volumes of data. These are just a few examples of how DBMS support critical operations across different industries. And with that, guys, now we will discuss the future trends in DBMS. So as technology continues to evolve, so do database management systems. So let's explore some of the emerging trends in DBMS that are shaping the future of database management system. These trends include big data and NoSQL databases, distributed databases, cloud databases, and the integration of machine learning. So talking about big data and NoSQL database, that is designed to handle massive volumes of unstructured and semi-structured data that support for various data models like document, key value, column family, and graph. Examples are MongoDB, Cassandra, Hadoop. Now coming to distributed databases. So these databases that run on multiple servers or nodes, providing high availability and scalability. So in this, data is distributed across different locations but appears as a single database to users. Examples are Google Spanner, Apache Cassandra, and Amazon DynamoDB. Now coming to cloud databases. So these databases are hosted and managed on cloud platforms, offering flexibility and scalability that eliminates the need for physical infrastructure and allows for easy scaling and maintenance. Examples are Amazon RDS, Microsoft Azure SQL Database, and Google Cloud Spanner. Now coming to machine learning integration. So incorporating machine learning algorithms into DBMS for advanced data analytics and predictive modeling that helps in automating data management tasks and extracting valuable insights from data. Examples are Google's BigQuery, Amazon Redshift ML, and Oracle Autonomous Database.
Imagine you're managing an online store. You need to handle day-to-day transactions, analyze sales trends over the past year, and store massive amounts of raw customer feedback from social media. How do you manage all this data efficiently? This is where databases, data warehouses, and data lakes come into play. I'm pretty sure most of you are well aware of what a database is. A database is a system that stores and organizes data in a structured way, using rows and columns, making it easy to access, manage, and update information. Now, if data can be stored and managed in databases, then what is a data warehouse and a data lake, and why do we need them? So in this video, I will give you a clear understanding of what a database, data warehouse, and data lake is with examples. How are they different from each other, and what factors to consider before choosing amongst the three. So let's jump in. What is a database? A database is essentially a structured collection of data or information that is stored electronically. It serves as a centralized repository where data is organized in a systematic way, often using tables, rows, and columns. So the primary function of a database is to support online transaction processing or OLTP, which means it handles the real-time transactions and operations of businesses or applications. So behind the scenes, a database management system or DBMS manages the database, ensuring data is stored securely and efficiently. So the DBMS also allows users and applications to interact with the data through queries, updates, and modifications. So in common usage, the term database can refer both to the actual data repository and the software system or DBMS that manages it, providing a seamless interface between users and their stored information. Now, there are two types of databases. Relational databases store data in structured tables with fixed rows and columns. This structured approach makes them ideal for applications requiring strong data consistency and complex querying capabilities. On the other hand, non-relational databases, often referred to as NoSQL databases, offer more flexibility by accommodating various data models. So these include JSON for semi-structured data, BSON, key value pairs for simple data retrieval, tables with dynamic columns for evolving schemas, and graph databases using nodes and edges for connected data relationships. So some of the examples of databases are Oracle, MySQL, and PostgreSQL, and also MongoDB. Now, what is a data warehouse? So a data warehouse functions as a specialized database designed to store structured information gathered from multiple sources, so encompassing both current and historical data. So unlike traditional databases primarily focused on transaction processing, data warehouses are tailored for analytical purposes. So they consolidate data from different systems to facilitate comprehensive analysis, uncover insights, and generate business intelligence through reports and dashboards. So in essence, while a data warehouse is indeed a type of database, it distinguishes itself by its optimized architecture for handling complex queries and facilitating data analytics essential for strategic decision-making in organizations. So a data warehouse serves as a centralized repository designed to store large volumes of both current and historical data gathered from diverse sources. This data ranges from raw, initially ingested information to highly refined, cleansed, filtered, and aggregated data sets. The process of moving data into a data warehouse is managed through extract, transform, load or ETL process, which extract data from its original sources, transform it to fit the warehouse schema, and load it into the warehouse on a regular basis, such as hourly or daily schedules. So this periodic loading means that the data warehouse may not always reflect the most current state of the original systems. So once the data is successfully loaded into the warehouse, business analysts and data scientists can utilize business intelligence tools to connect to the data warehouse. So these tools enable them to explore the data, uncover valuable insights, and generate reports that aid business stakeholders in making informed decisions based on comprehensive data analysis. So examples of data warehouse is Amazon Redshift, Google BigQuery, and IBM DB2 Warehouse. Now, what is a data lake? So a data lake serves as a centralized storage repository for data collected from various sources, preserving it in its original or raw format. So unlike data warehouses that also handle extensive volumes of both current and historical data, data lakes distinguish themselves by their versatility in storing diverse data formats such as JSON, BSON, CSV, etc. So the core objective of a data lake typically revolves around analyzing this data to extract valuable insights. So however, some organizations use data lakes mainly because they offer affordable storage options, storing data in anticipation of future analysis. So data lakes are versatile storage systems that can handle large amounts of structured, semi-structured, and unstructured data. So unlike traditional databases or data warehouses, data lakes don't need data to be organized before storing it, allowing quick accumulation of diverse data types like spreadsheets, JSON files, PDFs, and multimedia. So different users access data differently. Structured data is often used directly by business analysts for insights, while unstructured data requires expertise from developers, data scientists, or data engineers. This set of flexibility lets analysts and scientists discover unexpected patterns and insights, using the data's variety and volume to solve problems that weren't anticipated initially. So data and data lakes can be processed with online analytical processing or OLAP systems and visualized using business intelligence tools, improving data exploration and decision-making capabilities. Some of the examples of data lake are AWS S3, Azure Data Lake Storage Gen 2, Google Cloud Storage, etc. So now let's recap the differences among the three of them. So if your application needs to store data, which is essential for most interactive apps, having a database is crucial. So databases are fundamental for applications in various industries and scenarios. They provide an organized way to store, retrieve, and manage data effectively. For instance, an online store uses a database to handle product stocks and customer orders. Similarly, a healthcare system relies on databases to manage patient information and medical histories. Even social media apps use databases to store user profiles and posts. So without databases, it would be difficult to manage and access data reliably, impacting the functionality and usability of interactive applications. Now, data warehouses are essential when organizations need to store large amounts of historical data and analyze it deeply to gain business insights. Their organized structure makes data analysis straightforward, accessible to business analysts, and beneficial for data scientists. So, unlike transactional databases used daily for operations, data warehouses specialize in handling complex queries and generating detailed reports. So, this capability supports strategic decision making based on past trends and patterns. It's important to know that while data warehouses excel in analytics, they aren't suitable for real-time transaction processing or handling multiple users at once. So organizations typically maintain separate databases for day-to-day operations and use the data warehouse specifically for strategic analytics and business intelligence. Now, data lakes are a budget-friendly way to store large amounts of data in its original form. So unlike regular databases or data warehouses that need data to be organized beforehand, data lakes allow storing various data types like structured, semi-structured, and unstructured without immediate restructuring. So this keeps data raw, letting business fully explore and analyze both current and past information, uncovering insights that may not be obvious initially. So data lakes are great for advanced analytics such as machine learning and predicting trends, offering flexibility for experimenting with data. However, they aren't suitable for handling day-to-day transactions or meeting the fast data access needs of operational tasks, which traditional databases and data warehouses specialize in. So I hope now you all know how the three of them differ. Now, having known that, there are some factors to be considered before deciding on which platform to use. So let's look into those. Considerations like the variety and volume of data sources, the way data arrives, and how predictable its structure is are crucial. So data lakes are versatile, handling unstructured data in various formats. On the other hand, data warehouses specialize in structured data from multiple sources. Now, databases perform well with structured data from one source, but may struggle with scalability. Now, the choice between these platforms depends on these factors, shaping their roles in data management and analytics. Now, in a solid data management strategy, choosing when and how to use data models is crucial. In a solid data management strategy, choosing when and how to use data models is crucial. Data lakes offer flexibility by storing raw data alongside metadata, allowing schemas to be applied later during data extraction for analysis. On the other hand, databases and data warehouses use ETL, extract, transform, load processes. Here, raw data is transformed into a predefined structure upon ingestion, called schema on write. This difference shows how data lakes enable agility in exploring data and adjusting schemas as needed, contrasting with databases and data warehouses that prioritize upfront data organization and consistency through fixed schemas. Now, big data is highly valuable for businesses, evident in their investments in data management. As data grows in volume and speed, storage expenses increase. Data lakes are cost-effective because they store data as is, reducing storage needs compared to data warehouses that require extensive processing before analysis. Databases can scale storage capacity to match demand. Now, the choice between a data warehouse, data lake, or relational database depends on users' role, whether they are a business analyst, data scientist, or a part of operations, and their specific organizational needs. So operations teams focused on business insights often prefer data warehouses for structured data analytics, despite higher setup and storage costs. Data scientists prefer data lakes for their flexibility with structured and unstructured data, which supports advanced AI and machine learning. Business analysts skilled in SQL may find relational databases adequate for generating specific trend reports on business segments. So each option serves different needs based on data complexity, analytics requirements, and cost considerations. Now, organizations have different preferences between open source and proprietary software, along with the communities backing them. So data lakes are popular because many use platforms like Hadoop, and there's a growing amount of unstructured data from various company systems and real-time data streams. Another important point is how easy and affordable it is to update systems and when data sources and structures change. Unlike relational databases and data warehouses, which can be expensive to update, data lakes make it simple to adjust, making them flexible for changing data needs.
Today, I've got a question for you. What's the difference between a data analyst and a data scientist? Well, in this video, we will give you the answers. From healthcare to ride-hailing apps and online shopping to streaming services, big data has transformed applications and how we interact with them. Two key fields underpinning this transformation are data science and data analytics. Now, I know these concepts can be a bit tricky to grasp at first, so let's use a fun analogy to make it more clearer. Imagine for a moment that a business is like a human body. In this scenario, a data scientist would be a general practitioner, while a data analyst would be more like a specialist consultant. Both play crucial roles in keeping the body, or in our case, the business, healthy and functioning well. Think of the data scientist as the GP who looks at the entire body. They need to understand how all the different parts work together and how external factors affect overall health. This big picture views allows them to ask important questions about the body's well-being that others might miss. On the other hand, the data analyst is like a specialist focusing on a specific part of the body, let's say the heart or the brain. They dive deep into the area of expertise, answering specific questions and solving particular problems. For example, if there's an issue with the heart, the data analyst or heart specialist would be the go-to expert. But remember, while the specialist focuses on the area, the GP will still keep an eye on the overall health. They work together, each bringing the unique skills and keeping the body or the business in top shape. So in a nutshell, data scientists and data analysts both play vital roles in keeping a business healthy. The data scientist looks at the bigger picture while the data analyst dives deep into specific areas. Throughout this video, we will explore these roles in a more detail, looking at the specific tasks, skills they need, and how they contribute to the data-driven world we live in. So let's discuss the differences between data analytics and data science. Imagine a thriving social media app with millions of users sharing photos, videos, and messages every day. At this company, we have two data heroes, Alex, the data analyst, and Chris, the data scientist. They both work with data, but their roles are quite different. Alex is like the app's detective. Their job is to figure out on how many people are using the app right now. Alex looks at two things. Firstly, which features are most popular, when do most people log in, and how long do users spend on this app. Alex digs through user activity logs, engagement metrics, and customer feedback to answer specific questions. This helps the team make the app better today. That's what data analysts do. They solve current puzzles using existing information. Now, Chris, they're more like the app's fortune teller and inventor rolled into one. Chris takes all the data Alex collects, put a whole lot and more, and tries to predict the future. They ask big questions like, what new features will users want next year? How can we use AI to make the app more fun? What if we could predict trending topics before they explode? Chris uses complex mathematics, machine learning, and computer programming to spot trends and create new ideas. That's what data scientists do. They use data to predict the future and innovate. Both Alex and Chris are crucial for the app's success. Alex helps the app run smoothly and keeps user happy day to day. Chris helps the company plan for the future and stay ahead in the competitive tech world. Let's look at the key definitions of how they differ from each other. Comparing data science versus data analytics. Data science and data analytics, while related, serve distinct purposes. Data science is a broad multidisciplinary field encompassing areas like machine learning, artificial intelligence, and computer science. It involves researching vast amounts of unstructured data to ask and answer strategic long-term questions. Data scientists often build complex models and algorithms focusing on innovation and strategic decision making, and they usually hold senior roles. In contrast, data analytics is a specialized discipline with data science that focuses on analyzing existing structured data to answer specific and immediate questions. Data analysts interpret data, identify trends, and provide actionable insights using tools like SQL and Excel. They often work in specific departments like marketing and sales. While their skill set is narrower than the data scientists, they have a deep understanding of their particular business's area. Essentially, data scientists create a big picture framework, while data analysts zoom in specific elements within that framework to optimize current operation. Let's talk about the skill set comparison. Skills for data analyst. Proficiency in business intelligence tools, strong statistical analytical skills, intermediate programming skills in SQL and Python, expertise in data visualization tools like Tableau and Power BI. Next, let's discuss the skills for data scientist. To be a data scientist, you must know advanced knowledge of machine learning and AI. You must have experience with big data platforms such as Hadoop and Apache Spark, strong programming skills in Python and R, proficiency in predictive modeling and data mining techniques. Let's discuss the workflow comparison. Now, let's compare the workflows of data analyst and data scientist. The workflow of data analyst typically begins with data collection, where they gather data from various sources to ensure they have all the necessary information. Next comes data cleaning, a crucial step where they remove any errors and redundancies from the dataset to ensure accuracy. Following this, they perform data analysis, using statistical methods to interpret the data and uncover patterns and trends. To present their findings effectively, data analysts then engage in data visualization, creating charts and graphs that make complex data more understandable. Finally, they provide actionable insights, offering recommendations that can be implemented immediately to improve business operations. In contrast, the workflow of a data scientist starts with identifying the problem, where they define a strategic question or opportunity that needs to be addressed. Then they proceed with data mining, extracting relevant data from large data sets to gather the information needed for the analysis. Similar to data analysts, data scientists also perform data cleaning to prepare the data for analysis. However, they take it a step further with data exploration, conducting exploratory analysis to understand the depth of data. Next, we have feature engineering, where they create new features from raw data to enhance their models. And then they build predictive models to forecast future outcomes based on the data. Once the models are ready, they deploy the model into production and start generating insights in real time. The final step is their workflow to monitor and iterate, continuously improving the model based on the new data and ensure it remains accurate and effective. Let's discuss the tools and techniques. Let's explore the tools and techniques used by data analysts and data scientists. Data analysts like Alex uses a variety of tools to handle and analyze data efficiently. They often use Excel for data organization and basic analysis due to their accessibility and functionality. For querying databases, SQL is the go-to language, enabling them to extract and manipulate data effectively. To visualize data and create insightful dashboards, Tableau is commonly employed using robust data visualization capabilities. Additionally, Python is used for more advanced data manipulation and analysis, making it a versatile tool in data analyst toolkit. On the other hand, data scientists like Chris rely on slightly different set of tools to handle their more complex tasks. Python is a staple for data manipulation, machine learning, and artificial intelligence thanks to the extensive libraries and frameworks. R is also a key tool particularly for statistical analysis and visualization, providing powerful statistical techniques. For processing large data sets, Hadoop is indispensable. Enabling scalable and distributed computing, Apache Spark is used for large-scale data processing, offering speed and ease of use for big data analytics. Lastly, we have the TensorFlow, which is important for building and deploying machine learning models, making it essential for AI-related tasks. Let's discuss the application comparison. Let's see how the work of data analysts and data scientists relies in real-world scenarios. Data analysts like Alex plays a vital role in understanding user behavior. For example, they analyze which app features are most popular among users, providing insights that can enhance user experience and app's functionality. In the realm of sales, they identify trends and optimize marketing strategies, ensuring that the company targets its audience effectively and maximizes revenue. Moreover, by analyzing customer feedback, data analysts help improve product features, ensuring the company meets customer needs and expectations. Conversely, data scientists like Chris engage in more predictive and innovative application. They use predictive analysis to forecast future trends and behaviors, allowing companies to make informed strategic decisions. For instance, they build recommendation systems that suggest products or contents to users based on their past behavior, enhancing user engagement and satisfaction. Additionally, they develop AI innovations to improve user experience, such as chatbots or personalized user interfaces, leveraging advanced machine learning models to stay ahead in the competitive tech landscape. At last, we will talk about the career path comparison. Finally, let's discuss the career paths and opportunities and salaries for data analysts and data scientists in both the United States and India. A career in data analyst often begins with marketing or finance. Over time, they can transition into senior analyst role to specialize further in business intelligence. There are also opportunities to move into management positions, overseeing data analysis team and driving strategic decisions based on data insights. In United States, the average salary for a data analyst is around $65,000 per year, with senior roles potentially earning up to $90,000 annually. In India, the average salary for a data analyst is approximately 6 lakh per year, with senior roles earning up to 10 lakh rupees annually. In contrast, a career as a data scientist typically requires advanced degrees and specialized training in data science. As they gain experience, they can progress to senior data scientist roles or lead data science teams, taking on more responsibility and tackling complex challenges. Data scientists also have opportunities to work in cutting-edge fields like AI, machine learning, and big data, where they can innovate and contribute to significant technological advancements. In United States, the average salary of a data scientist is approximately $1,20,000 per year, with senior positions often earning up to $1,50,000 annually. In India, the average salary of a data scientist is around 10 lakh rupees per year, with senior roles earning up to 20 lakh rupees annually. In summary, both data science and data analytics are crucial in today's data-driven world. Data scientists focus on the bigger picture and long-term strategy, while data analysts hone in on specific questions and provide actionable insights. Choosing between the two depends on your interests, career goals, and desired salary.
This session, we are going to learn about databases, how data is stored in relational databases, and we'll also look at some of the popular databases. Finally, we'll understand various SQL commands on MySQL server. Now let's get started with what is a database. So according to Oracle, a database is an organized collection of structured information or data that is typically stored electronically in a computer system. A database is usually controlled by a database management system or DBMS. So it is a storage system that has a collection of data. Relational databases store data in the form of tables that can be easily retrieved, managed, and updated. You can organize data into tables, rows, columns, and index it to make it easier to find relevant information. Now talking about some of the popular databases, we have MySQL database, we also have Oracle database, then we have MongoDB, which is a NoSQL database. Next, we have Microsoft SQL Server. Next, we have Apache Cassandra, which is a free and open source NoSQL database. And finally, we have PostgreSQL. Now, let's learn what is SQL. So SQL is a domain-specific language to communicate with databases. SQL was initially developed by IBM. Most databases use structured query language or SQL for writing and querying data. SQL commands help you to store, process, analyze, and manipulate databases. With this, let's look at what a table is. So this is how a table in a database looks like. So here you can see the name of the table is players. On the top, you can see the column names. So we have the player ID, the player name, the country to which the player belongs to, and we also have the goals scored by each of the players. So these are also known as fields in a database. Here, each row represents a record or a tuple. So you have the player ID, which is 103 here, the name of the player is Daniel, he is from England, and the number of goals he has scored is 7. So you can use SQL commands to query, update, insert records, and do a lot of other tasks.
Now we'll see what the features of SQL are. SQL lets you access any information stored in a relational database. With SQL queries, data is extracted from the database in a very efficient way. The structured query language is compatible with all database systems from Oracle, IBM to Microsoft. and it doesn't require much coding to manage databases. Now we will see applications of SQL. SQL is used to create a database, define its structure, implement it, and lets you perform many functions. SQL is also used for maintaining an already existing database. SQL is a powerful language for entering data, modifying data, and extracting data in a database. SQL is extensively used as a client-server language to connect the front end with the back end, thus supporting the client-server architecture. SQL, when deployed as Data Control Language (DCL), helps protect your database from unauthorized access. So let's understand what an ER diagram is. An entity relationship diagram describes the relationship of entities that needs to be stored in a database. ER diagram is mainly a structural design for the database. It is a framework made using specialized symbols to define the relationship between entities. ER diagrams are created based on the three main components: entities, attributes, and relationships. Let's understand the use of ER diagram with the help of a real-world example. Here, a school needs all its student records to be stored digitally, so they approach an IT company to do so. A person from the company will meet the school authorities, note all their requirements, describe them in the form of ER diagram, and get it cross-checked by the school authorities. As the school authorities approve the ER diagram, the database engineers would carry further implementation. Let's have a view of an ER diagram. The following diagram showcases two entities, student and course, and the relationship. The relationship described between student and course is many-to-many, as a course can be opted by several students, and a student can opt for more than one course. Here, student is the entity and it possesses the attributes, that is, student ID, student name, and student age. And the course entity has attributes such as course ID and course name. Now we have an understanding of ER diagram. Let us see why it has been so popular. The logical structure of the database provided by ER diagram communicates the landscape of business to different teams in the company, which is eventually needed to support the business. ER diagram is a GUI representation of the logical structure of a database, which gives a better understanding of the information to be stored in a database. Database designers can use ER diagrams as a blueprint, which reduces complexity and helps them save time to build databases quickly. ER diagrams helps you identify the entities that exist in a system and the relationships between those entities. After knowing its uses, now we should get familiar with the symbols used in ER diagram. The rectangle symbol represents the entities, oval symbol represents attributes, a rectangle embedded in a rectangle represents a weak entity, a dashed oval represents a derived attribute, a diamond symbol represents a relationship among entities, double oval symbol represents multi-valued attributes. Now we should dive in and learn about the components of ER diagram. There are three main components of ER diagram: entity, attribute, and relationship. Entities have weak entity. Attributes are further classified into key attribute, composite attribute, multi-valued attribute, and derived attribute. Relationships are also classified into one-to-one relationships, one-to-many relationships, many-to-one relationships, and many-to-many relationships. Let's understand these components of ER diagram, starting with entities. An entity can be either a living or a non-living component. An entity is showcased as a rectangle in an ER diagram. Let's understand this with the help of an ER diagram. Here, both student and course are in rectangular shape and are called entities, and they represent their relationship study in a diamond shape. Let's transition to weak entity. An entity that makes reliance over another entity is called a weak entity. The weak entity is showcased as a double rectangle in ER diagram. In the example below, the school is a strong entity because it has a primary key attribute, school number. Unlike the school, the classroom is a weak entity because it does not have any primary key, and the room number attribute here acts only as a discriminator and not a primary key. Now, let us know about attributes. Attribute. An attribute exhibits the properties of an entity. An attribute is illustrated with an oval shape in an ER diagram. In the example below, student is an entity and the properties of student such as address, age, name and roll number are called its attributes. Let's see our first classification under attribute, that is key attribute. The key attribute uniquely identifies an entity from an entity set. The text of a key attribute is underlined. In the example below, we have a student entity and it has attributes name, address, roll number and age. But here, roll number can uniquely identify a student from a set of students. That's why it is termed as a key attribute. Now, we will see composite attribute. An attribute that is composed of several other attributes is known as a composite attribute. An oval showcases the composite attribute, and the composite attribute oval is further connected with other ovals. In the example below, we can see an attribute name, which can have further subparts such as first name, middle name, and last name. These attributes with further classification is known as composite attribute. Now, let's have a look at multi-valued attribute. An attribute that can possess more than one value are called multi-valued attributes. These are represented as double oval shape. In the example below, the student entity has attributes phone number, roll number, name, and age. Out of these attributes, phone number can have more than one entry, and the attribute with more than one value is called multi-valued attribute. Let's see derived attribute. An attribute that can be derived from other attributes of the entity is known as a derived attribute. In the ER diagram, the derived attribute is represented by dashed oval, and in the example below, student entity has both date of birth and age as attributes. Here, age is a derived attribute as it can be derived by subtracting current date from the student date of birth. Now, after knowing attributes, let's understand relationship in ER diagram. A relationship is showcased by the diamond shape in the ER diagram. It depicts the relationship between two entities. In the below example, student, study, course. Here, both student and course are entities and study is the relationship between them. Now, let's go through the type of relationship. First is one-to-one relationship. When a single element of an entity is associated with a single element of another entity, this is called one-to-one relationship. In the example below, we have student and identification card as entities. We can see a student has only one identification card and an identification card is given to one student. It represents a one-to-one relationship. Let's see the second one, one-to-many relationship. When a single element of an entity is associated with more than one element of another entity is called one-to-many relationship. In the below example, a customer can place many orders, but a particular order cannot be placed by many customers. Now, we will have a look at many-to-one relationship. When more than one element of an entity is related to a single element of another entity, it is called many-to-one relationship. For example, students have to opt for a single course, but a course can be opted by a number of students. Let's see many-to-many relationship. When more than one element of an entity is associated with more than one element of another entity is called many-to-many relationship. For example, an employee can be assigned to many projects, and many employees can be assigned to a particular project. Now, after having an understanding of ER diagram, let us know the points to keep in mind while creating the ER diagram. First, identify all the entities in the system, embed all the entities in a rectangular shape and label them appropriately. This could be a customer, a manager, an order, an invoice, a schedule, etc. Identify relationships between entities and connect them using a diamond in the middle illustrating the relationship. Do not connect relationships. Connect attributes with entities and label them appropriately, and the attributes should be in oval shape. Assure that each entity only appears a single time, and eradicate any redundant entities or relationships in the ER diagram. Make sure your ER diagram supports all the data provided to design the database. Make effective use of colors to highlight key areas in your diagrams.
There are mainly 4 types of SQL commands. So first we have Data Definition Language or DDL. So DDL commands change the structure of the table like creating a table, deleting a table, or altering a table. All the commands of DDL are auto-committed, which means it permanently saves all the changes in the database. We have create, alter, drop, and truncate as DDL commands. Next, we have data manipulation language or DML. So DML commands are used to modify a database. It is responsible for all forms of changes in the database. DML commands are not auto-committed, which means it can't permanently save all the changes in the database. We have select, update, delete, and insert as DML commands. Now select command is also referred to as DQL or data query language. Third, we have data control language or DCL. So DCL commands allow you to control access to data within the database. These DCL commands are normally used to create objects related to user access and also control the distribution of privileges among users. So we have grant and revoke, which are the examples of data control language. Finally, we have something called as transaction control language or TCL. So TCL commands allow the user to manage database transactions. Commit and rollback are example of TCL. Now let's see the basic SQL command structure. So first, we have the select statement. So here you specify the various column names that you want to fetch from the table. We write the table name using the from statement. Next, we have the where clause to filter out our table based on some conditions. So you can see here where condition 1, condition 2, and so on. Then we have the group by clause that takes various column names. So you can write group by column 1, column 2, and so on. Next, we have the having clause to filter out tables based on groups. Finally, we have the order by clause to filter out the result in ascending or descending order. Now talking about the various data types in SQL. So we have exact numeric, which has integer, small int, bit, and decimal. Then we have approximate numeric, which are float and real. Then we have some date and time data types such as date, time, timestamp, and others. Then we have string data type, which includes char, this varchar, and text. Finally, we have binary data types, and binary data types have binary, var binary, and image. Now let's see some of the various operators that are present in SQL. So first we have our basic arithmetic operators. So you have addition, the subtraction, multiplication, division, and modulus. Then we have some logical operators like all, and, any, or, between, exists, and so on. Finally, we have some comparison operators such as equal to, not equal to, this greater than, less than, greater than equal to, or less than equal to, not less than, or not greater than. Now let me take you to my MySQL workbench where we will learn to write some of the important SQL commands, use different statements, functions, data types, and operators that we just learned.
In this session, we will learn how to install MySQL Workbench and then we will run some commands. Firstly, we will visit the official Oracle website, that is mysql.com, and now we will move to the downloads page. Now scroll down and click on MySQL GPL downloads. Now under community downloads, click on MySQL installer for Windows. The current versions are available to download. I will choose this installer and click the download button. Now here just click on no thanks, just start my download. Once the installer has downloaded, open it. You may be prompted for permission. Click yes. This opens the installer. You will be asked to choose the setup type. We will go with custom. Click next. Now you have to select the products you want to install. We will install only the MySQL server, MySQL shell, and the MySQL workbench. Expand MySQL servers by double clicking on it. And choose the version you want to install and click on this arrow. Now you have to do the same thing for applications. Expand applications and choose the MySQL workbench version you want to install and click on the arrow. And we'll do the same thing for MySQL shell. We'll choose the latest version, click on the arrow. So these are the products that have to be installed in a system. Now we'll click next. I'll click execute to download and install the server. This may take a while depending on your internet speed. As the download is completed, click next. Now you'll see the product configuration. Click next. Now we'll configure our SQL Server instance. Here we will go with the default settings and click next. And under authentication, select use strong password encryption for authentication, which is recommended, and click on next. Now here set the password for your root user. By the way, root is the default user. This user will have access to everything. I will set my password. Now I will click on next. And here also we'll keep the default settings and click on next. Now to apply configuration, we will execute the process. Once all the configuration steps are complete, click finish. Now you will see the installation is complete. It will launch MySQL Workbench and MySQL Shell after clicking on finish. Now the shell and workbench has started. Now we'll connect by clicking on the root user. It will ask for a password. Enter the password and it will connect successfully. The workbench has started. Now we'll just connect the server. So first we'll open command prompt. Now we'll reach the path where MySQL files are present. We'll go into this PC, local disk C, program files, MySQL, MySQL Server 8.0, bin. And now I'll copy this path. Now I'll open the command prompt and write a command cd space and paste the link and press enter. Now I'll write another command that will be MySQL -u space root -p and press enter. Now it will ask for your password. Just enter the password and press enter. Now the server has started and now we'll see some commands in MySQL Workbench. First we will open MySQL Workbench. Now we'll click on the local instance MySQL AT and enter the password to connect to the local host. Now, the MySQL Workbench has started. Now we will see some commands. The first command we will see is show databases. Show databases semicolon, and now we will select the whole command and click on this execute button, and here we will see the result in the result grid. These are the databases that are stored already in the database. Now there are 4 databases, that is Information Schema, MySQL, Performance Schema and SYS. Now we will select one of the database. We will use MySQL. Now we have selected the MySQL database
And now in this database, we will see which tables are stored in this MySQL database. To see that, we will run a command show tables. We'll select the command and click on the execute button. These are the tables that are stored in this MySQL database, that is columns, underscore prive, component, DB, and much more.
Now let me go ahead and open my MySQL workbench. So in the search bar, I'll search for MySQL workbench. You can see I'm using the 8.0 version. I'll click on it, and here it says welcome to MySQL workbench. And below under connections, you can see I have already created a connection which says local instance. Then you have the root, the local host, and the port number. Let me click on it. You can see the service, the username is root, and I'll enter my password and hit OK. Now this will open the SQL editor. So this is how the MySQL workbench looks like. Here we learn some of the basic SQL commands. So first, let me show you the databases that are already present. So the command is show databases. You can hit tab to autocomplete. I'll use a semicolon. I'll select this, and here on the top you can see the execute button. So if I run this, below you can see the output. It says show databases, 7 rows are returned, which means currently there are 7 databases. You can see the names. Alright, now let's say I want to see the tables that are present inside this database called world. So I'll use the command use world, which is the database name. Now let me run it. So currently I'm using the world database. So to display the tables that are present in the world database, I can use the show command and write show tables. Give a semicolon, and I'll hit Control Enter this time to run it. Alright, so you can see the tables that are present inside this world database. So we have 3 tables in total: city, country, and country language. Now if you are to see the rows that are present in one of the tables, you can use the select command. So I'll write select star, which basically means I want to display all the columns. So star here means to display all the columns. Then I'll write my from the table name, that is city. So this command is going to display me all the rows that are present inside the city table. So if I hit Control Enter, alright, you can see the message here. It says 1000 rows were returned, which means there were total 1000 records present inside the city table. So here you can see there's an ID column, a name column, this country code, district, and population. Alright. Similarly, you can check the structure of the table by using the describe command. So I'll write describe, and then I'll give the table name, that is city. Now let's just run it. There you go. The field shows the column names. So we have ID, name, country code, district, population. Type here shows the data type of each of the columns. So district is character 20, ID is an integer, population is also integer. Null says yes or no, which means if no, then there are no null values. If it's yes, which means there are null values in your table. Key here represents whether you have any primary key or foreign key, and these are some extra information. Now let's learn how to create a table in MySQL. So I'll use the create table command for this, and before that let me create a database and I'll name it as SQL Intro. So the command is create database, and I'll give my database name, that is SQL_intro. Let me give a semicolon and hit Control Enter. So you can see I have created a new database. Now if I run this command, that is show databases, you can see this newly created database, that is SQL Intro. If I scroll down, there you go, you can see the name here, SQL Intro. Okay, now within this database we'll create a table called employee details. Now this will have the details of some employees. So let me first show you how to create a table that will be present inside the SQL Intro database. So I'll use the command create table, and then I'll give my table name that is going to be employee underscore details. Next, the syntax is to give the column names. So my first column would be the name column, which is basically the employee name, followed by the data type for this column. Since name is a text column, so I'll use varchar and I'll give a value of 25. So it can hold only 25 characters. Okay. Next, I also want the age of the employee. Now age is always an integer, so I'll give int. Okay. Then we can have the gender of the employee. So gender can be represented as F or M, F for female and M for male. So I'm using the char data type or character data type, and I'll give the value as 1. Then let's have the date of join or DOJ, and this is going to be of data type date. Alright. Next, we'll have the city name, that is the city to which the employee belongs to. So again, this is going to be varchar 15. Finally, we'll have a salary column, and salary we'll keep it as float, since salary can be in decimal numbers as well. Now I'll give a semicolon. Alright, so let me just quickly run through it. So first I wrote my create command, then the table, which is also a keyword, followed by the table name, which is employee details here, and then we gave the column names such as name, age, this gender, date of join, city and salary. For each of the columns we also give the data type. Alright, so let me just run it. Okay, so here you can see we have successfully created our first table. Now you can use the describe command to see the structure of the table. I'll write describe emp underscore details. If I run this, there you go. So under field you can see the column names, then you have the data types. Null represents if the table can accept null values or not, and these are basically empty, and we haven't set any default constraint. Alright, moving ahead. Now let's learn to add data to our table using the insert command. So on a notepad I have already written my insert statement, so let me just copy it and then I'll explain it one by one. Alright, so if you see this, so we have used an insert into statement or a command followed by the table name, that is emp details. Then this is the syntax. Using values I have passed in all the records. So first we have Jimmy, which is the name of the employee, then we have 35, which basically represents the age, then M means the gender or the sex, then we have the date of join, next we have the city to which the employee belongs to, and finally we have the salary of the employee. So this particular information represents one record or a tuple. Similarly, the next employee we have is Shane. You can see the age and other information. Then we have Mary, this Dwayne, Sarah and Amy. Alright, so let me go ahead and run this. So this will help you insert the values in the table that you have created. You can see we have successfully inserted 6 records. Now to display the records, let me use the select statement. So I'm using select star from emp underscore details. If I run this, you can see my table here and the values it has. So we have the name column, the age column, the state of join, city, salary, and these are the values that you can see here. Moving ahead, now let's say you want to see the unique city names present in the table. So in this case, you can use the distinct keyword along with the column name in the select statement. So let me show you how you can print the distinct city names that are present in our table. Now if you notice this table clearly, we have Chicago, Seattle, Boston, Austin, there's New York, and there's Seattle repeated again. So I only want to print the unique values. So for that, I can write my select statement as select distinct. Then I'll give my column name, which is city, from my table name, that is EMP details. If I run this, you can see my query has returned 5 rows and these are the values. So we have Chicago, Seattle, which was repeated twice, is just been shown once. Then we have Boston, Austin and New York. Now let's see how you can use inbuilt aggregate functions in SQL. So suppose you want to count the number of employees in the table. So in that case, you can use the count function in the select statement. So let me show you how to do that. So I'll write select. I'll use my function name, that is count. Now since I want to know the total number of employees, I'm going to use their name inside the brackets from employee underscore details. Now if I run this, this will return the total number of employees that are present in the table. So we have 6 employees in total. Now if you see here in the result, it says count name. Now this column is actually not readable at all. So what SQL provides is something called as an alias name. So you can give an alias to the resultant output. So here I can write select count of name and use an alias as I can give an alias as count underscore name and run this statement again. There you go. You can see here in the resultant output we have the column name as count name, which was our alias name. Now suppose you want to get the total sum of salaries, you can use another aggregate function called sum. So I'll write my select statement, and this time instead of count I'm going to write sum. And since I want to find the sum of salaries, so inside the bracket I'll give my salary column from my table name, that is employee details. If I run this, this will result in the total sum of salaries. So basically it adds up all the salaries that were present in the salary column. Now let's say you want to find the average salary. So instead of sum, you can write the average function, which is avg. So this will give you the average salary from the column salary. So you can see it here, this says average salary. Now if you want, you can give an alias name to this as well. Now you can select specific columns from the table by using the column names in the select statement. So initially we were selecting all the columns. For example, like you saw here, the star represents that we want to see all the columns from the employee details table. Now suppose you want to see only specific columns, you can mention those column names in the select statement. So let's say I want to select just the name, age and the city column from my table, that is employee details. So this will result in displaying only the name, age and city column from the table. If I run it, there you go. It has given only 3 columns to me. Now SQL has a where clause to filter rows based on a particular condition. So if you want to filter your table based on specific conditions, you can use where clause. Now where clause comes after you give your table name. So suppose you want to find the employees with age greater than 30. In this case, you can use a where clause. So let me show you how to do it. I'll write select star from my table name, that is employee details, and after this I'll use my where clause. So I'll write where age greater than 30. If I run this, it will give me the output where the age is only greater than 30. So it excluded everything that is less than 30. So we have 4 employees whose age is greater than 30 here. Now suppose you want to find only female employees from the table, you can also use a where clause here. So I'll write select, let's say I want only the name, the gender, which is sex here, comma city from my table, that is employee details, where I'll give my column name, that is sex, is equal to, since I want only the female employees, I'll give F and run this statement. Okay, you can see here our employee table has 3 female employees. Now suppose you want to find the details of the employees who belong to Chicago or Austin. In this case, you can use the OR operator. Now the OR operator in SQL displays a record if any of the conditions separated by OR is true. So let me show you what I mean. So since I want the employees who are from Chicago and Austin, I can use an OR operator. So I'll write select star from emp details, which is my table name. Then I'll give my where clause where city equal to, I'll give my city name as Chicago, and then I'm going to use the OR operator, or city equal to, I'll write Austin. I'll give a semicolon and let me run it. There you go. So in the output you can see all the employees who belong to the city Chicago and Austin. Now there is another way to write the same SQL query. So you can use an in operator to specify multiple conditions. So let me just copy this, and instead of using the OR operator, this time I'm going to use the in operator. So I'll delete this. After the where clause, I'm going to write where city and use the in operator. Inside bracket, I'll give my city names as Chicago and I want Austin. So I'll give a comma and write my next city name, that is Austin. So this query is exactly the same that we wrote on top. Let me run this. You will get the same output. There you go. So we have Jimmy and Dwayne who are from Chicago and Austin respectively. Now SQL provides the between operator that selects values within a given range. The values can be numbers, text or dates. Now suppose you want to find the employees whose date of join was between 1st of Jan 2000 and 31st of December 2010. So let me show you how to do it. I'll write select star from emp details where my date of join, that is DOJ, between, I'll give my two date values, that is 1st of Jan 2000 and I'll give my second value, the date value, that is 31st of December 2010. So every employee who has joined between these two dates will be displayed in the output. If I run it, we have two employees who had joined between 2000 and 2010. So we have Jimmy and Mary here who had joined in 2005 and 2009 respectively. Alright. Now in where clause, you can use the AND operator to specify multiple conditions. Now the AND operator displays a record if all the conditions separated by AND are true. So let me show you an example. I'll write select star from employee details table where I want the age to be greater than 30 and I want sex to be male. Alright, so here you can see I have specified two conditions. So if both the conditions are true, only then it will result in an output. If I run it, you can see there are two employees who are male and their age is greater than 30. Now let's talk about the group by statement in SQL. So the group by statement groups rows that have the same values into summary rows. Like for example, you want to find the average salary of customers in each department. Now the group by statement is often used with aggregate functions such as count, sum and average to group the result set into one or more columns. Let's say we want to find the total salary of employees based on their gender. So in this case you can use the group by clause. So I'll write select, let's say sex, comma, I want to find the total sum of salary as I'll give an alias name, let's say total salary from my table name, that is employee details. Next, I am going to group it by sex. Okay, let me run it. There you go. So we have two genders, male and female, and here you can see the total salary. So what this SQL statement did was, first it grouped all the employees based on the gender, and then it found the total salary. Now SQL provides the order by keyword to sort the result set in ascending or descending order. Now the order by keyword sorts the records in ascending order by default. To sort the records in descending order, you can use the DESC keyword. So let's say I want to sort my employee details table in terms of salary. So I'll write select star from emp underscore details, and I'll use my order by clause on the salary column. So this will sort all the records in ascending order of their salary, which is by default. You can see the salary column is sorted in ascending order. Now suppose you want to sort the salary column and display it in descending order, you can use this keyword, that is DESC. Let me run it. You can see the output. Now this time the salary is sorted in descending order, and you have the other values as well. Now let me show you some basic operations that you can do using the select statement. So suppose I write select and do an addition operation, let's say 10 plus 20, and I'll give an alias name as addition. If I run this, it will give me the sum of 10 and 20, that is 30. Similarly, you can use the subtraction operator, and you can change the alias name as, let's say, subtract. Let's run it. You get minus 10. Now there are some basic inbuilt functions. There are a lot of inbuilt functions in SQL, but here I'll show you a few. Suppose you want to find the length of a text or a string, you can use the length function. So I'll write select and then use the length function. I'll hit tab to autocomplete. Let's say I want to find the length of country India, and I'll give an alias as total length. If I run it, you see here it returns 5 because there are 5 letters in India. There's another function called repeat. So let me show you how repeat works. So I'll write select repeat. Let's say I want to repeat the symbol that is at the rate. I'll put it in single quotes because it is a text character, and I want to repeat this character for 10 times. Close the bracket and let's run it. You can see here in the output it has printed at the rate 10 times. You can count it. Alright. Now let's say you want to convert a text or a string to uppercase or lowercase. You can do that as well. So I'll write select and use the function called upper. Let's say I want to convert my string, that is India, to uppercase. I'm not giving in any alias name. If I run this, see, my input was capital I and everything else was in small letter. In the output you can see it is converted my input to all caps. Similarly, you can change this. Let's say you want to print something in lowercase, you can use the lower function. Let's say this time everything is in uppercase. If I run it, it converts India to lowercase. Now let's explore a few date and time functions. Let's say you want to find the current date. There's a function called CUR, which stands for current, and this is the function I'm talking about, which is current date. If I run this, you will get the current date, that is 28th of Jan 2021. And let's say you want to extract the day from a date value, so you can use the day function. Let's say I'll use day and I want to find the day from my current date. If I run this, you get 28, which is today's day. Now similarly, you can also display the current date and time. So for that you can use a function that is called now. So this will return the current date and time. You can see this is the date value and then we have the current time. Alright. And this brings us to the end of our demo session. So let me just scroll through whatever we have learned. So first, I showed you how you can see that databases present in MySQL. Then we used one of the databases and checked the tables in it. Then we created another database called SQL Intro for our demo purpose. We used that database and then we created this table called employee details with column names like name, integer, the sex, date of join, city and salary. I showed you the structure of the database. Let me run this again so you get an idea. You can see this was the structure of our table. Then we went ahead and inserted a few records. So we inserted records for 6 employees. So you have the employee name, the age, the gender, the date of join, the city to which the employee belongs to, and the salary of the employee. Then we saw how you can use the select statement and display all the columns present in the table. We learned how you can display the unique city names. We learned how to use different aggregate functions like count, average and sum. Then we learned how you could display specific columns from the table. We learned how to use where clause. Then we used an or operator. We learned about in operator, the between operator. Then we used an and operator to select multiple conditions. Finally, we learned about group by, order by and some basic SQL operations. Now it's time to explore some string functions in MySQL. So I've given a comment, string functions. First, let's say you want to convert a certain string into uppercase. So I can write select. The function I'll use is upper, and within this function you can pass in the string. Let's say I'll write India. If you want, you can give an alias name as, let's say, uppercase. I'll give a semicolon and let's run it. There you go. So my input was in sentence case, and using the upper function we have converted everything into uppercase. Similarly, let me just copy this and I'll show you. If you want to convert a string into a lowercase, you can use the lower function. I'll run this. You can see the result. Everything is in lowercase now. Of course, I need to change the alias name to lowercase. Now, instead of using lower as the function, there is another function that MySQL provides, which is called the L case. So I'll just edit this and write L case, and let's say I'll write India in uppercase. Let's run it. It returns me the same result. Cool. Now moving on, let's say you want to find the length of a string. You can use the character length function. I'll write select, use the function character length, and I'm again going to pass in my string as India as, let's say, total length. Let's run it. This time I'm going to hit Control Enter to run my SQL command. There you go. It has given us the right result, which is 5, because India has 5 characters in it. Now these functions you can also apply on a table. Now let me show you how to do it. Let's say we already have the students table and you want to find the length of each of the student names. So here you can pass stu_name and you can give the same alias name, let's say total length, and then you can write from table name, that is students. If I run this, you can see the output. It has given me total 20 rows of information. It is not readable actually. Let me also display the student names so that we can compare their length. Alright, I'll run this again. and now you can see the result. So Joseph has 6 characters, Nilesh has 6, Vipul has 5, Anubhav has 7. Similarly, if you see, Akshay has 6, Tanishq has 7, Raghav has 6, Cummins has 7, Rabada has 6, so on and so forth. Now instead of using this character length, you can also use the function char length. It will work the same way. Let's see the result. There you go. It has given us the same result. You can either use character length or char length. Now there's another very interesting function called concat. So the concat function adds 2 or more expressions together. Let's say I'll write select. I'll use the function concatenate. The function is actually concat, and I'm going to pass in my string values. Let's say India is in Asia. Let's run this and see our result. You can see here it has concatenated everything. Let us make it more readable. I'll give a space in between so that you can read it clearly. Now this is much more readable. India is in Asia, and if you want, you can give an alias name as well, as let's say merged. There you go. Now the same concat operation you can also perform on a table. I'm going to use the same students table. Let's say I want to return the student ID followed by the student name, and then I am going to merge the student name followed by a space followed by the age of the student, and I can give an alias as let's say name underscore age from my table, that is students. Let's see how this works. Okay, you see here the result is very clear. We have the student ID, the student name, and the concatenated column that we created, which was name underscore age, where we have the student name with a space followed by the age of the student. If I scroll down, you can see the rest of the results. Cool. Now moving ahead, let's see how the reverse function works in MySQL. So the MySQL reverse function returns a string with the characters printed in reverse order. So suppose I write select reverse. I'll use the same string again. Let's say I have India. Let's run it. You will see all the characters printed in reverse order. Again, you can perform the same operation on a table as well. Let's say I'll write select reverse, and I'll pass in the column as student name from my table, that is students. Let's run it. It gives you 20 students and all the names have been printed in reverse order. Okay. Now let's see what the replace function does. So the replace function replaces all occurrences of a substring within a string within a new substring. So let me show you what I mean. I'll write select replace. I'll pass in my input string, which is let's say orange is a vegetable, which is ideally incorrect. I'm purposely writing this so that I can replace the word vegetable with fruit. Okay, so what this replace function does is it is going to find where my word vegetable is within the string, my input string, and it is going to replace my word vegetable with fruit. Let's run it and see the output. There you go. Now this is correct, which is orange is a fruit. Alright. Now MySQL also provides some trim functions. You can use the left trim, right trim, and just the trim function. So let me show you how this left trim works. Left trim or L trim removes the leading space characters from a string passed as an argument. So say I write select, I'll use the left trim function, which is L trim, and then I'm going to purposely give a few spaces in the beginning of the string. I'll give a word, let's say India, and then I'll give some space after the word India, and see how the L trim works. If I run this, it gives me India, which is fair enough. But before that, let's first find the length of my string. So I'll use my length function here, and within this function I am going to find the length of my string, which has India along with some leading and trailing spaces. I'll paste this here, give a semicolon, and I'll run it. Okay, so the entire string is 17 characters long, or the length of the string is 17. Now say I use ltrim on my same string, what it returns me is India, and if I run length over it, you can see the difference, as in you can see how many spaces were deleted from the left of the string. You can see here, now it says 17, and I'm going to use ltrim. Let's see the difference. It gives me 12. The reason being, it has deleted 5 spaces from the left. You can count it, 1, 2, 3, 4, and 5. So 17 minus 5 is 12, which is correct. Similarly, you can use the rtrim function, which removes the trailing spaces from a string. Trailing spaces are these spaces. When you use left trim, it deletes the leading spaces, which is this. Now let me just replace ltrim with rtrim, which stands for right trim, and see the result. So the length is 10 now. The reason being, it has deleted 7 spaces from the right of the string. If you can count it, 1, 2, 3, 4, 5, 6, and 7. Cool. You can also use the trim function, which will delete both the leading and the trailing spaces. So here, if I just write trim and I'll run it, it gives me 5, because India is total 5 characters long, and it has deleted all the leading and the trailing spaces. Alright. There's also a function called position in MySQL. The position function returns the position of the first occurrence of a substring in a string. So if the substring is not found with the original string, the function will return 0. So let's say I'll write select position. I want to find where fruit is in my string, that is orange is a fruit. I'll give an alias as name. There's some error here. This should be within double quotes. Now let's run it and see the result. Okay, it says at the 13th place, or at the 13th position, we have the word fruit in our string, which is orange is a fruit. Now the final function we are going to see is called ASCII. So the ASCII function returns the ASCII value for a specific character. Let's say I write select ASCII of the letter small a. If I run this, it will give me the ASCII value, which is 97. Let's say you want to find the ASCII value of 4. Let's see the result. It gives me 52. Alright. In this session, we are going to learn two important SQL statements or clauses that are widely used, that is group by and having. First, we'll understand the basics of group by and having, and then jump into MySQL workbench to implement these statements. So let's begin. First, what is group by in SQL? So the group by statement or clause groups records into summary rows and returns one record for each group. It groups the rows with the same group by item expressions and computes aggregate functions for the resulting group. A group by clause is a part of select expression. In each group, no two rows have the same value for the grouping column or columns. Now below, you can see the syntax of group by. So first we have the select statement and then followed by the column names that we want to select. From, we have the table name followed by the where condition, and next we have the group by clause, and here we include the column names. Finally, we have the order by and the column names. Now here is an example of the group by clause. So we want to find the average salary of employees for each department. So here you can see we have the employees table. It has the employee ID, the employee name, the age of the employee, we have the gender, the date on which the employee had joined the company. Then we have the department to which each of these employees belong to. We have the city to which the employees belong to, and then we have the salary in dollars. So actually we'll be using this employees table on MySQL workbench as well. So if you were to find the average salary of employees in each department, so this is how your SQL query with group by clause would look like. So we have selected department and then we are using an aggregate function that is AVG, which is average, and we have chosen the salary column, and here we have given an alias name which is average underscore salary, which appears in the output. You can see here from employees, and we have grouped it by department. So here in the output you can see we have the department names and the average salary of the employees in each department. Now let me take you to my MySQL workbench where we will implement group by and solve specific problems. Okay, so I am on my MySQL workbench. So let me make my connection first. I'll enter the password. So this will open my SQL editor. So first of all, let me check the databases that I have. So I'll use my query that is show databases. Let's run it. Okay, you can see we have a list of databases here. I'm going to use my SQL underscore intro database. So I'll write use SQL underscore intro. So this will take us inside this database. I'll run it. Alright. Now you can check the tables that are present in SQL underscore intro database. If I write show tables, you can see the list of tables that are already present in this database. To do our demo and understand group by as well as having, let me first create an employee table. So I'll write create table employees. Next, I'll give my column name as employee underscore ID, which is the ID for each employee. I'll give my data type as integer and I'll assign employee ID as my primary key. Next, I'll give employee underscore name and my data type would be varchar. I'll give the size as 25. My third column would be the age column. Age would obviously be an integer. Then I have my gender column. I'll use character data type and assign a value of 1 or size of 1. Next we have the date of join and the data type will be date. We have the department column as well. This is going to be of varchar and 20 will be the size. Next we have the city column, which is actually the city to which the employee belongs to. And finally we have the salary column, which will have the salary for all the employees. Okay, now let me select and run this. You can see here we have successfully created our table. Now to check if our table was created or not, you can use the describe command. I'll write describe employees. You can see the structure of the table so far. Alright, now it's time for us to insert a few records into this employees table. So I'll write insert into employees and I'll copy paste the records which I have already written on a notepad. So let me show you. So this is my EMP notepad and you can see I have already put the information for all the employees. So let me just copy this and we'll paste it here. Alright, let me go to the top and verify if all the records are fine. Alright, so let's run our insert query. Okay, so you can see here we have inserted 20 rows of information, and now let's check the table information or the records that are present in our employees table. I'll write select star from employees. If I run it, you can see here I have my employee ID, the employee name, age, gender, we have the city, salary, and in total we have inserted 20 records. Now let me run a few SQL commands to check how the structure of our table is. Let's say I want to see the distinct cities that are present in our table. So I'll write select distinct city from employees. If I run this, you see here there are total 8 different cities present in our employees table. So we have Chicago, there's Seattle, Boston, we have New York, Miami, and Detroit as well. Now let's say you want to know the total number of departments that are present. So you can use distinct department. If I run this, alright, you can see we have 7 rows returned and here are the department names. So we have sales, marketing, product, tech, IT, finance, and HR. Alright, now let me show you another SQL command. Now this is to use an aggregate function. So I want to find the average age of all the employees from the table. So I can write select AVG, which is the aggregate function for average. Inside that I have passed my age column from employees. If I run this, so the average age of all the employees in our table is 33.35. Now say you want to find the average age of employees in each department. So for this you need to use the group by clause. I'll give a comment here. I want to find the average age in each department. So I'll write select department, comma, I'll write average of age from employees group by department. Now if I run this, you can see here we have our 7 departments on the left, and on the right you can see the average age of employees in each of these departments. Now you can see here in the output it says AVG of age, which is not readable, so I can give an alias name as average age. Alright, I can bring this down, and if you want you can round the values also. So you can round the decimal places. So I'll use a round function before the average function, and the round function takes 2 parameters. One is the variable and the decimal place you want to round it to. So if I run this, there you go. You can see here we have the average age of all the employees in each of these departments. Alright, now suppose you want to find the total salary of all the employees for each department. So you can write select department, comma, now I want the total salary, so I'll use the sum function and I'll pass my column as salary from employees group by department. Let's run this query. You can see here in the output we have the different departments, and on the right you can see the total salary of all the employees in each of these departments. Now here also you can give an alias name as total underscore salary. Let's run it again and you can see the output here. Alright, now moving ahead, you can also use the order by clause along with the group by clause. Let's say you want to find the total number of employees in each city and group it in the order of employee ID. So to do this, I can use my select query. I'll write select count of, let's say, employee ID, and I want to know the city as well, from employees group by city, and next you can use the order by clause. I'll write order by count of employee ID, and I'll write DESC, which stands for descending. If I run this query, you can see here on the left you have the count of employees, and on the right you can see the city names. So in Chicago we had the highest number of employees working, that was 4. Then we had Seattle, Houston, Boston, Austin, and the remaining also had 2 employees. So in this case we have ordered our result based on the count of employee ID in descending order. So we have the highest number appearing at the top and then followed by the lowest. Okay, now let's explore another example. Suppose we want to find the number of employees that joined the company each year. We can use the year function on the date of joining column. Then we can count the employee IDs and group the result by each year. So let me show you how to do it. So I'll write select. I'm going to extract year from the date of join column. I'll give an alias as year. Next, I'll count the employee ID from my table name, that is employees, and I'm going to group it by year, date of join. I give a semicolon. Alright, so let's run this. Great. You see here in the result we have the year that we have extracted from the date of join column, and on the right you can see the total number of employees that joined the company each year. So we have in 2005 there was 1 employee. Similarly we have in 2009 there were 2 employees. If I scroll down, you have information of other years as well. Now if you want, you can order this as well based on year or count. Okay. Now you can also use the group by to join 2 or more tables together. So to show you this operation, let me first create a sales table. So I'll write create table sales, and the sales table will have columns such as the product ID, which is going to be of integer type. Then we have the selling price of the product. Now this will be a float value. Then we have the quantity sold for each of the products. So I'll write quantity. Quantity will be of integer type. Next we have the state in which the item was sold, and state I'll put it as varchar and give the size as 20. Let's run this so that we'll create our sales table. Alright, so we have successfully created our sales table. Next we need to insert a few values to our sales table. So I have already written the records in a notepad. Let me show you. Okay, so here you can see I have my sales text file. Let me just copy these information. I'll just paste it on the query editor. Okay, now let me go ahead and run this insert command. Alright, so you can see here we have successfully inserted 9 rows of information. So let me just run it through what we have inserted. So the first column is the product ID column. Then we have the selling price at which this product was sold. Then we have the quantity that was sold and in which state it was sold. So we have California, Texas, Alaska. Then we have another product ID which is 123, and these are the states in which the products were sold. So let me just confirm with the select statement. I'll write select star from sales. If I run this, you can see we have successfully created our table. Okay. Now suppose you want to find the revenue for both the product IDs 121 and let's say 123, since we have just two product IDs here. So for that you can use the select query. So I'll write select product ID. Next, I want to calculate the revenue. So revenue is nothing but selling price multiplied by the quantity. So I'll use the sum function to find the total revenue, and inside the sum function I'll use my selling price column multiplied by my quantity column. I'll give this an alias name as revenue from my table name, that is sales. Finally, I'll group it by product ID. Let's run it. There you go. So here you can see we have the two product IDs 121 and 123, and here you can see the revenue that was generated from these two products. Alright. Now let's say we have to find the total profit that was made from both the products 121 and 123. So for that I'll create another table. Now this table will have the cost price of both the products. So let me create the table first. I'll write create table. Let's say the table name is C product, which stands for the cost price of the products. I'll give my first column as product ID. This will be an integer, and I'll have my second column as cost price. Cost price will have floating type values. Let's run this. So we have successfully created our product cost table. Now let me insert a few values into the C product table. So I'll write insert into C underscore product. I'll give my values for 121. Let's say the cost price was $270 for each, and next we have my product as 123, and let's say the cost price for product 123 was $250. Let's insert these two values. Okay. Next, we'll join our sales table and the product cost table. So this will give us the profit that was generated for each of the products. So I'll write select C dot product underscore ID, comma, I'll write sum S dot sell underscore price. Now here C and S are alias names. So if I subtract my cost price from the selling price, that will return the profit that was generated. I'll multiply this with s dot quantity, close the bracket. I'll give an alias name as profit from sales as S. So here S stands for the sales table. I'm going to use inner join C underscore product table as the alias name should be C, where S dot product underscore ID is equal to C dot product underscore ID. We are using product underscore ID because this column is the common column to both the tables. And finally, I am going to group it by C dot product underscore ID. Alright. So let me tell you what I have done here. So I am selecting the product ID. Next, I am calculating the profit by subtracting the cost price from the selling price, and I have multiplied the quantity column. I am using an inner join to connect my sales and the product cost table, and I am joining on the column that is product ID, and I have grouped it by C dot product ID. Let's run this. There you go. So here you can see for product ID 121, we made a profit of $1,100, and for product ID 123, we made a profit of $840. So now that we have learnt group by in detail, let's learn about the having clause in SQL. The having clause in SQL operates on grouped records and returns rows where aggregate function results matched with given conditions only. So now having and where clause are kind of similar, but where clause can't be used with an aggregate function. So here you can see the syntax of having clause. You have the select statement followed by the column names from the table name, then we have the where conditions, next we have the group by, finally we have having, and at last we have order by column names. So you can see here we have a question at hand. We want to find the cities where there are more than 2 employees. So you can see the employee table that we had used in our group by clause as well. So if you were to find the cities where there are more than 2 employees, so this is how your SQL query should look like. So we have selected the employee ID and we are finding out the count using the count function. Next we have selected the city column. From employees, we have grouped it by city, and then we have used our having clause. So we have given our condition having count of employee ID should be greater than 2. So if you see the output, we have the different city names, and these were the cities where the count of employees was greater than 2. Alright, so let's go to our MySQL workbench and implement how having works. So suppose you want to find those departments where the average salary is greater than $75,000. You can use the having clause for this. So let me first run my table, which is employees. If I run this, you can see we had inserted 20 rows of information, and the last column we had was salary. So the question we have is, we want to find those departments where the average salary is greater than $75,000. So let me show you how to do it. So I'll write select department, comma, I'll use the aggregate function that is average salary. I'll give an alias name as avg underscore salary from employees. Next we'll use the group by clause, and I want to group it by each department, and then I'm going to write my having clause. So in having clause, I'll use my condition that is having average of salary greater than $75,000. Let's run it and see the output. There you go. So here you can see there were total three departments in the company, that is sales, finance and HR, where the average salary is greater than $75,000. Okay. Next, let's say you want to find the cities where the total salary is greater than $200,000. So this will again be a simple SQL query. So I'll write select city, comma, I want to find the total salary, so I'll use the sum function and I'll pass my column as salary, as I'll give a alias name as total from employees group by city, and then I am going to use my having clause. I'll pass in my condition as having sum of salary greater than $200,000. Alright, so let's run this query. There you go. So the different cities are Chicago, Seattle and Houston, where the total salary was greater than $200,000. Now suppose you want to find the departments that have more than 2 employees. So let's see how to do it. I'll write select department, comma, this time since I want to find the number of employees, I'm going to use the count function. I'll write count star as employee underscore count or emp underscore count, which is my alias name, from employees. Next, I'll group it by department, having, I'll give my condition count star greater than 2. Let's run this. Okay, so you have departments such as sales, product, tech and IT, where there are more than 2 employees. Okay, now you can also use a where clause along with the having clause in an SQL statement. So suppose I want to find the cities that have more than 2 employees apart from Houston. So I can write my query as select city, comma, count star as emp count from employees, where I'll give my condition city not equal to Houston. I'll put it in double quotes since I don't want to see the information regarding Houston. I'll group it by city, having count of employees greater than 2. So if I run this query, you see we have information for Chicago and Seattle only, and we have excluded the information for Houston. Now you may also use aggregate functions in the having clause that does not appear in the select clause. So if I want to find the total number of employees for each department that have an average salary greater than $75,000, I can write it something like this. So select department, comma, count star as emp count from employees group by department, and in the having clause I'm going to provide the column name that is not present in the select expression. So I'll write having average salary greater than 75,000. This is another way to use the having clause. Let's run this. Alright, you can see we have department sales, finance and HR, and you can see the employee count where the average salary was greater than 75,000. Okay, so let me run you from the beginning what we did in our demo. So first we created a table called employee, then we inserted 20 records to this table. Next we explored a few SQL commands like distinct, then we used average, and finally we started with our group by clause, followed by looking at how group by can be used along with another table, and we joined two tables, that was sales and product cost table, to find out the profit. Then you learned how to use the having clause. So we explored several different questions and learned how to use having in SQL. In this session, we will learn about joins in SQL. Joins are really important when you have to deal with data that is present on multiple tables. I'll help you understand the basics of joins and make you learn the different types of joins with hands-on demonstrations on MySQL workbench. So let's get started with what are joins in SQL. SQL join statement or command is often used to fetch data present in multiple tables. SQL joins are used to combine rows of data from two or more tables based on a common field or column between them. Now consider this example where we have two tables, an orders table and a customers table. Now the order table has information about the order ID, which is unique here. We have the order date, that is when the order was placed. Then we have the shipped date. This has information about the date on which the order was shipped. Then we have the product name, which basically is the names of different products. We have the status of delivery, whether the product was delivered or not, or whether it was cancelled. Then we have the quantity, which means the number of products that were ordered. And finally we have the price of each product. Similarly, we have another table called customers, and this customer table has information about the order ID, which is the foreign key here. Then we have the customer ID, which is the primary key for this table. We also have the phone number, customer name and address of the customers. Now suppose you want to find the phone numbers of customers who have ordered a laptop. Now to solve this problem, we need to join both the tables. The reason being, the phone numbers are present in the customers table, as you can see here, and laptop, which is the product name, is present in the orders table, which you can see it here. So using a join statement, you can find the phone numbers of customers who have ordered a laptop. Now let's see another problem where you need to find the customer names who have ordered a product in the last 30 days. In this case, we want the customer name present in the customers table and the last 30 days order information, which you can get from the order date column that is present in the orders table. Okay, now let's discuss the different types of joins one by one. So first we have an inner join. So the SQL inner join statement returns all the rows from multiple tables as long as the conditions are met. From the diagram above, you can see that there are two tables, A and B. A is the left table and B is the right table. The orange portion represents the output of an inner join, which means an inner join returns the common records from both the tables. Now you can see the syntax here. So we have the select command and then we give the list of columns from table A, which you can see here is the left table, followed by the inner join keyword and then the name of the table, that is B, on a common key column from both the tables A and B. Now let me take you to the MySQL workbench and show you how inner join works in reality. So here I'll type MySQL. You can see I have got MySQL workbench 8.0 version installed. I'll click on it. So it'll take some time to open. Okay, I'll click on this local instance and here I'll give my password. Okay, so this is how an SQL editor on MySQL workbench looks like. So first of all, let me go ahead and create a new database. So I'll write create database. This is going to be my command, followed by the name of the database, that is going to be SQL_joins. If I give a semicolon and hit Ctrl Enter, this will create a new database. You can see here one row affected. Now you can check whether the database was created or not using show databases command. If I run it, here you can see I have SQL joins database created. Now I'll use this database, so I'll write use SQL underscore joins. Okay. Now to understand inner join, consider that there is a college, and in every college you have different teams for different sports such as cricket, football, basketball and others. So let's create two tables, cricket and football. So I'll write create table, and my table name is going to be cricket. Next, I'm going to create two columns in this table. The first column is going to be cricket ID. Then I'm going to give the data type as int and use the auto increment operator. I'm using auto increment because my cricket ID is going to be my primary key. Then I'm going to give the name of the students who are part of the cricket team, and for this I'll use varchar data type and give the length as 30. I'll give another comma and I'll assign my cricket ID as primary key. Within brackets I'll give cricket underscore ID. Cricket ID is nothing but a unique identifier for each of the players, like you have roll numbers in college. Okay, let me just run it. Alright, so we have successfully created our cricket table. Similarly, let me just copy this and I'll paste it here. I'll create another table called football. This will have the information of all the students who are part of the football team, and instead of cricket I am going to give this as football ID. Alright, and the name column will have the names of the students. I'll change my primary key to football ID. Alright, let me run this. Okay, so now we have also created our football table. The next step is to insert a few player names into both the tables. So I'll write my insert into command. First, let's load some data to our cricket table. So I'll write cricket and I'll give my name column followed by values, and here I'll give some names such as, let's say, Stuart. I'll give another comma. The next player I'll choose is, let's say, Michael. Similarly, I'll add a few more. Let's say we have Johnson. The fourth player I'll take is, let's say, Hayden. And finally we have, let's say, Fleming. Okay. Now I'll give a semicolon and run this. Okay, so let me just check if all the values were inserted properly. For this I'll use select star from table, that is cricket. If I run it, you can see I have created a table and have successfully inserted 5 rows of information. Now similarly, let's insert a few student names for our football table. So I'll change this to football, and obviously there would be students who will be part of both cricket and football team. So I'll keep a few repeated names. Let's say Stuart, Johnson, and let's say Hayden are part of both cricket and football team. Then we have, let's say, Langer, and let's say we have another player in the football team, that is Aston. I'll just run it. Okay, you can see there are no errors. So we have successfully inserted values to our football team as well. Let me just recheck it. I'll write select star from football. Alright, so we have 5 players in the football team as well. Okay, now the question is, suppose you want to find the students that are part of both the cricket and football team. In this case, you can use an inner join. So let me show you how to do it. So I'll write select star from cricket, as I'm using an alias name as C, which stands for cricket. Then I'm going to write inner join. My next table is going to be football as F, which is an alias name for the football table. Then I'm going to use the on command or operator, and then I'll give the common key, that is name here. So c dot name is equal to f dot name. So based on this name column from both the table, my inner join operation will be performed. So let's just run it. There you go. So Stuart, Johnson and Hayden are the only 3 students who are part of both the teams. Alright. Now you can also individually select each of the columns from both the tables. So let's say I write select c dot cricket underscore id, comma c dot name, comma f dot football underscore id, comma f dot name. From, I'll write cricket as C, inner join football as F, on C dot name is equal to F dot name. Now if I run this, you see we get the same output here as well. Alright. Now let's explore another example to learn more about inner joins. So we have a database called classic models. Let me first use classic models. I'll run this. Okay. Now let me just show the different tables that are part of classic tables. Alright. So here you can see there are tables like customers, there's employees, office, there's office details, orders, payments, products and product lines as well. Alright, so let me use my select statement to show what are the columns present in the products table. Okay, so this product table has information about different product names. You have the product code. Now this product code is unique here. We also have the product vendor, a little description about the product, then we have the quantity in stock, buying price and MSRP. Let's see what we have in product lines. If I run it, you see here we have the product line, which is the primary key for this table. Then we have the textual description for each of the products. This is basically some sort of an advertisement. Alright, now suppose you want to find the product code, the product name and the text description for each of the products. You can join the products and product lines table. So let me show you how to do it. I'll write my select statement and choose my columns as product code, then we have product name, and let's say I want the text description, so I'll write this column name. Okay, then I'll use from my first table, that is products, inner join product lines, I can use using the common key column, that is product line. Close the bracket, I'll give a semicolon, and if I run it, there you go. So you can see the different product codes, then we have the different product names and the textual description for each of the products. So this we did by joining the products table and the product lines table. Alright. Now suppose you want to find the revenue generated from each product order and the status of the product. To do this task, we need to join 3 tables, that is orders, order details and products. So first let me show you what are the columns we have in these three tables. We have obviously seen for the products table. Now let me show you for orders and order details table. So I'll write select star from orders. If I run it, you can see it has information about the order number, the date on which the order was placed. We also have the shipment date. We also have the status column, which has information regarding whether the order was shipped or cancelled. Then we have some comments column. We also have the customer number who ordered this particular product. Similarly, let's check what we have under order details. So I'll write select star from order details. If I run it, you can see it has the order number, the product code, quantity of each product, we have the price of each product, then we have the order line number. Okay, so using the product orders and order details, let's perform an inner join. So I'll write select o dot order number comma o dot status comma I need the product name, which I'll take from the products table. So I'll write p dot product name. Now here O, P are all alias name for the tables, orders, products, and I'll use OD for order details, comma. Since we want to find the revenue, we actually need to find the product of quantity ordered into price of each product. So I'll use a sum function, and inside the sum function I'll give quantity ordered multiplied by the price of each item. I'll use an alias as revenue. Then I'll use my from clause, from orders as O, inner join order details as I'll use an alias name as OD. On, I'll write O dot order number is equal to OD dot order number. I'll use another inner join, and this time we'll join the products table. So I'll write inner join products as P on P dot product code is equal to OD dot product code. And finally I'll use the group by clause and group it by order number. Alright, let me run this. Okay, there's some mistake here. We need to debug this. It says you have an error in your SQL syntax. Check the manual. Alright. Okay, I think the name of the tables is actually orders and not order. Alright, now let's run it. Okay, there's still some error. It says classic models dot product doesn't exist. So again, the product name is, the table name is products and not product. So let's run it again. Alright, there you go. So we have the order number, the status, the product name, and the revenue. This we got it using inner join from 3 different tables. Now talking about left joins, the SQL left join statement returns all the rows from the left table and the matching rows from the right table. So if you see this diagram, you can see we have all the rows from the left table, that is A, and only the matching rows from the right table, that is B. So you can see this overlapped region, and the syntax for SQL left join is something like this. So you have the select statement, and then you give the list of columns from table A, which is your left table. Then you use the left join keyword followed by the next table, that is table B, on the common key column. So you write a dot key is equal to b dot key. Okay. Now in our classic models database, we have two tables, customers and orders. So if you want to find the customer name and their order ID, you can use these two tables. So first let me show you the columns that are present in customers and orders. I think orders we have already seen. Let me first show you what's there in the customers table. Okay, so you can see we have the customer number, the name of the customer, then we have the contact last name, the contact first name, we have the phone number, then there's an address column. There are two address columns actually. We have the city name, the state, and we have other information as well. And similarly we have our orders table. So I'll write select start from orders. So I'll write select star from orders. If I run this, you can see these are the information available in the orders table. Okay, so let's perform a left join where we want to find the customer name and their order IDs. So I'll write select c dot customer name, or let's say first we'll choose the customer number, comma, then I want the customer name, so I'll write c dot customer name. Then we have the order number column which is present in the orders table, and let's say I also want to see the status. Then I'll give my left table, that is customers as C, left join, orders as O on C dot customer number equal to O dot customer number. Let's run it. Okay, again there is some problem. Alright, so the table name is customers. Let's run it. So there's another mistake here. This is customer number, so B is missing. Cool. Let me run it. Alright, so here you can see we have the information regarding the customer number, then the respective customer names, we have the order number and the status of the shipment. So if I scroll down, you'll notice one thing, there are a few rows you can see which have null values. This means for customer number 125 and for this particular customer name there were no orders. And similarly if I scroll down, you will find a few more null values. You can see here there are two null values here. For customer number 168 and 169 there were no orders available. Alright, now to check those customers who haven't placed any orders, you can use the null operator. So what I'll do is here I'll just continue with this. I'll use a where clause and write where order number is null. Now let me run this. Okay, so here you can see there are 24 customers from the table that don't have any orders in their names. Okay, now talking about right joins. So SQL right join statement returns all the rows from the right table and only matching rows from the left table. So here you can see we have our left table as A and the right table as B. So the right join will return all the rows from the right table and only the matching rows from the left table. Now talking about the syntax. So here you can see we have the select statement. Followed by the select statement, you will have the list of columns that you want to choose. From table A, right join table B on the common key column from both the tables. Alright. Now to show how right join works, I'll be using two tables, that is customers and employees. So let's see the rows of data that are present in the customer table first. So I'll write select star from customers. Let's run it. So here you have the customer number, the customer name, then we have the phone number, the address of the customers. You also have the country to which the customer belongs to, the postal code, and the credit limit as well. Similarly, let's see for the employees table. Here I'll change customers to employees. Let's run it. Okay, so we have the employee number, the last name, the first name, we have the extension, the email ID, the job title, and also reports to here means the manager. Okay, so based on these two tables, we'll find the customer name, the phone number of the customer, and the email address of the employee, and join both the tables, that is customers and employees. So let me show you the command. So I'll write select c dot customer name, comma, then we have c dot phone. I'll give a space here. Next, I want the employee number from the employee table, so I'll write e dot employee number, comma, e dot email from customers as C, right join employees as E on e dot, my common key column is employee number here, so I'll write e dot employee number is equal to C dot, we have sales representatives employee number, and I'm also going to order it by the employee number column. Okay, so you can see I have my customer name selected from the customers table, the phone number of the customer, then we have the employee number and the email address. So let me run it. Okay, there's some problem. Alright, so the table name is customers actually. Let's run it once again. There you go. So you can see here we have all the values selected from our right table, which is the employees table. You can see right join employees, which means your employees table is to the right, and then we have the customer name and phone numbers of the customers from the customer table, which is actually your left table. So you have a few employee numbers such as 1002, there's 1056, which don't have any customer name or phone numbers. Okay, so there's another popular join which is very widely used in SQL, known as self joins. So self joins are used to join a table to itself. So in our database we have a table called employees. Let me show you the table first. Alright, so here you can see we have the employee number, the last name, the first name of the employee, we have the email ID, and here if you see we have a column called reports to. Now this you can think of as the manager column. So the way to read is, for example, for employee number 1056, the manager is 1002. So if you check for 1002, we have Dane Murphy. Then if I scroll down, let's say for employee number 1102, for employee number 1102, the manager is 1056. So here you can see who is at 1056. You have Mary Patterson. Similarly, if I scroll down, let's say for employee number 1188, we have the manager as 1143. Now if I check the table at 1143, we have Anthony Bow. So the employee Julie Firelli reports to Anthony Bow. Alright, now suppose you want to know who is the reporting manager for each employee. So for that you can use a self join. So let me show you how to join this employees table. I'll write select, and then I'm going to use a function called concat. Within brackets I'll start with my alias name, that is m dot, then I'll write last name. I'm going to concat last name followed by a comma, then I'll have my first name. I'll close this bracket, and then I'm going to give my alias name, let's say manager, comma, next I'm going to concat the same last name and first name, and this time I'm going to use a separate alias, let's say E, which stands for employee. So I'll write E dot last name, comma, and within single quotes I'll give my comma, and then I'll write E dot first name. I'll close this bracket. I'll give an alias as, let's say, employee. From, I'll write employees as E, inner join employees as M on M dot, I'll use my common key column as employee number, so I'll write M dot employee number is equal to E dot, here I'm going to use the reports to column, and then I'll order it by, let's say, manager. Okay, now let's run this. There you go. So you have your two columns as manager and employee. So for employee Louis Bonder, the manager is Gerard Bonder. Similarly, if I scroll down, you have there are multiple employees reporting to this particular manager. Similarly, we have our manager as Anthony Bow, and we have different employees who are reporting to this particular manager, and so on. Alright, now moving ahead. Now let's see what a full join is. So SQL full outer join statement returns all the rows when there is a match in either left or right table. Now you must remember that MySQL Workbench does not support full outer join by default, but there's a way to do it. So by default, this is how the syntax of full outer join looks like. Now this statement will work on other SQL databases like Microsoft SQL Server, but it won't work on MySQL Workbench. I'll show you the right way of using full outer join on MySQL Workbench. So to show full outer join, I'm going to first use a left join, and then we'll also use a right join, and finally we'll use a union operator. So the union operator is used to combine the result set of two or more select statements. So first of all, let me write C dot customer name. So for this example, I'm using the customer table and the order table, comma, O dot order number. So I just want to know the customer name and the order number related to the customer. From, I have customers as C, left join, I'll write orders as O on C dot customer number is equal to O dot customer number. Let me just copy this, and after this I am going to use my union operator. So union operator is used to merge results from two or more tables. So basically this performs a vertical join. And next I am going to use my right join operation. So here instead of left join, I'll write right. Rest all looks fine. Let me just run it. There you go. So we have successfully run our full outer join operation. You can see we have the different customer names and the order that each customer had placed. Alright, so that brings us to the end of our demo session. So let me just run through whatever we did in this session. So first we created a database called SQL joins. Then we created two tables like cricket and football. Then we had inserted a few rows to each of these tables. Then we used this table to learn about inner join. Next, we used a database called classic models. It had multiple tables, so we explored all of these tables like products, there was product lines, orders, customers and employees, and learned how to use inner join, left join, self join, right join, as well as full outer join. In this video we will learn what is a subquery and look at the different types of subqueries. Then we'll learn subqueries with select statement followed by subqueries with insert statement. Moving further, we will learn subqueries with the update statement, and finally we look at subqueries with delete statement. All this we will be doing on our MySQL workbench. So before I begin, make sure to subscribe to the Simplilearn channel and hit the bell icon to never miss an update. So let's start with what is a subquery. So a subquery is a select query that is enclosed inside another query. So if I show you, this is how the basic structure of a subquery looks like. So here, whatever is present inside the brackets is called as the inner query, and whatever is present outside is called the outer query. So first, the inner query gets executed and the result is returned to the outer query, and then the outer query operation is performed. Alright, now let's see an example. So we have a question at hand, which is to write a SQL query to display department with maximum salary from employees table. So this is how our employees table looks like. It has the employee ID, the employee name, age, gender, we have the date of join, department, city and salary. Now to solve this query, my subquery would look like this. So I'll first select the department from my table, that is employees, where I'll use the condition salary equal to, and then I'll pass in my inner query, which is select max of salary from employees. So what this does is it will first return the maximum salary of the employees in the table. Then our outer query will get executed based on the salary returned from the inner query. So here the output is department sales has the maximum salary. So one of the employees from the sales department earns the highest or the maximum salary. If you see in our table, the employee is Joseph, who earns $115,000. Alright, and Joseph is from the sales department. Now let's see how this query works. So here we have another question, which is to find the name of the employee with maximum salary in the employees table. So this is our previous employees table that we saw, and to find the employee who has the maximum salary, my subquery would look something like this. So I'm selecting the employee name from my table, that is employees, where I'm using the condition salary equal to, and then I'm passing in my subquery or the inner query. So first I'm selecting the maximum salary. This will return a particular value, that is the highest salary from the table. And if you see our table, the highest salary is $115,000. So our query becomes select employee name from employees where salary equal to $115,000. So the employee name is Joseph here, and that's the output. Now if you want to break it down, here you can see first the inner query gets executed. So our SQL query will first execute the inner query that is present inside brackets, select maximum salary from employees. The result is $115,000, and then based on the returned result, our outer query gets executed. So the query becomes select employee name from employees where salary equal to $115,000, and that employee is Joseph. Alright, now we'll learn the different types of subqueries. So you can write subqueries using select statement, update statement, delete and insert statement. We'll explore each of this with the help of example on my MySQL workbench. So let's learn subqueries with the select statement. So subqueries are majorly used with the select statement, and this is how the syntax looks like. You select the column name from the table name, then you have the where condition followed by the columns that you want to pass, the operator, and inside that you have the subquery. So here is an example that we will perform on our MySQL workbench. So in this example, we want to select all the employees who have a salary less than average salary for all the employees. This is the output. So let's do this on my MySQL workbench. Alright, so let me log into my local instance. I'll give my password. Okay, so you can see I'm on my MySQL workbench. So let's start by writing our subquery using the select statement. Okay, so for this demo session, we'll be using a database that is Subqueries. You can see it here. I have a database called Subqueries. So I'll use this Subqueries database and we'll create a few tables as well. Okay, if I run it, now we are inside the Subqueries database. So let me just show you the tables that are present inside this database. I'll write show tables. If I run it, okay, there are two tables, employees and employees underscore B. We'll use this table throughout our demo session. Alright, now for our select subquery, we want to fetch the employee name, the department and the salary whose salary is less than the average salary. So we will be using the employees table. So let me first show you the records and the columns we have in the employees table. So I'll write select star from employees and run it. Okay, you can see here we have 20 rows of information. We have the employee name, the employee ID, age, gender, date of join, department, city and salary. So this is the same table that we saw in our slides. Okay, now for our subquery, I'll write select. I want to choose the employee name, the department and the salary. There should be a comma here instead of a period. Next, I'll give my table name, that is employees, where my salary is less than, and after this I'll start my inner query or the subquery. I'll write select average salary. So I'm using the AVG function to find the average salary of all the employees from my table, that is employees. If I give a semicolon and run this, you'll see the output. So we have total 12 employees in the table whose salary is less than the average salary. Now if you want, you can check the average salary. So the average salary is $75,350. Now the employees who have a salary less than the average salary, so these are the people. Alright, now moving back to our slides. Okay, now let's see how you can use subqueries with the insert statement. Now the insert statement uses the data written from the subquery to insert into another table. So this is how the syntax looks like. So you write insert into table name followed by select individual columns or star from the table, use the where clause, and then you give the operator followed by the inner query or the subquery. So here we will explore a table called products table. We are going to fetch few records from the products table based on a condition, that is the selling price of the product should be greater than $100. So only those records will fetch and put it in our orders table. Alright, so we are going to write this query on my MySQL workbench. So let's do it. I'll give my comment as update subquery. Alright, so first of all, let's create a table that is products. So I'll write create table products. Then we'll give our column names. The first column would be the product ID of type integer. Then we have the column as item or the product, which is of type varchar 30. Next we have the selling price of that product. The selling price will be of type float. And finally we have another column which is called the product type. And again, product type is of the data type varchar. I'll give the size as 30, close the bracket and give a semicolon. Now let's just run it. Okay, so we have successfully created our products table. Now let's insert a few records to our products table. So I'll write insert into products followed by values. I'll give 4 records. The first product ID is 101. The product is, let's say, jewelry. Then the selling price is, let's say, $800, and the product type is, it's a luxury product. Next, let's insert one more product detail. The product ID is 102. The product is, let's say, t-shirt. The price is, let's say, $100, and the product type is non-luxury. Next, I'll just copy this to reduce our task. We'll edit this. The third product's ID is 103. The product is laptop, and let's say the price is $1,300, and it's a luxury product. I'll paste again, and finally I'll enter my fourth product, which is, let's say, table, and the price is $400, and it's a non-luxury product. I'll give a semicolon, and we'll insert these 4 records to our products table. You can see we have inserted 4 records. Let's just print it now. So I'll write select star from products. If I run it, you can see we have our 4 products ready. Now we need to create another table where we are going to put some records from our products table. So that new table is going to be the orders table. So I'll write create table orders. Now it will have 3 columns. The order ID will be of type integer. Then we have product underscore sold. This will be of type varying character of size 30, and finally we have the selling price column. This will be of type float. Let's create our orders table. The table name should be orders, and there is some mistake here. Okay, you should close the brackets. Okay, let me run it. So we have our orders table ready. Now let's write our insert subquery. So I am going to insert into my table, that is orders, and I'll select the product ID, comma, the item, and the selling price or the sell price from my table, that is products, where I'll write product ID in. I'll write my inner query select prod ID or the product ID from products. Next, I'll give a where clause where the selling price is greater than $1,000. So let me tell you what I am going to do here. I am going to insert into my orders table the product ID, the item name, and the selling price from my products table, where the product ID has this condition. So let me first run this condition for you, which is select prod ID from products where the selling price is greater than 1000. If I run this, okay, there is some issue here. The column name is actually prod ID. Now let's run it again so that we can see the product IDs of the products which have a selling price greater than 1000. So it is 101 and 103. Now let's run the entire query. There is another mistake here. Let's debug the mistake. Now this should be product ID instead of product underscore in. Let's insert again. Alright, so we have successfully inserted 2 records to our table, that is orders. Now let's see the orders table. I'll write select star from orders. If I run it, there you go. So there were two products from our product table that were jewelry and laptop, which have a selling price greater than $1,000. So the selling price for jewelry was $1,800 and for laptop it was $1,300. So this is how you can use a subquery using the insert statement. Alright, now going back to our slides again. Alright, now let's see how you can use subqueries with the update statement. Now the subqueries can be used in conjunction with the update statement. So either single or multiple columns in a table can be updated when using a subquery with the update statement. So this is how the basic syntax of an update subquery looks like. So you write update table followed by the table name, you set the column name, you give the where operator, and then you write your inner subquery. So we are going to see an example where we will use this employees table, and using this employees table we will update the records of the salaries of the employees by multiplying it with a factor of 0.35 only for those employees which have age greater than 27. So we are going to use a new table called employees_b for this as well. So let's see how to do it. So I'll give my comment as update subquery. Before we see the subquery, let's see what we have in the table employees_b. This is basically a replica of the employees table. There you go. It has the same records that our employees table has. We are going to use both the employees table and the employees_b table to update our records. So I'll write update employees set salary equal to, let me bring this to the next line. I'll write set salary equal to salary multiplied by 0.35, where age in, then I'll write select age from my other table, that is employees_b, where age is greater than or equal to, let's say 27. Alright, so let me run through this query and tell you what we are going to do. So I'm going to update the records of the employees table specifically for the salary column. So I'm checking if the age is greater than 27, then we'll multiply the salaries of the employees with a factor of 0.35 in the employees table. Let me just run this, then we'll see our output. Okay, so it says 18 rows affected, which means there are total 18 employees in the table out of the 20 employees whose age is greater than 27. Now if you see, I'll write select star from employees. You can see the difference in the salaries. If I scroll to the right, you can see these are the updated salaries. Okay. Now if you check for employees who have an age less than or equal to 27, for example Marcus, whose age is 25, his salary is the same. We haven't updated his salary. Then if you see, if we have, okay, there is one more employee, Maya. We haven't updated the salary of Maya because the age is less than 27. Alright. Now let's go back to our slides again. As you can see, we got the same output on our MySQL workbench. Now let's explore how you can write subqueries with the delete statement. Now subqueries can again be used in conjunction with the delete statement. So this is how the basic syntax of a delete query using subquery would look like. You write delete from the table name, where clause, the operator value, followed by the inner query in within brackets. So here we are going to use the employees table, and what we are going to do is we'll delete the employees whose age is greater than or equal to 27. So let's see how you can do it. Alright, so I'll give my comment as delete subquery. So we'll follow the syntax that we saw. I'll write delete from my table name, that is employees. I'll write where age in, and then I'll start my inner query or the subquery. I'll write select age from employees underscore B, where age is, let's say, greater than equal to 32, or let's say the age is less than equal to 32. Close the bracket and I'll give my semicolon. Let me first run the inner query for you so that you get an idea of the employees who are less than 32 years of age. So there are 9 employees in the table who have an age less than equal to 32. So we are going to delete the records. If I run this, okay, it says 9 records deleted. Now let's print or display what we have in the employees table. If I run this, there you go. So if you see the age table, we have total 11 employees now, and all their ages are greater than 32 because we have deleted all those employees who had an age less than equal to 32. Okay, so let me show you from the beginning what we did. So first we used our subqueries database, then we used our employees table. So we started by looking at how you can use the subquery with a select statement. This should be insert instead of update. So we learned how to write an insert subquery. We use two tables, products and our orders table. Moving ahead, we saw how to write subqueries using the update command. So we updated the salaries of the employee by a factor of 0.35 for those who had an age greater than equal to 27. And finally, we saw how to use the subquery using the delete statement. So we deleted all those records for the employees whose age was less than equal to 32.
I wondered what those people with fancy charts on their computers are doing. They are probably business analysts. So what's a business analyst? Think of them as the Sherlock Holmes of the business world. They look at lots of information and figure out how to make companies run better. And guess what? It's a pretty cool job right now. Lots of companies are trying to hire these folks. Want to know how much they make? On average, about $85,000 per year. Some of them even make over $120,000. Not bad, right? But here's the thing. To be really good at this job, you need to know some special words. It's like learning the secret code of business. And in today's video, we are going to look at the 10 important words every business analyst should know. And by the time we are done, you will be talking like a pro. So let's start with a little story. Meet John. John works at a company and is always overwhelmed by all the data terms his colleagues use during meetings. So words like KPIs, data warehouse, and analytics were thrown around, and John often felt lost. He knew understanding these terms was crucial for his career growth, so he decided to dive into learning about business intelligence. John started by learning what business intelligence actually means. He discovered that BI involves strategies and technologies that help companies analyze and manage their data. For example, if he worked at Spotify, BI could tell him which songs are getting the most plays, when people listen the most, and even predict the next big hit. This realization made John see how powerful BI could be for making informed business decisions. Alright, so let's dive in and let's understand what business intelligence actually is. Imagine you're running a popular ice cream shop, and business intelligence is like having a super smart helper that tells you everything about your business. Cool, right? So what exactly is business intelligence? It's all the tricks and tools companies use to understand their data better. It helps them make smart choices based on facts, not just guesses. For example, let's say you use a tool like Power BI in your ice cream shop. It might show you which flavors sell the most on hot days, what time your shop is busiest, and which toppings are most popular with kids. This info helps you make smart decisions like stocking up on popular flavors or hiring extra staff for busy times. Business intelligence is super important because it turns boring numbers into useful information that helps businesses grow and succeed. It's like having X-ray vision for your company. Next, let's talk about data visualization. So data visualization is the graphical representation of information and data. By using visual elements like charts, graphs, and maps, data visualization tools provide an accessible way to see and understand trends, outliers, and patterns in data. For example, a bar chart showing the most popular pizza toppings in a delivery app. This is crucial for presenting data in an easy to understand format. Moving on, we have analytics. So analytics involves the systematic computational analysis of data. For example, using analytics to understand which times of day are busiest for a pizza delivery app. This term is important because it helps in making sense of large amounts of data and aids in decision making. Next up is KPI, that is key performance indicator. So a KPI is a measurable value that demonstrates how effectively a company is achieving key business objectives. For example, tracking the number of pizzas sold each month as a KPI to measure business performance. KPIs are essential for measuring performance and progress towards strategic goals. Now let's discuss data warehouse. So a data warehouse is a centralized repository for storing large volumes of structured data from multiple sources. For example, storing customer data from different gym branches in one place for analysis. It is used for reporting and data analysis and is a core component of business intelligence. Data warehouses are important for consolidating data from different sources and making it available for analysis. Next, we have database. So database is an organized collection of data generally stored and accessed electronically from a computer system. For example, a database storing member records for a gym. Databases are foundational for storing and managing data efficiently and are critical for any business intelligence processes. Moving forward, let's introduce data mining. So data mining is the process of discovering patterns and knowledge from large amounts of data. For example, a gym analyzing member attendance to identify the most popular class times. Data mining is important for extracting useful information from large data sets. Next, let's talk about dashboard. So dashboard is a business intelligence tool that allows users to track key metrics and KPIs. For example, a dashboard for a gym showing daily attendance, most used equipment, and membership growth. It provides a visual representation of data and helps in monitoring performance at a glance. Dashboards are crucial for real-time data monitoring and decision making. Next up is reporting. Reporting refers to the process of organizing data into informational summaries to monitor how different areas of a business are performing. For example, a monthly financial report summarizing income and expenses for a gym. Reports are essential for tracking progress, identifying trends, and making informed decisions. Finally, let's discuss SQL, that is Structured Query Language. So SQL is a standard programming language for managing and manipulating databases. For example, writing an SQL query to retrieve all gym members who joined last month. It is used to query, insert, update, and modify data. SQL is fundamental for anyone working with databases and business intelligence tools. Remember, whether you are running a multi-million-dollar corporation or a neighborhood lemonade stand, these BI tools and concepts can help you make smarter decisions and grow your business. They turn raw data into valuable insights, helping you understand your customer better, optimize your operations, and stay ahead of the competition. So with that, guys, we have come to the end of this session. I hope this video has helped demystify some key business intelligence terms for you. If you found this video helpful, don't forget to give it a thumbs up and subscribe to our channel for more business and tech insights. If you have questions about BI or want to share your opinion, you can comment down in the comment section below.
So let's start with what is normalization. Normalization in DBMS is a method used to organize data within database to reduce repetition. By breaking down large data sets into smaller, more manageable tables and ensuring these tables are properly related, normalization helps prevent issues like data redundancy. Data redundancy means the unnecessary repetition or duplication of data within a database. For example, when a same piece of data is stored in multiple places, it can lead to inconsistencies and take up more storage space than needed. For example, data redundancy before normalization. You can see the table mentioned above, where we have order ID, customer name, customer address, product, and quantity. You might see some of the data which is being repeated again and again. In the above table, the customer address for John Doe is repeated 3 times. Let's suppose if John Doe moves to a new address, every occurrence of his address in the table must be updated. If any instance is missed during the update, it leads to inconsistencies and errors can occur in the database. The solution is reducing the redundancy through normalization. Let's check it out how. So you can see this is the normalized table we have created. First is the normalized customer table and then we have the order table. So what are the benefits of normalization? The address for John Doe is stored only once in the customer table. If John Doe's address changes, it needs to be updated in one place, ensuring consistency through the database. This reduces the risk of errors and maintains data integrity. The process involves multiple steps that transform data into a tabular format, removing duplicates and establishing clear connections between different tables, making the database more efficient and reducing problems like errors during data insertion, updates, or deletion. Let's now discuss the types of DBMS normal forms. Normalization rules are categorized into different normal forms. The first one is 1NF. For a table to be in first normal form, it must satisfy the 4 rules. Single-valued atomic attributes. Each column should contain only one value per row. This means that there should be no repeating groups or arrays within a single column. Same domain values. All values stored in a specific column should be of the same data type or domain. For example, if a column is meant to store dates, all values in that column should be dates. Then we have unique column names. Each column in the table should have a unique name. This ensures clarity and avoids confusion when referring to a specific column. Then we have order of data, which doesn't matter. The order in which rows are stored in the table should not affect the data or its integrity. Let's check the example of the first normal form. Consider the following unnormalized table: customer ID, customer name, and the phone numbers. As you can see, the phone numbers are repeated twice. The problems with the original table is the non-atomic values. The phone numbers column contains multiple phone numbers separated by commas, which violates the atomicity rule of 1NF. Converting to first normal form, to bring this table into 1NF, we must ensure that each column contains only atomic value. This involves splitting the rows where there are multiple phone numbers. As you can see, we have splitted the data. Each row now has a single phone number, ensuring that the phone number column contains atomic value. Same domain names, all the values in the phone number column are consistent in format and type. All are phone numbers. Then we can see that the unique column names, the columns customer ID, customer name, phone number, which has unique name satisfying the requirement. Order of data. The order in which the rows appear does not matter, as the data's meaning and integrity are preserved. By applying these rules, the table now conforms to the first normal form, eliminating any redundancy related to the phone numbers and ensuring data is stored in a more organized and efficient manner. Let's go through each of these database normal forms step by step with simple examples to help you grasp the concepts more easily. Let's talk about the second normal form. For a table to be in second normal form, it must satisfy the following condition. Number 1, it must be in 1NF. Number 2, no partial dependency. Every non-key attribute should be fully dependent on the entire primary key, not just part of it. This rule applies primarily to tables with composite primary keys. Example of second normal form is, consider the following table that is in 1NF. The order ID, product name, quantity, and the supplier name. The problems with this table is that the partial dependency. The product name and the supplier name depend only on product ID, not the entire primary key, which is order ID and product ID. This violates 2NF. Converting to second normal form, to bring the table into 2NF, we separate the data into 2 tables to remove partial dependencies: order table and the product table. No partial dependency in the order table. Quantity is fully dependent on both order ID and product ID. In the product table, product name and supplier name are dependent only on the product ID. This ensures that each non-key attribute is fully dependent on the primary key, bringing the tables into 2NF. Let's now talk about the third normal form, 3NF. For a table to be in third normal form, it must satisfy the following condition. Number 1, it must be in 2NF. Number 2, there should be no transitive dependency where non-key attributes depend on other non-key attributes rather than the primary key. Let's check out the example of a third normal form. Consider the following table that is in 2NF. The problems with the 2NF table is that the transitive dependency, the instructor name is dependent on the course name, which is not directly on student ID or course ID, and this violates 3NF. So how do we convert this into 3NF? To achieve 3NF, we split the table to remove the transitive dependency, student course table and course table. No transitive dependency. Now, the student course table, there are no non-key attributes depending on other non-key attributes. The course table stores the course and instructor information separately. This structure eliminates transitive dependency, ensuring the tables conform to 3NF. Let's now talk about the Boyce Codd normal form, which is BCNF. BCNF is an extension of the third normal form, 3NF. A table is in BCNF if it is in 3NF, and for every functional dependency, A implies to B, A should be a super key. Let's check out the example of a Boyce Codd normal form BCNF. So you can see this table here consisting of employee ID, department, and the manager. The problem with this table is that the BCNF violation. In this table, department determines manager, but department is not a super key, since employee ID is the primary key. This violates BCNF. So how do we convert this to BCNF? To achieve BCNF, we split the table to ensure that every determinant is a super key. As you can see, the employee table and the department table. The super key requirement in the employee table, employee ID is the primary key, and in the department table, department is now the primary key. The decomposition ensures that every functional dependency is satisfied by a super key, meeting the requirements of BCNF. Let's now talk about the fourth normal form, which is 4NF. A table is said to be in 4NF if it is in BCNF and has no multi-value dependencies. So let's consider an example of a fourth normal form. Consider a table where an employee can have multiple skills and work on multiple projects. As you can see, the employee ID, skill, and the project. The problem with this table is that it is multi-value dependency. An employee skill is independent of the project, but both are stored in the same table. This leads to multi-value dependency, violating 4NF. So, in order to achieve 4NF, we separate the skills and the projects into different tables, the employee skill table and the employee projects table. And now you can see that no multi-value dependency. By separating the skills and the projects, we eliminate multi-value dependencies, ensuring the table conform to 4NF. Let's now talk about the fifth normal form, the employee skill table and the employee projects table. So as you can see that no multi-value dependency is there. By separating the skills and the projects, we eliminate multi-value dependencies, ensuring the tables conform to 4NF. Now let's talk about the fifth normal form, which is 5NF. A table is said to be in fifth normal form if it is in 4NF and cannot be decomposed into any smaller tables, losing information, also known as joint dependency. Let's consider an example of a fifth normal form. This is a table here that records the relationship between suppliers, parts, and a project. The problem with this table is that the joint dependency. The table has a complex relationship between suppliers, parts, and projects that can be decomposed further. So how do we convert this into fifth normal form? In order to achieve 5NF, we break the table into smaller related tables, the suppliers part table and the suppliers project table, also parts project table. Eliminating joint dependency, by decomposing the table into 3 smaller tables, we remove the complex relationship and eliminate the joint dependency, ensuring the tables conform to 5NF.
Imagine you are trying to figure out what most people in your neighborhood love to eat for dessert. You could ask everyone, right? But how do you make sense of all of these answers? That's where statistics comes in. It's like your personal data detective, helping you gather, organize, and analyze all the information to spot patterns and trends. With statistics, you can easily discover if most people love ice cream or if brownies are the hidden favorite. All about turning numbers and facts into useful insights, helping you make smarter decisions and understand the bigger picture. Hello guys, welcome back to Simplilearn's YouTube channel. And today I will walk you through the basic understanding of descriptive statistics, inferential statistics, frequency statistics, and kurtosis statistics, and more. Then I will take you through the differences among the various types. By the end of the video, you will know all you want to know about statistics and its types. Without any further delay, let's get into the video. First things first, let us understand what statistics actually is. Statistics is a branch of mathematics that help us collect, organize, and analyze data, understand patterns, trends, and make decisions. It's like having a big group of information and breaking it down to learn something useful. For example, if we survey 100 people about their favorite fruit, statistics help us figure out what most people like, what fruit is least liked, and how confident we are about these results here. After we have a basic idea of statistics, let us get into the various types of statistics. The first one is descriptive statistics. Descriptive statistics is a branch of statistics that focuses on summarizing and describing the main features of a dataset. This is further divided into measures of central tendency, measures of spread, and data distribution. Let's start with measures of central tendency, and this is further divided into three types. The first one is mean, the average of all data points. The second one is median, the middle value when data is arranged in order. The third one is mode, the most frequently occurring value. Let's break down the measures of central tendency, mean, median, and mode with an example. Imagine you have the following scores from a maths test taken by 7 students: 72, 85, 91, 89, 85, 76, and 90. Now you want to calculate the mean. Now, to calculate the mean, you have to add up all the scores and divide by the number of students. Therefore, the mean is 84. It means the average scores of the students is 84. Now, moving on to find the median. To find the median, we need to take the same example and we have to arrange the scores in ascending order. The median is the middle value, so in this case, the middle value is 85, since it is the fourth number in a list of 7. So, half of the students scored above 85 and half scored below 85. Now, moving on, the next is to calculate the mode. The mode is a score that appears most often. So, we take the same example and we see that 85 occurs twice more than any other score. So, the most common score in the test is 85. Now, moving on to the next, that is the measures of spread. Unlike central tendency, which tells you whether the data is centered, spread tells you how scattered the data is. It has three components: range, variance, and standard deviation. Range, it is the difference between the highest and the lowest values in the set. And variance, it measures how much each score deviates from the mean. And standard deviation, it is the square root of variance. Let's use an example to understand measures of spread, range, variance, and standard deviation, which help us understand how spread out or dispersed the data is. Consider the test scores of 5 students. Now, we want to find the range. Therefore, the range is the difference between the highest and the lowest values in the dataset. That is, 85 minus 65 is equal to 20. The scores span a range of 20 points from 65 to 85. Now, moving on, we want to find the variance for the same example. The variance measures how much each score deviates from the mean on average squared. First, we calculate the mean. So, to calculate the mean, we take the total of the scores divided by the total number of scores, and that is equal to 75. Next, we find the squared differences from the mean for each score. And here it is. 65 minus 75 whole square is equal to minus 10 whole square, and that is equal to 100. And in this way, we perform the same for each score. Now, the sum of these square differences divided by the number of data points is the variance. And that is taking the total of the squared differences divided by 5, that is equal to 50. The variance is 50, meaning that on average the square differences from the mean are 50. Now, moving on to find the standard deviation. The standard deviation is the square root of the variance. It tells us how spread out the data is in the same units as the original data. The standard deviation is the root over of 50, that is approximately equal to 7.07. Now, moving on, the third measures of division is data distribution. Let us use an example to explain data distribution, which tells us how data points are spread or organized across a range of values. Imagine you have the following test scores for 20 students. One way to understand data distribution is by creating a histogram. The histogram groups the scores into ranges or bins and shows how many scores fall into each range. For this dataset, we could create bins like 50 to 60, there are 3 students, 61 to 70, there are 7 students, and 71 to 80, we have 5 students. And in this way, 81 to 90, we have 3 students, and 91 to 100, we have 2 students. Now, moving on to the normal distribution, the second one under the data distribution. In some cases, data follows a normal distribution which forms a bell shaped curve, and this means most data points are around the mean with fewer data points as you move away from the mean in either direction. And normal distribution curve, it means most data points are around the mean with fewer data points as you move away from the mean in either direction. In a normal distribution, the mean, median, and mode are the same. Data is symmetrically spread around the center. Now moving on, in our example, the scores are somewhat concentrated around 70 to 80, but the distribution is not perfectly normal because there are more students scoring higher, that is the right skew. Therefore, skewed distribution. Skewed distribution, if a data set is not symmetrical, we have skewed distribution. And that is further divided into two. The right skew, that is the positive skew, and the left skew, that is the negative skew. In right skew, more data points are on the lower side with fewer higher values. And in the left skew, more data points are on the higher side with fewer low values. Moving on, in our test score example, we have a slightly right skew distribution because there are more students with lower scores, that is to 55 to 70, compared to higher scores, that is 90 to 100. And this is known as right skew distribution. Now, moving on to the second type of statistics, that is inferential statistics. It uses sample data to make predictions and generalizations about a larger population, allowing researchers to draw conclusions beyond the immediate dataset. Inferential statistics comprises several techniques for drawing conclusions. Here are some common types. Hypothesis testing. Second one is confidence intervals, and the third one is regression analysis. Now moving on to hypothesis testing. Hypothesis testing is a statistical method used to determine whether there is enough evidence in a sample of data to support a specific claim about a population. Let's work through the process of testing whether a new teaching method improves student test scores, breaking it down step by step with some explanations to make it easier to follow. Step number 1 is hypothesis. We always start by stating what we want to test. In this case, we want to see if the new teaching method helps students score better compared to the traditional one. To do this, we set up two hypotheses. H0, that is the null hypothesis, and that is the average test score with the new method is equal to 75. This means that the new method has no impact and there is no improvement in the test scores. H1, that is the alternative hypothesis, the average test score with the new method is greater than 75. This suggests that the new method does improve test scores. In simple terms, we are trying to figure out if the new method makes any difference compared to what we normally expect, which is a score of 75. Now moving on to the next step, that is significance level. Next, we need to decide how confident we want to be in our conclusion. The significance level helps us measure this. It tells us the probability of mistakenly rejecting the null hypothesis when it's actually true. Type 1 error. A common choice for this significance level is 0.05 or 5%. This means we are willing to accept a 5% chance of making a mistake by rejecting the null hypothesis when it is true. So we said alpha is equal to 0.05. Step 3. Collect data. Now we need some actual data to test. Let's say we taught 30 students using the new method and their average test score came out to be 78. This is our sample data and we will compare it to the population mean, which is 75, the traditional method score. Now moving on to the next step, that is perform statistical test, the t-test. With the data in hand, we need to perform a statistical test. For this test, we will use a t-test which will help us compare the sample mean 78 to the population mean 75. The t-test checks if the difference between the two means is significant or if it could just be due to random chance. Moving on to the next step, that is the p-value. The p-value from the t-test is the number that tells us the probability of getting the sample data if the null hypothesis is true. Let's say the t-test gives us a p-value of 0.03. This means there is 3% chance of seeing this level of improvement if the new method doesn't actually improve scores. Now moving on to the last step, that is decision. Now we compare the p-value to our significant level alpha. If the p-value is smaller than 0.05, it means the results are statistically significant and we can reject the null hypothesis. In our case, the p-value is 0.03, which is less than 0.05. So we reject the null hypothesis. Now moving on to the second part, that is confidence interval. A confidence interval is a range that tells us how sure we are about an estimate from sample data. It gives a range of values whether the true member likely false. For example, suppose you survey 100 men in a city to estimate the average height. The average height from your sample is 175 centimeter and the standard deviation is 10 centimeter. You want to calculate 95% confidence interval to estimate the true average height of all men in the city. Now let's move on to the steps. Sample mean. The sample average is 175 centimeter. The standard error is calculated as 10 by root over of 100, that is equal to 1. Now, the confidence interval formula for a 95% confidence level use the critical value 1.96. The confidence interval is 175 plus minus 1.96 into 1. That is equal to 175 plus minus 1.96. The result, the 95% confidence interval is 173.04, 176.96. You can be 95% confident that the true average height of all men in the city is 173.04 centimeter and 176.96 centimeter. Now moving on to the third one, that is regression analysis. Regression analysis is a way to understand how one thing affects another. For example, if you own a shop and want to know if spending more on advertising increases your sales, you can use regression analysis. In this case, advertising spending is a thing you control, that is the independent variable, and sales is what you want to predict. By analyzing the past data, regression helps finding a pattern or relationship. For example, you might discover that for every $100 you spend on advertising, your sales increase by $200. This means you are positive relationship between advertising and sales. Now, if you plan to spend $500 on advertising, you can predict an increase in the sales by applying that relationship. Regression analysis gives you a formula or model to make such predictions based on the pattern you identified. In short, regression helps you logically predict how changes in one factor affect another. Next, I will be talking about is frequency statistics. In statistics, frequency refers to how often something occurs in a dataset. It simply counts how many times each value or event appears. Frequency is useful for understanding the distribution or pattern of data. Let's say you surveyed 10 people about their favorite food and the results were 4 people chose apples, 3 people chose bananas, 2 people chose oranges, and 1 person chose grapes. Here's how frequency works. Apples have a frequency of 4 as 4% chose it. Bananas have a frequency of 3, oranges have a frequency of 2, and grape has a frequency of 1. In this simple example, frequency helps you see that apples were the most popular fruit choice, while grapes were the least popular. Last but not the least, let's talk about kurtosis statistics. Kurtosis is a statistical term that describes the shape of the distribution of data, especially how the data is concentrated in the tables. It helps us understand if the data has more or fewer extreme values compared to a normal distribution. It is further divided into high kurtosis and low kurtosis. High kurtosis has more extreme values, and in low kurtosis, the data has fewer extreme values. In short, high kurtosis means more extreme heights, while low kurtosis means more consistent, evenly spread heights. By now, you must be curious to know about the differences among all the types of statistics. So here we go. Differentiating them on the basis of purpose. Descriptive statistics summarizes the main features of a dataset, for example, mean, median, and standard deviation. Inferential statistics makes predictions or generalizations about a population based on sample data. Frequency statistics counts when specific values or events occur in the dataset. Kurtosis describes the shape of the distribution, focusing on the tails and extreme values, differentiating them on the basis of data focus. Descriptive statistics deals with the entire dataset at hand. Inferential statistics uses a sample to infer conclusions about a larger population. Statistics focuses on the frequency of individual values or categories. Kurtosis focuses on whether the data has many or few extreme values. Now differentiating them on the basis of common metrics. In descriptive statistics is the mean, median, mode, and standard deviation and range. In inferential statistics, it is hypothesis testing, confidential intervals, regression analysis. In statistics, it is frequency counts, frequency tables, histograms, bars, and charts. In kurtosis value, high kurtosis is equal to more extreme values and low kurtosis is equal to fewer extremes. Now, differentiating on the basis of complexity. Complexity in descriptive statistics is simple and straightforward, summarizes the observed data, and in inferential statistics it is more complex, and in statistics it is simple counting and displaying of occurrences. Kurtosis requires statistical analysis to determine the distribution's tailedness. Now finally, differentiating them on the basis of visualization. Descriptive statistics, it is the box plots, pie charts, and summary tables. Inferential statistics, it is confidence intervals, regression lines, p-values, and more. And in statistics, it is bar charts, histograms, frequency tables. And kurtosis, it is histograms, distribution plots to visualize outliers. So here is a question for you guys. I hope everyone will comment your answers in the chat section and let's see how many of you really understood the topic. So the question is, which of the following is not a measure of central tendency? And the options are mean, median, mode, and standard deviation. Participate in the quiz and I hope to see your answers in the comment section. We will reply to whoever provides the correct answer and the wrong answers will be corrected for sure. I will provide you 1 minute to write your answers in the comment section.
Imagine having the power to transform chaos into clarity in today's data-driven world. That's exactly what ETL, which is extract, transform, load, let you do. Picture this data pouring in from all the direction, databases, apps, cloud systems, and just with few smart moves, you can transform it into clean, organized insights ready to fuel big businesses' decisions. Learning ETL is like becoming a data wizard, pulling together scattered pieces and making them work like magic. And here's the exciting part. ETL is an in-demand skill that can open doors to endless opportunities in some of the fastest growing fields out there. Today, I'll walk you through what ETL is and why is it such a game changer in today's data-driven world. I'll break down a real-world scenario to show you how things work with and without ETL, explore popular ETL tools, and wrap up with the common challenges businesses face when implementing ETL. So buckle up, by the end you will have a solid grasp of ETL and why it matters a lot. Without causing any further delay, let's get into the video. First things first, let us understand what ETL is. ETL basically stands for extract, transform, and load. It is a process which is used in data management to help businesses collect data from various sources, clean and organize it, and then store it in a central location like a database or data warehouse. First, data is extracted from different systems or files, then it is transformed by cleaning, filtering, and formatting it to ensure it's consistent and ready for use. Finally, the data is loaded into a system where it can be easily accessed for analysis or reporting. ETL is essential for companies to turn raw data into useful insights that support better decision making. So after we have basic ideas on ETL, let us now understand why is it so important to understand ETL in today's world. So understanding ETL is necessary in today's world because businesses rely more than ever on data to make informed decisions, improve operations, and stay competitive. With data coming from so many different sources, websites, apps, social media, and many more, ETL provides a way to gather, clean, and organize all this information efficiently. Without ETL, data would remain messy, inconsistent, and difficult to use, making it harder for businesses to extract valuable insights. In a data-driven world where quick and accurate decisions are critical, knowing how ETL works helps companies unlock the full potential of their data for growth, innovation, and success. To make sure you understand better about ETL, let us understand it with the help of a real-world example. Let's imagine you're running an online store that sells clothes. You have data coming from multiple sources: sales data from your website, customer reviews from social media, and inventory details from your warehouse system. Now you want to analyze this data to figure out what products are selling the most, which customers are returning, and what items need restocking. Here's what happens with and without ETL. With the help of ETL, you collect and extract all the sales data from your website, customer feedback from social media, and inventory information from the warehouse system. The data is cleaned and organized, duplicate entries are removed, different formats are standardized, and any missing or incorrect data is fixed. You also combine all this data into a single format that's easy to work with. The cleaned, ready-to-use data is loaded into a central system like a data warehouse. Now you can analyze everything in one place. Whether you want to know which products are trending, who your most loyal customers are, or what inventory needs to be restocked, you can quickly generate reports and gain insights in real time. Thanks to ETL, you can now have a clear, organized view of your entire business. You can make informed decisions, spot trends, and act fast. Now imagine the same scenario but without ETL. Your sales data is in one system, customer reviews are in another, and inventory details are stored separately. The data is messy, some formats don't match, and there is duplicate entries. Combining all this data manually is time-consuming and error-prone. Every time you need a report or insight, you have to spend hours or even days pulling the data from different sources, cleaning it up and organizing it by yourself. By the time you figure which products are selling the most, the trend might already be over. Without ETL, you're just stuck doing manual work, and important insights are delayed or missed. Decision making becomes slower, and you lose out on opportunities to optimize your business. In short, ETL saves times, reduces errors, and gives you the power to make faster, smarter decisions, some things that's crucial for any businesses in today's fast-paced world. By now, you're probably wondering which ETL tools are trending and what companies are using to manage their massive data workloads. Well, the wait is over. ETL tool can be grouped into two main types. First, we have traditional ETL tools, and second, we have cloud-based ETL tools. Each serves a unique purpose in handling and transforming data, depending on the needs of their business. Let's dive into what makes each business stand out. Let's talk about the first, old traditional ETL tools. These tools have been around for a while and are widely used in on-premise systems. They are trusted by enterprises for handling large-scale complex data transformation and integration tasks. Some of the common tools used are Informatica Power Center, which is a strong ETL tool for big companies known for handling large data efficiently. Then we have Microsoft SSIS, a popular ETL tool that works well with Microsoft SQL Server for data tasks. Then we have Talon, which is an easy-to-use open-source ETL tool, which is great for cloud and big data projects. Next, we have Pentaho, with a simple ETL tool with a drag-and-drop interface for transforming data. IBM InfoSphere Data Stage is a powerful tool for integrating large data systems into big organizations. Talking about Oracle Data Integrator, which is fast, reliable ETL tool made for working with Oracle databases. Now that we have discussed the old traditional ETL tools, let's now move on to the cloud-based ETL tools. Unlike traditional tools, they are designed for cloud-based environments, offering scalability, flexibility, and integration with cloud data warehouses. They are perfect for businesses transitioning to or already operating in the cloud. Some of the common tools used are AWS Glue, which is a serverless ETL tool by Amazon that makes it easy to prepare and load data for analysis. Then we have Google Cloud Data Flow, which is a real-time ETL tool for processing large data sets on Google Cloud. Fivetran is a simple automated ETL tool that quickly sets up data pipelines with minimal effort. Next, we have Matillion, which is a cloud-native ETL tool that integrates easily with platforms like AWS, Azure, and Google Cloud. Stitch is a straightforward ETL tool that helps move data to your data warehouse quickly. Hevodata is a no-code ETL tool which is designed for automating data integration across cloud platforms. Let us now see some common challenges businesses face while implementing ETL processes. At first, we have data quality. It's hard to make sure that the data collected from different sources is clean, accurate, and consistent. Bad data can lead to wrong decisions. Then we have scalability. As businesses grow and collect more data, it becomes tough to manage larger amounts of data without slowing things down. Real-time processing. Many ETL systems work with batches of data, but today businesses often need data processed instantly, which makes things more complicated. The next challenge is integration with different systems. Getting data from many different platforms like databases, apps, or files and making it work together can cause compatibility issues. Error handling. While something goes wrong in the ETL process, like a failed data load, it can be tricky to detect and fix those errors quickly. Then we have data security. Keeping sensitive information safe during the ETL process and following legal requirements like GDPR can be challenging, especially when using cloud services. ETL can throw a few curveballs your way, but don't let that freak you out. Think of those challenges as stepping stones to turn your raw data into absolute gold. Once you have nailed down a smooth ETL process, the payoff is incredible. Faster decisions, sharper insights, and a major data-driven advantage over your competitors. And yes, it takes a bit of effort, but once you have conquered the ETL game, your data will become one of the most powerful business's assets.
So currently I am on my MySQL workbench. Let me connect to the local instance. So I'll give my password. I'll click on OK. Alright. So this is my MySQL workbench query editor. So first we are going to learn subqueries. Let me give a comment and write subqueries. Alright. So first of all, let's understand what a subquery is. So a subquery is a query within another SQL query that is embedded within the where clause, from clause, or having clause. So we'll explore a few scenarios where we can use subqueries. So for that, I'll be using my database, that is SQL_intro. So I'll write my command use SQL_intro. Now this database has a lot of tables. I'll be using the employees table that is present inside SQL_intro. Let me just expand this, and you can see here we have an employees table. So let me first show you the contents within this table. I'll write select star from employees. Let me execute it. Okay, you can see here we have the employee ID, employee name, age, gender, there's date of join, department, city, and salary, and we have information for 20 employees. If I scroll down, you can see there are 20 employees present in our table. So let's say you want to find the employees whose salary is greater than the average salary. In such a scenario, you can use a subquery. So let me show you how to write a subquery. I'll write the select statement. In the select statement, I'll pass my column names that I want to display. So the column names I want are the employee name. Then I want the department of the employee and the salary of the employee. From my table name, that is employees. Next, I'll use a where condition where my salary should be greater than the average salary of all the employees. So I'll write salary greater than. After this, I'm going to write my subquery. So I'll give select average of salary from my table name, that is employees, and I'll close the bracket and give a semicolon. So what it does is, first it is going to find the average salary of all the employees that are present in our table. Once we get the average salary number, we'll use this where condition where salary is greater than the average salary number. So the inside subquery, let me run it first. If I run this gives you the average salary of all the employees, which is $75,350. Now I want to display all the employees who have salary greater than $75,350. So let's run our subquery. There you go. So there are 8 employees in our table who have a salary greater than the average salary of all the employees. Alright. Next, let's see another example. Suppose this time you want to find the employees whose salary is greater than John's salary. So we have one employee whose name is John. Let me run the table once again. Okay, if I scroll down, you see we have an employee as John. You see this? Our employee ID 116 is John and his salary is $67,000. I want to display all the employees whose salary is greater than John's salary. So basically all the employees who are earning more than $65,000, I want to print them. So let's see how to do it. I'll write select, I want the employee name, comma, the gender of the employee. I also want the department and salary. From my table name, that is employees, I'll write where salary is greater than, I'll start my opening bracket. Inside the bracket, I'm going to give my inner query, that is select salary from employees where the employee name is John. So within single quotations, I'll give John as my employee. I'll end with a semicolon. So let me first run my inner query. So this will give us the salary that John has, which is $67,000. Now I want the employees who are earning more than $67,000. So let's run our subquery. Okay, so you can see 12 rows returned, which means there are 12 employees in our table who are earning more than $67,000. You see here, all these employees have a salary greater than $67,000. Okay. Now, you can also use subqueries with 2 different tables. So suppose you want to display some information that are present in 2 different tables, you can use subqueries to do that. So for this example, we'll use a database that is called classic models. You can see the first database. So let me use this database called classic models. I'll write use classic models. Now this database was actually downloaded from the internet. There's a very nice website. I'll just show you the website name. So this is the website, that is mysqltutorial.org. You can see here they have very nice articles, blogs from where you can learn MySQL in detail. So we have downloaded the database, that is classic models, from this website. You see here they have a MySQL sample database. If you click on this, it will take you to the link where you can download the database. So they have this download link which says download MySQL sample database, and the name of the database is classic models. Alright, so we are going to use this classic models database throughout our demo session. If I expand the tables section, you can see there are a lot of tables that are present inside this classic models database. We have cricket, customers, there's employees, office, there's orders, order lines, and many more. So for our subquery, we'll be using 2 tables, that is order details and products table. First, let me show you the content that is present inside the products table first. If I run this, you see here it says 110 rows returned, which means there are 110 different products that are present in our table, which has the product code, the product name, product line. We have the product vendor, description, quantity in stock, buy price, MSRP, The other table we are going to use is order details, which has the details of all the orders. Let me show you the records order details tables has. Okay, so there are 1000 records present in this table. You have the order number, the product code, quantity ordered, price of each item. You have the order line number as well. Okay, now we want to know the product code, the product name, and the MSRP of the products whose price of each product is less than $100. For this scenario, we are going to use two different tables and we are going to write a subquery. Okay, so if you see here in the order details table, we have a column called price each. I want to display the product code, the product name, and the MSRP of the products which have a price of each product less than $100. So the way I'm going to do is I'll write select product code, comma, product name. Now one thing to remember, that this product name is actually present inside our products table and product code is present in both the tables, that is products and order details. Here you can see this is the product code column, comma, MSRP, which is present inside the products table again, from my table, that is products, where I'll write product code. I'm going to use the in operator. Next, I'll write my inner query, that is select product code from my table order details, where my price of each product is less than $100. Let me run this. Okay, so you can see there are total 83 products in our table which have a price less than $100. You can see the price here. Okay, now we learn another advanced concept in SQL which is known as stored procedures. I'll just give a comment saying stored procedure. Okay, so first let's understand what is a stored procedure. A stored procedure is an SQL code that you can save so that the code can be reused over and over again. So if you want to write a query over and over again, save it as a stored procedure and then call it to execute it. So in this example, I want to create a stored procedure that will return the list of players who have scored more than 6 goals in a tournament. So I have a database called SQL_IQ. These are a few databases that I have already created. So this database has a table called players. If I expand the tables option, you see we have a table called players and you can see the columns player ID, the name of the player, the country to which the player belongs to, and the number of goals each player has scored in a particular tournament. So I'll write a stored procedure that will return the list of top players who have scored more than 6 goals in a tournament. So first of all, let me begin by using my SQL_IQ database. We'll run it. So now we are inside the SQL_IQ database. Let me select star from players to show the values that we have in the players table. You can see there are 6 players in our table. We have the player ID, the names of the players, the country to which these players belong to, and the goals they have scored. So I'll write a stored procedure. So the stored procedure syntax is something like this. It should start with a delimiter. Okay. In the delimiter, I'll write &&. Next, I'll write create procedure followed by the procedure name. Let's say I want to name my procedure as top_players. Next statement is begin. After begin, I'll write my select statement. I want to select the name of the player, the country, and the goals each player has scored from my table, that is players, where I'll write goals is greater than 6. I'll give a semicolon. Then I'll end my procedure with a delimiter that was double ampersand. Next, I'll write delimiter and give a semicolon. Now the semicolon suggests this is a default delimiter. And there should be a space. Okay. Now let's run our stored procedure. There you go. So you have successfully created our stored procedure. Now the way to run a stored procedure is you need to use the call method and give the procedure name, that is top_players in our case, with brackets and a semicolon. Let's execute it. Okay, there is some problem here. So we made a mistake while creating a procedure. The name of the column is goals and not goal. Let me create that procedure again. Okay, it says the procedure top_player already exists. Let's just edit the procedure name. Instead of top player, we'll write it as top players, and similarly we'll edit here as well. Now let's create it again. Okay, now to call my procedure, I'll write call space followed by the procedure name, which is top_players. If I run this, you can see we have 2 players in our table who have scored more than 6 goals. So we consider them as the top players in a particular tournament. Alright. Now there are other methods that you can use while creating a stored procedure. One of the methods is by using an in parameter. So when you define an in parameter inside a stored procedure, the calling program has to pass an argument to the stored procedure. So I'll give a comment, stored procedure using in parameter. Alright. So for this example, I'll create a procedure that will fetch or display the top records of employees based on their salaries. So we have a table in our SQL_IQ database which is called employee details. I'm going to use this table. You can see we have the name of the employee, the age, sex, then we have the date of join, city and salary. Using this table, I'll create a procedure that will fetch or display the top records of employees based on their salaries, and we'll use the in parameter. So let me show you how to do it. I'll write delimiter. This time I'm going to use /. I'll write create procedure followed by the procedure name. Let's say SP for stored procedure, sort by salary is the name of my procedure, and inside this procedure I'll give my parameter in. I'll create a variable var and assign a data type integer. Then I'll write begin followed by my select statement, where I'll select the name, age, salary from my table name, that is EMP details or employee details. I'm going to order this by salary descending, and I want to display limited number of records. So I'm using this limit keyword and my variable var, which I created here. I'll end my select statement. I'll end my stored procedure with /, and I'll go back to my default delimiter, that is semicolon. Alright, so let me run this. There should be a space here. Alright, so let's run this. Okay, you can see we have successfully created our second stored procedure, which is sp underscore sort by salary. Now you can also check whether the stored procedure was created or not. Here you have an option to see the stored procedures. Let me just refresh this, and you can see we have 3 stored procedures that we have created so far. One is sp underscore sort by salary, the other two were top underscore player and top underscore players. Okay, now let's call our stored procedure. I'll write call space followed by the stored procedure name, which is sp underscore sort by salary, and inside this I'll give my parameter, which was actually var, and this var we have used in limit. Let's say I want to display only the top 3 records of the employees who have the top 3 highest salaries. Okay, so let me run it. There you go. So Amy, Sarah and Jimmy were the top 3 employees who have the highest salary. So you saw how you could use the in parameter in a stored procedure. We created a variable, and that variable we used in our select statement, and we called our stored procedure and passed in that variable. Okay. Now instead of a select statement inside a stored procedure, you can also use other statements. Let's say update. So I'll create a stored procedure to update the salary of a particular employee. So in this procedure, instead of select statement, we'll use the update command. In this example, we'll use the in operator twice. So let me show you how to do it. I'll write my delimiter first, which is going to be /, then I'll write create procedure. My name of the procedure is going to be update salary, and inside the update salary name I'll write in, and then temp underscore name, which will be a temporary name variable, and the type I'll assign is varchar 20. I'll again use my in parameter. I'll write in. Next, my other variable would be new underscore salary, and the data type would be float. I'll write begin and write my update command or update statement. I'll write update table name, that is employee details, set salary equal to new underscore salary, where name is equal to my temporary variable, that is temp underscore name. So this is my update command, and I'll end the delimiter. Alright, so let's run this. Okay, we have successfully created our stored procedure. If I refresh this, you can see I have my stored procedure update underscore salary. Okay, now let's say first of all I'll display my records that are present inside employee underscore details table. Okay, so we have 6 rows of information. Let's say you want to update the salary of employee Jimmy, or let's say Mary, from 70,000 to let's say 72,000, or let's say 80,000. So I'll call my stored procedure, that is update underscore salary, and this time I'm going to pass in 2 parameters. The first parameter will be the employee name, and next with a comma I'll give my new salary that I want to So my employee name, let's say, is Mary, and the salary I want to be updated is, let's say, $80,000. I'll give a semicolon and I'll run it. You can see it says 1 row affected. Now let's check our table once again. There you go. If you see this record, for Mary we have successfully updated the salary to $80,000. Now moving ahead, we learn to create a stored procedure using the out parameter. So I'll give a comment, stored procedure using out parameter. Okay, so suppose we want to get the count of total female employees. We will create total employees as an output parameter, and the data type would be an integer. The count of the female employees is assigned to the output variable, which is total underscore EMPs, using the into keyword. Let me show you how to write a stored procedure using the out parameter. So first I'll declare my delimiter to / I'll write create procedure followed by the procedure name. It is going to be sp underscore count employees, and inside this I am going to give my out parameter and the variable name, that is total underscore EMPs, which is total employees, and the data type will be integer. Next I am going to write begin followed by my select statement, that is select. I want the count of total employees, and the output I am going to put into my new variable, that is total underscore EMPs. From my table, that is EMP underscore details, where sex is equal to F, which means female, I'll give a semicolon. Next I'll end it with the delimiter, and I'm going to change the delimiter to a default delimiter, that is colon. So let me tell you what I am doing here. I'm creating a new stored procedure, that is sp underscore count employees. Using this stored procedure, I am going to count the total number of female employees that are present in our table emp underscore details. So I've used my out parameter and I'm creating a new variable called total underscore EMPs. The data type is integer. Here in the select statement, I'm counting the names of the employees, and the result I am storing it in total underscore EMPs. I have used my where condition where the gender or the sex is female. So let's run this. Okay, so we have created our stored procedure. Let's refresh this. Okay, you can see we have our new stored procedure sp underscore count employees. Now to call it, I'll write call the name of the procedure, that is count underscore sp underscore count employees. Within brackets, I'll pass in the parameter as @ f underscore emp. I'll give a semicolon. Then I'll write select @ f underscore emp as female employees. Okay, so as is an alias name. Let's run this one by one. First I'll call my procedure, and then we'll display the total number of female employees. You can see in our table we have 3 female employees. Alright, now with this understanding, let's move on to our next topic in this tutorial on advanced SQL. Now we are going to learn about triggers in SQL. So I'll give a comment here, triggers in SQL. So first let's understand what is a trigger. So a trigger is a special type of stored procedure that runs automatically when an event occurs in the database server. Now there are mainly 3 types of triggers in SQL. We have the data manipulation trigger, we have the data definition trigger, and login triggers. In this example, we will learn how to use a before insert trigger. So we will create a simple students table that will have the student's roll number, the age, the name, and the student's marks. So before inserting the records to our table, we'll check if the marks are less than 0. So in case the marks are less than 0, our trigger will automatically set the marks to a random value, let's say 50. So let's go ahead and create our table, that is students. Alright. So I'll write create table student. Now this table will have the student roll number, the data type is integer, it will have the age of the students, again the data type is integer, we have the names of the students, so the third column would be name, the data type would be variable or varying character, size I am giving it as 30, finally we have the marks as floating type. So let's create this table which is student. So we have created our table. Now I'll write my trigger command. So trigger command will start with delimiter like how our usual stored procedures have. Next, this time I'll write create trigger. Then you need to give the name of the trigger, that is mark underscore, let's say verify. I'm going to use a before insert trigger, so I'll write before insert on my table name, that is student. Next I'll write for each row if new dot marks is less than 0, then we'll set new dot marks equal to 50. So this is my condition. First we'll check before inserting if any student has marks less than 0, we'll assign a value 50 to that student, because usually the marks are not less than 0 in any exam. I'll write end if semicolon and I'll close the delimiter. So this is my trigger command. I'll run it. It says trigger already exists. So in this case we need to update the trigger name. Let's say I'll write marks underscore verify underscore student for ST. Let's run it again. Okay, there is an error here because in our table the column name is mark and not marks. So here we need to change it as mark instead of marks. Alright, let's run it. Okay, so we have created our trigger. Now let me insert a few records to the student table. So I'll write insert into student. I'll write values. I'll give the values as 501, which is the student roll number. The age is, let's say, 10. The name is, let's say, Ruth. And the marks is, let's say, 75.0. Give a comma. We'll insert our second student record. Student roll number is 502. Age is 12. The name is, let's say, Mike. And this time I'm purposely giving a value of minus 20.5. Give another comma. We'll insert the third record for student roll number 503. Age is 13. The name is Dave. And let's say the marks obtained by Dave is 90. Now we'll insert our final record for student number 504. The age is 10. Name I'll enter as Jacobs. and this time again I'm purposely giving the marks in negative 12 point, let's say 5. I close the bracket and give a semicolon, and I'll run my insert statement. Okay, so we have inserted 4 rows of information to our student table. Now let me run the select query. I'll write select star from student. If I run this, you see the difference. There you go. So originally we had inserted for 502 the marks was minus 20.5, and for 504 for Jacobs the marks was minus 12.5. Our trigger automatically converted the negative marks to 50, because when we created our trigger we had set our marks to 50 in case the marks were less than 0. So this is how a trigger works. Now you can also drop a trigger or delete a trigger. You can just write drop trigger followed by the trigger name. In this case our trigger name is marks underscore verify underscore st. I'll just paste this here, and if you run this it will automatically delete your trigger. You give this as a comment. Okay, now moving on. Now we are going to learn about another crucial concept in SQL which is very widely used. This is known as views. So views are actually virtual tables that do not store any data of their own but display data stored in other tables. Views are created by joining one or more tables. I'll give a comment as views in SQL. Okay. Now to learn views, I am going to use my table which is present inside Classic Models database. Now this database, as I mentioned, we had downloaded it from the internet. So first of all, let me write use Classic Models. So I'll switch my database first. Alright, now we are inside Classic Models. So here let me show you one of the tables which is called customers. So I'll write select star from customers. Okay, I missed S here. Let's run it again. So this is my customer table which is present inside Classic Models database. It has the contact last name, the contact first name, the customer name, customer number, we have the address, state, country, and other information. Now I'll write a basic view command using this customer table. The way to write is I'll write create view followed by the view name which is cust underscore details. Then you write as select. I'm going to select a few column names from my original customer table, which is this one. So I need the customer name. Let's say I need the phone number and the city. So you have this information here. You have the phone number and the city. Alright, I'll write from my table that is customers. If I run this, my view that is cust details will be created. Let's run it. There's some error here because the name of the table is customers and not customer. I'll give an S and I'll run it again. Alright, so you can see we have created our view, and to display the contents that are present inside our view, I can write select star from followed by the view name that is cust underscore details. Let's run it. There you go. So we have the customer name, the phone number and the city of the different customers that we have in our table. Alright. Now let's learn how you can create views using joins. So we'll join two different tables and create a view. So for that I am going to use my products table and the products lines table. I'm talking about the products table and the product lines table present inside Classic Models database. So before I start, let me display the records that are present inside the products table. Let's run it. So these are the different products you can see here. Now let's see what we have in product lines table. So we have the product line, the text description, and there's some HTML description and image. So I'll create a view by joining these two tables and will fetch specific records that are present in both the tables. So let me first start by writing create view followed by the view name, that is product underscore description, as I'll write select product name, comma, then I'll write quantity in stock. I also want the MSRP. Now these three columns are present inside the products table, and next from the product lines table I want the text description of the products. So I'll write from products table, I'll give an alias as P followed by inner join my other table, that is product lines, as let's say PL on the common column, that is product line. So P dot product line is equal to, I'll give a space, PL dot product line. Okay, so here we have used an inner join to fetch specific columns from both the tables, and our view name is product underscore description. Let us run it. Alright, so we have our view ready. Now let me view or display what is present inside our product underscore description view. I'll write select star from product underscore description. Let's run it. There you go. So we have the product name, the quantity in stock, MSRP, and textual descriptions of the different products in the table. Okay, now there are a few other operations that you can perform. Let's say you want to rename a view. Instead of product underscore description, you want to give some other name. So I'll just give a comment, rename description. So to rename a description, you can use the rename statement. I'll write rename table product underscore description, which is my old name. I want to change this name to, let's say, I'll give vehicle description, since all our products are related to some of the other vehicle. So I'll write vehicle description. Okay, let us run it. Alright, so here you can see I have renamed my view. So here if I just refresh it and I'll expand this, you can see we have the cust details view and we have the vehicle underscore description view. Okay, now either you can view all the views from this panel or you can use a command. Let's say I'll write display views is the comment. Now to show all the views, you can use show full tables, where table underscore type is equal to, within single quote I'll write view. So this is the command that will display all the views that are present inside a database. There is some error here. Let's debug the error. This should be okay. So instead of table types, it should be table type equal to view. Let's run it. You can see the two different views that we have. One is customer details, another is vehicle underscore description. Okay, now you can also go ahead and delete a view. For that you can use the drop command. So I'll write drop view followed by the view name. Let's say I want to delete customer underscore details or cust underscore details view. I'll write drop view cust underscore details. Let's run it. You can see here we don't have the cust underscore details view anymore. Alright. Now moving to our final section in this demo. Here we will learn about Windows functions. Now, Windows functions were incorporated in MySQL in the 8.0 version. So Windows function in MySQL are useful applications in solving analytical problems. So using the employees table present inside my SQL underscore intro database, so we'll find the total combined salary of the employees for each department. So first let me switch my database to SQL underscore intro database. I'll run it. Okay. I'll display my table, that is employee. So here we have 20 employees in our table. Using this table, we are going to find the combined salary of the employees for each department. So we'll partition our table by department and print the total salary. And this we are going to do using some Windows functions in MySQL. So I'll write select. I want the employee name, the age of the employee, and the department of the employee, comma. Next I'll write the sum of salary over. I want to partition it by department. So I'll write partition by department, which is DEPT, and I'll give an alias as total salary so that it will create a new column with the name total salary from my table, that is employees. The output will be a little different this time. Let's execute it and see the result. There you go. So here we have created another column in our result, that is total salary, and for each of the employees and the respective departments we have the highest salary. So in finance, the highest salary of one of the employees was $155,000. Similarly, if I come down, we have the highest salary from HR. If I scroll further, we have the highest salary from IT, marketing, product, sales, and the tech team. Alright. Now we'll explore a function which is called row number. Now the row number function gives a sequential integer to every row within its partition. So let me show you how to use the row number function. I'll write select row underscore number function over my column would be salary. So I'll write order by salary. I'll give the alias as row num, give a comma, and I want to display the employee name and the salary of the employee from my table, that is employees, and I'll order by salary. So let's see how our row number function will create sequential integers. Okay, you can see here we have a row num column and we have successfully given row numbers to each of the records. You can see it starts from 1 and goes up till 20. Okay. Now this row number function can be used to find duplicate values in a table. To show that, first I'll create a table. I'll write create table. Let's say I'll give a random name, that is demo. And let's say we have in this table the student ID, which is of type integer, and we have the student name, which is of type varchar. The size is 20. I'll create the small table with a few records. Let's create this table first. Now we are going to insert a few records to our demo table. So I'll write insert into demo values I'll give 101, the name is Shane, give a comma, I'll insert the second student name, 102, the name is Bradley, I'll give a comma. This time for 103 we have two records. Let's say the name of the student is Herath. I'll give a comma, I'll copy this and we'll paste it again. So we have duplicated 103. Next we have 104. The name of the student, let's say, is Nathan. Then again, let's say for the fifth student, which is Kevin, we have two records. I'll copy this and I'll paste it here. Let me give a semicolon and we'll insert these records to our table demo. Alright. Now let me just run this table for you. I'll write select star from demo. If you see this, we have a few information that are duplicated in our table, that is for student ID 103 and student ID 105. Now I am going to use my row number function to find the duplicate records present in my table. I'll write select student underscore ID comma student underscore name. I'll give another comma and write row underscore number over within brackets. I'll write partition by st underscore id comma st underscore name. Okay, then I'll write order by st underscore id, close the bracket. I'll give an alias as row num from my table, that is demo. Let's just run it. You can see here, okay, let me just delete n from here and do it again. Alright, now if you see here, there is just one student in the name Shane, we have one student in the name Bradley, but here if you see for Herath, the second record it says 2, which means there are two records for Herath, and if I scroll down there is one record for Nathan and there are two records for Kevin, which means Kevin is also repeated. Okay, now we are going to see another Windows function that is called rank function in MySQL. So the rank function assigns a rank to a particular column. Now there are gaps in the sequence of ranked values when two or more rows have the same rank. So first of all, let me create a table, and the name of the table would be a random name. We'll give it as, let's say, demo1, and it will have only one column, let's say variable a of type integer. We'll create this table first. Okay, now let's go ahead and insert a few records to our table, which is demo1. So I'll write value 101, 102, let's say 103 is repeated. I'm doing this purposely so that in the output you can clearly distinguish what the rank function does. Next we have 104, 105, we have 106, and let's say 106 is also repeated. Finally we have 107. Okay, let me insert these values to my table, that is demo1. Okay, this is done. Now if I write select var underscore a and use my rank function, I'll write rank over, then I'll order by my variable, that is var underscore a, as an alias name, let's say test rank, from my table that is demo1. Let me execute this and show you how the rank function works. Now if I run this, there you go. So here if you mark, so for variable A101 the test rank is 1, for 102 the test rank is 2, but for this value which is 103 the test rank is repeated because there was a repetition for 103. So we have skipped the rank 4 here. For 104 the rank is 5 now, for 105 the rank is 6 now. For 106 again, since the record was repeated twice, we have skipped the 8th rank and our rank function has assigned the same value which is 7 for 106, and for the last value 107 the rank is 9. Alright. Now moving ahead, we'll see our final Windows function which is called first value. So first value is another important function in MySQL. So this function returns the value of the specified expression with respect to the first row in the window frame. Alright. So what I'm going to do is, I'm going to select the employee name, the age and salary, and I'll write first underscore value, which is my function, and pass in my employee name, and then I'll write over order by my column that is salary descending. I'll give an alias as highest underscore salary from my table that is employees. So let me run this and see how the first underscore value function works. Alright, so in our table Joseph was the employee who had the highest salary, which was $115,000. So the first value function populated the same employee name throughout the table. You can see it here. Now you can also use the first underscore value function over the partition. So let's say you want to display the employee name who has the highest salary in each department. So for that you can use the partition. I'll write select emp underscore name, comma, I want the department and the salary, comma, I'll use my function that is first underscore value followed by the name of the employee inside my first value parameter. I'll write over, here I'm going to use partition. I'm going to partition it by department, since I want to know the employee name who has the highest salary in each department. And I'm going to order by salary descending, and I'll give my alias again as highest salary from my table that is employees. So let's run this and see the difference in the output. Okay, so as you can see here, we have the employee who had the highest salary from each department. So for finance, Jack had the highest salary. From HR it was Marcus. Similarly in IT it was William. If I scroll down, for marketing it was John. For product it was Alice who had the highest salary. Similarly in sales we had Joseph, and in tech we had Angela. So this is how you can use the first underscore value function using partition. Alright, so that brings us to the end of this demo session on our tutorial. So let me just scroll through and show you what we did from the beginning. First we learnt about subqueries in SQL. So we initially wrote a simple subquery, and then we used our classic models database which was downloaded from the internet. I'd also shown you the link from where you can download this database. Here we used two different tables and we performed a subquery operation. we learned how to create stored procedures. So we learned how you can use the in operator or the in parameter as well as the out parameter in stored procedure. After stored procedure, we learned another crucial concept in SQL which is called triggers. Now triggers are also a special kind of stored procedures. So we saw how to write a before insert trigger. You can see it here. Next, we learned how to delete a trigger. We also saw how to work with views in SQL. So views are basically virtual tables that you can create from existing tables. We also saw how you can use views using two different tables and an inner join. And we learned how to display views, how to rename view names, how to delete a view, and finally we explored a few Windows functions. In this tutorial, we will learn how to work with databases and tables using SQL with Python. To do this demo, we will be using our Jupyter notebook and the MySQL workbench. You can see it here. So we will write our SQL queries in the Jupyter notebook with Python-like syntax. If you don't have MySQL or Jupyter notebook installed, so please go ahead and install them first. While installing the MySQL workbench, you will be asked to give the username and password. Let me show you. So I am on my MySQL workbench. So once you connect, it will ask for the username and the password. So I have given my username as root, and password you can give while installing it. We will be using the same user ID or the username and the password to make our connection. So let's get started with our hands-on demonstration part. First and foremost, let me go ahead and import the necessary libraries. I'll give a comment as import libraries. Alright, so first I'll import mysql.connector. Next, from mysql.connector, I'm going to import my error method or the error module. Next, I want to import pandas as PD. So let's run this. Okay, there is some error here. This should be capital E and not small e. Alright, you can see I have imported my important libraries. Now I'm going to create a function that will help us create a server connection. So I'll write my user-defined function by using the def keyword. I'll write create underscore server underscore connection. This is going to be my function name, and it will take in three parameters. First is the host name, next is the username, and then we have the user password. Alright, I'll give a colon, and then in the next line I'm going to define a variable which is going to be connection, and I'll assign it to a value called none. Now we'll be using exception handling techniques to connect to our MySQL server. The try block lets you test a block of code for errors, and the except block will handle the errors. So I'll write try and give a colon, and then I'm going to reassign the connection variable to a method which is mysql dot connector dot connect. Now this mysql connector dot connect method sets up a connection, so it establishes a session with the MySQL server. If no arguments are passed, it uses the already configured or default values. So here we are going to pass in three parameters. The first is the host name. I'll write host equal to host name, which is host underscore name. I'll give a comma, then I'll write user equal to user underscore name. Next will be my password, and I'll assign the value user underscore password. Alright. Now I'm going to use a print statement and write MySQL database connection successful. After this, I'll give my except block. So I'll use the keyword except. Here I'll write error as ERR, give a colon, and then I'm going to use the print statement. Here I'm going to use some print formatting techniques using the F letter. I'll write error colon and I'll use curly braces, give ERR, and then I'll close the double quotes. After this, I'm going to return my connection. Alright. Let me give a comment here. We are going to assign our password, so we need to put our MySQL terminal password. So this password you assign it while installing MySQL workbench. I'll write PW and I'll give my password, which is simply@12345, and then I'm going to give my database name. So I'll give database name. Here I'm going to write DB equal to, this is the database I want to create, which is going to be MySQL_Python. Let me just scroll this down. Okay, now I'll say connection equal to, I'll pass in my user defined function name, which is create server connection, and the parameters, which are going to be localhost, that is my host name, my username, which is root, and then I'll give PW, which is my password, that is exactly simply@12345. Let's just run it now. Okay, there is an error here. We need to remove this double quotation. Alright, made another mistake here. This should be root. Okay, you can see here MySQL database connection successful. Alright, next we are now going to create a database, that is MySQL_Python. So I'll give a comment, create MySQL_Python database. Again, to create this database, I'm going to create another user defined function using the def keyword. I'll write the function name as create database, pass in the parameters as connection, query, give a semicolon, and in the next line I'll write cursor equal to, I'm going to make the connection, so I'll write connection dot cursor, and I'll give the parenthesis. So this MySQL's cursor of MySQL connector Python is used to execute statements to communicate with the MySQL database. The MySQL cursor class initiates objects that can execute operations such as the MySQL statements. Okay, next I'm going to again use my try and except block. So I'll write try, give a colon, and here I'm going to use cursor dot execute Within that, I'm going to pass in my query. Next, I'll use a print statement, and the message I'm going to display is database created successfully. After this, I'm going to write my except block. I'll write except error as err, give a colon, and then I'll use a print statement. I'll write print. I'll use the formatting again, error colon, then I'll write within single quotes, I'll give curly braces err, and then I'll close the double quotes. Next, let's use the variable create underscore database underscore query, and here I'm going to write my SQL query to create the database. So I'll write create database, and followed by that I'll give my database name, which is going to be MySQL underscore Python. Okay. After this, I'll call my function, which is create database, and I'll pass in the parameters. The first one is connection, and next the query is create underscore database underscore query. Let me just copy it, and I'm going to paste it here. Alright, so what I'm doing here is I am creating a new function, that is to create a new database with the name MySQL underscore Python, which you can see it here. Now this function takes in two parameters, connection and query. I'm using the connection.cursor function, which is often used to execute SQL statements using Python language. And then I have created my try and except blocks. So this try block statements will try to create my new database, which is MySQL underscore Python. In case it fails to create the new database, the except block will work. So here I am writing my SQL query to create a new database, which is create database followed by the database name, and I am assigning it to a variable which is create database query, and then I'm calling my function create database and passing in the two parameters, connection and the query. Alright, so let's just run it. Alright, you can see here it has created my database successfully. Now you can verify this by checking the MySQL workbench or the MySQL shell. You can see on the MySQL workbench here on the left panel under schemas, there is a database called MySQL underscore Python. Let me just expand it. Now we haven't created any table, so it's not showing it now. The next step, we are going to connect to this database. So let's go ahead and connect to our database that we have just created. I'll write the comment as connect to database. Now to connect to our database, I'm again going to create a user defined function using the def keyword. I'll write create underscore db, which is for database underscore connection, and the parameters it will take is the host name followed by the username, then we have the user password, and finally we have the database name. I'll give a colon. In the next line, I'm going to create my variable, which is connection, and then I'll assign it to a value none. After this, I'm going to use my exception handling techniques. So I'll write my try block first. I'm going to reassign my connection variable using the MySQL connector method. So I'll write MySQL dot connector dot connect. So this method will take in the parameters. So first it will take the host name. I'll write host equal to host underscore name. I'll give a comma. Next it will take the username, so user equal to user underscore name, give another comma. Next it will take the user password. I'll use passwd equal to user underscore password. I'll give another comma, and this time it is going to be the database name. So I'll write database equal to db underscore name. Now let's use the print statement, and the message we are going to print is MySQL database connection successful. Alright, finally we'll write my except block. I'll write except error as err, give a colon, and then I'll use the print statement. F within double quotes I'll write error colon, within single quotes curly braces I'll write err, and will close the double quotes. Finally this function will return the connection value. Alright, let's run it, and there you go. It has run successfully, so we have connected to our database. Now it's time for us to execute SQL queries. I'll give another comment saying execute SQL queries. Alright, now to execute our SQL queries, I'll use another user defined function, which is execute underscore query, and I'll pass in the parameters as connection and query. I'll give a colon. I'm going to write cursor equal to connection dot cursor. Now this is used to establish a connection and run SQL statements. Next we'll use the try and except block, so I'll write try cursor dot execute. This will take in one parameter, which is going to be my query, and then I'll write connection dot commit, which is another method. Now let's use the print statement. So I'll write print, let's say the message would be query was successful, and then we'll write our except block, which is except if the try block doesn't work, throw an error using the print statement. Within double quotes, inside the curly braces, I'll write err and close the double quotes. Alright, so let's run it. Okay, so we have successfully created our various functions that were needed to create a database, establish a connection, and to execute our queries. Alright, now it's time for us to create our first table inside the MySQL underscore Python database. So to do that, I'm going to write my create command in SQL. So first we are going to assign our SQL command to a Python variable using triple quotes to create a multi-line string. So let me show you how to do that. I'll write my variable name, which is going to be create orders table. It is always recommended to use relevant variable names to make it more readable. And now I'm going to use triple quotes. So the triple quote will ensure I can create my multi-line string. Inside the triple quote, I am going to write my create command, which is create table. Here I am going to create an orders table first, and inside the orders table I am going to create my column names. The first column would be the order ID. It is going to be of type integer, and I'll assign this order ID as my primary key column. We'll give a comma. Next, the second column would be customer underscore name. The customer name column would be of type varying character, so I'll write varchar and I'll give a size of 30, and this is also going to be not null. Moving ahead, my fourth column would be the product name column, so I'll write product underscore name. Product name will be of type varying character. The size is, let's say, 20, and it is also not null. Next, I'm going to create my fourth column, which is the date on which the item was ordered or the product was ordered. So I'll write date ordered. The data type will be date. Next, I'll create a quantity column to keep track of the number of quantities that were ordered. This is of type integer. My next column would be unit price, which will basically have information about the price of each unit of product. Unit price can be of type float. And finally, I'll have the phone number of the customer. I'll write phone number. Phone number can be kept as of type varying character. I've assigned a size of 20. Now let's give a semicolon and we'll close the triple quotes. Alright, so this is how the syntax would look like. Next, to run this, we are first going to call our createDB function. So let me give a comment as connect to the database. I'll write connection equal to create underscore db underscore connection. My parameters would be my host name, which is localhost, my username, which is root, comma, my password, and then my database name, which is MySQL underscore Python. So I'll write just db. Alright. Finally, let's execute this query using the execute underscore query function that we had created earlier. This takes in two parameters. The first one is connection, followed by the variable name, which is create orders underscore table. Let us run it. Okay, there is some error here. Let's see what's the error. Okay, so here we have put 4 double quotes. This should be triple quotes. Now let's run it. Okay, there is another here. Let's debug it. It says name cursor not defined. Let me just roll it to the above cell. If you see here in our execute underscore query function, instead of cursor, I have written cursor. So R is missing. Let's rerun this. And now let's run this again. There you go. You can see here MySQL database connection successful. Even our query was also successful. Now if you want to recheck if the table, that is orders, was created or not, you can check it on the MySQL workbench. So let me show you how to do it. So I am on my MySQL workbench, and under MySQL_Python database you have something called as tables. Let me just right click and I'll select refresh all. There you go. You can see this arrow. Just click on this arrow, and here you can see we have a table called orders. So we have created a table called orders. Now you can check the columns as well. You have the order ID, the customer name, product name, ordered date, quantity, unit price, and phone number. Now it's time for us to insert a few records to this table, which is orders. Now to insert records, I'll give a comment as insert data. I'll start with the variable name. Let's say the variable name is data_orders. I'll give triple quotes. Next, I'll write my insert into command. So I'll write insert into my table name, that is orders, followed by values, and now I'll start entering my records for each of the rows. So first I'll give 101, which is the order ID. Then I'll give the customer's name, let's say Steve, and the product he had ordered is, let's say, laptop. Then I'll give my date in which the item was ordered. Let's say it is 2018. I'll choose 06 as the month, and the date is, let's say, 12. I'll give another comma. This time we'll pass in the quantity, which is 2. Let's say the price of each laptop was $800, and we'll give a phone number. This is random. Let's say 62937330, let's say 802. Alright. Similarly, I am going to insert 5 more records of different customers and their items that they have purchased to this table orders. So here on my notepad I have my rest of the 5 records. Let me just copy it and we'll paste it in the cell here. This will save us some time. Okay, let me recheck if everything is fine. I'll give a comma here. Alright, so we have 6 customers in our table which have their customer IDs from 101 to 106. We have Steve, Jaws, Stacy, Nancy, Maria, and Danny. You have the different items they have purchased: laptop, books, trousers, t-shirts, headphones, and smart TV. This is the date on which they had ordered this item, the number of quantities they had ordered, and then we have the unit price and some random phone numbers. So let's create the connection now. I'll write connection equal to, I'll write create _db_ connection. Then I'll going to give my same parameters. Let me just copy it from the top, which is localhost, the host name, root is my username, then we have password and the database name, and then I'll use the same query as above, which is execute query. I'll copy this, paste it here, and instead of create orders table variable, I'll put as data_orders. So this will store my insert into command. You can see the variable I've used here is data_orders. Now it's time, let's just run it. Alright, there was some mistake here. Let's debug it. Again, this should be triple quotes and not 4. Now let me rerun it again. There you go. You can see here MySQL database connection successful and my query was also successful. Now we'll create another user-defined function which will help us read query and display the results. So I'll write my function name as def read_query. This will take in 2 parameters, connection and query. Then I'll write cursor equal to connection.cursor. I'll put my result as none, and then I'll use my try and accept block. I'll write try cursor dot execute. This will take in one parameter, which is query, and then I'll give another variable which is result equal to cursor dot fetch all. Now this fetch all method will return all the results in the table. I'll write return result. Next we'll use the accept block. So I'll write accept error as err, give a colon, and I'll use my print statement. Scroll this down. I'll use my formatting f error, give a colon followed by a space, within single quotes inside curly braces I'll give err and close my double quotes. Let's run it. Alright, so now we are all set. Now we are going to use our select clause having whereby, then we'll see how to use order by clause, some inbuilt functions, we'll update some records, delete some records, and do a lot of other stuff. So let's start with our first query. So our first query is going to be using the select statement. Alright, so suppose I want to display all the records that we have inserted into our orders table. So the way to do is I'll assign my query to a variable, let's say q1. I'll give triple quotes. Within triple quotes I'll write select star from orders. I'll give a semicolon followed by the triple quotes. Now we'll establish the connection. So let me just go to the top and I'll copy this line which is to connect to our database. I'll paste it here. Now we'll create a variable called results that will store the result of this query, and we are going to assign this variable to our function, that is read query, and this read query will have two parameters, the connection and the variable name, which is q1 for the query. Next, to display I'm going to use a for loop. I'll write for results for result in results print, I'll say result. Now we are done. Let's just run this query. There you go. You can see here we have successfully printed all the rows in our table, which is orders. You can see we have 6 records in total. Now we are going to explore a few more queries. So let me just copy this and we are going to edit in the same query. I'll paste it here. Next, let's say you want to display individual columns from the table and not all the columns. So let me create the variable q2. Now instead of star, I'm going to display only the customer name and let's say the phone numbers of the customer. So I'll write phone underscore number. Alright, the rest all remains the same. Let me just recheck it, and here instead of q1 we'll put q2, and let's run this cell. Alright, you can see here now we have displayed only 2 columns. The first column is the customer name and then we have their respective phone numbers. Okay, now let me just paste that query again. Now we are going to see how you can use an inbuilt function, that is, in our table we have the order date, and from the order date we are only going to display the different years that are present in the order date. So to do that I am going to use the year function. I'll edit this query. Instead of q1 I'll make it q3, and here I'm going to write select year, which is my function name, from my column which is date ordered, from orders, and here I'll change this to q3. Q1, Q2, Q3 are basically query 1, query 2 and query 3. Let's run it. There you go. So we have successfully extracted the different years present in the order date column. Now if you want to display the distinct or the unique dates present in the column, you can use the distinct keyword in the select statement. So the way to do it is, I'll write select distinct, give a space, the rest of the query remains the same, and here in Q3 I'll write Q4. I'll make this as Q4. Let's run it. You can see 2018 and 2019 are the unique year values that are present in the order date column. Okay, now moving ahead, let's write our fifth query, and this time we are going to explore how you can use the where clause. So I'll change this to Q5 before I write my query. So let's say you want to display all the orders that were ordered before 31st of December 2018. So to filter this, we are going to use the where clause. So I'll write select star from orders. Next I'll write where my date underscore ordered is less than, within quotes I'll give my date value, which is 2018 December 31st. So all the items or the products that were ordered before 31st of December 2018 will be displayed. So let's run it. Alright, you can see here there are 3 orders in our table which have been ordered before 31st of December. Now moving ahead, we want to display all the orders that were made after 31st of December. So here what you can do is, I'll just copy the above query again. I'll copy this line. So instead of less than 31st of December 2018, I'll make it as greater than. So every order that was placed after 31st of December will be displayed. If you run it, so you can see here there are 3 orders in our table which were ordered after 31st of December 2018. Now moving ahead, let's write our 7th query. Now let's see how the order by clause works in SQL. So you can filter your results based on a particular column or sort it based on a particular column. So this is going to be my query 7. I'll write it from scratch again. Let's say you want to display all the columns from the table. So I'll write select star from orders. Then I'm going to use order by unit price. I'll give a semicolon. Let's run this query and see the output. Now if you see the result here and you mark the unit price column, the result has been ordered in ascending order of unit price. You see here it starts with the lowest price and then goes on with the highest price towards the end. Now if you want to order it in descending order, you can use the keyword DESC. So this will ensure your top or the most expensive products appear at the top and the least expensive products appear at the bottom. Alright. Next, now let's see how you can create a data frame from the given table. So as you know, using Jupyter Notebook and Pandas, you can create data frames and work on it very easily. So with this table also we can create our own data frame. So for that, let me create an empty list first. I'll write from db equal to, I'll assign this as an empty list. So we are going to return a list of lists and then create a Pandas data frame. Next, I'll write my for loop. I'll write for result in results. I'll assign result to list of results. So I'm converting the result into a list and then I'm going to append it to the empty variable or the empty list, which is from_db dot append. I'll append the result to my empty list. Next, we need to pass in the columns now. That will be part of our data frame. So I'll write columns equal to this column. I'll pass it within a list. So I'll give my first column as order ID. Then we have the customer name. Next, I have my product name. Then I have the date on which it was ordered. Give a comma. Then we'll have the quantity column. Let me write it in the next line. Next, we have the unit price column. And finally, we have the phone number column. So I'll write within double quotes phone number, and this we are going to assign it to a data frame. So I'll be using pd dot data frame, which is my function to convert a list into a data frame. My variable I'm going to pass is from_db, and I'll write my next argument is columns equal to my variable name, that is columns. Finally, let's display the data frame, which is df. Alright, so here I'm creating a empty list first, and then I'm creating a for loop, and I'm appending the results to my empty list. Here you can see I have created my column list, and using pd.dataframe I'm converting the list into a data frame. If I run this is append and not appends. Alright, you can see we have our data frame ready. This is the index column. It starts from 0 onwards, and then we have the different column names. Okay, now let's see how to use the update command. Now suppose you want to change the unit price of one of the orders, you can use the update command. So the way to do it, I'll first create my variable, let's say update, and I'll give 3 quotes or triple quotes. Then I'll use my update command, which is update followed by the table name, that is orders. Next I'll write set, let's say unit_price. If you see this, let's say I want to set the unit price of trousers from $50 to, let's say, $45. I want to update this particular record. So I'm going to write set unit price column equal to $45, where the order ID equal to 103. So this query will update the third row in our table, which is order ID 103. So it will update from $50 to $45. I'll close the triple quotes, and now I'll use the connection queries again. Let me just paste it here. Alright, I'll delete these 3 lines of code, and instead of that I'll put execute underscore query, and this will take into parameters as always, which is going to be connection followed by the variable name, that is update. Let's run it. You see here it says MySQL database connection successful, query was successful. Now you can recheck that. To do it, let me just go to the top and we'll just copy our first query, which is Q1. I'll copy this and I'll paste it here. Let me just rename this now. This will be Q8, and I'll change this as well. I'll write select star from orders, where my order ID equal to 103. Let's see the unit price of 103 now. You can see here instead of 50, now we have updated it to $45. Alright, now the last command we are going to say is how you can delete a record from the table. I'll write delete command as my comment. Now to delete a query, I'll first give my variable name, which is delete underscore order, and I'll pass in within triple quotes. Next, I'll write my delete query, which is delete from my table name, that is orders. Then I'll give my where clause, where let's say I want to delete my order ID 105. Let me just go to the top and explain you again. So if you say this, we want to delete the order ID 105, which was for customer name Maria and she had ordered headphones. We want to completely remove this particular record. So I have my delete query ready. Now let me just create my connection and display the results. So I'll go to the top and I'll copy this connection command, which also has the execute query command, and I'll paste it here. And I'm going to make a change here. Instead of update, we'll write delete underscore order. Everything looks good. Let's just run it. You can see our query was successful. And now if you want to print it, let me just show you. I'll just copy this. We'll paste it here. I'll make this as Q9. I want to verify if my order ID 105 was deleted or not. Instead of this statement, I'll write select star from orders, and here I'll change this to Q9. If I run this, you can see it here. You can mark order ID 105 was deleted and it no more appears in this table. Alright, so this brings us to the end of the demo session on SQL with Python. Let me just scroll you through what we did. So first we imported the important libraries, MySQL connector, then we imported the error function, then we imported pandas using PD. We learned how to create a server connection to MySQL database. We created a new database, that is MySQL underscore Python, and now we connected to that database. We created a function to execute our queries. We saw how you can write a create table command. Then we inserted a few records to our orders table. We created a read underscore query command to read the queries and display the results. Then we started exploring our different SQL commands one by one. We saw how to use select query. Then we selected a few individual columns from our table, followed by using a inbuilt function which was year. Then we saw how to use the distinct keyword. After that, we used our where clause to filter our table based on specific conditions. We saw how to order your results based on a particular column. Then we saw how you could convert the table into a data frame using pd.dataframe function. Finally, we learned how to use the update command and the delete command. PostgreSQL is a very popular and widely used database in the industries. In this tutorial, we will learn PostgreSQL or PostgreSQL in detail with an extensive demo session. So in today's video, we will learn what PostgreSQL is and look at the history of PostgreSQL. We will learn the features of PostgreSQL and jump into performing PostgreSQL commands on the SQL cell and pgadmin. So let's begin by understanding what is PostgreSQL. PostgreSQL is an open source object relational database management system. It stores data in rows with columns as different data attributes. According to the DB Engine's ranking, PostgreSQL is currently ranked 4th in popularity amongst hundreds of databases worldwide. It allows you to store, process and retrieve data safely. It was developed by a worldwide team of volunteers. Now, let's look at the history of PostgreSQL. So in 1977 onwards, the Ingress project was developed at the University of California, Berkeley. In 1986, the Postgres project was led by Professor Michael Stonebreaker. In 1987, the first demo version was released, and in 1994, a SQL interpreter was added to Postgres. The first PostgreSQL release was known as version 6.0 or 6.0 on January 29, 1997, and since then PostgreSQL has continued to be developed by the PostgreSQL Global Development Group, a diverse group of companies and many thousands of individual contributors. Now, let's look at some of the important features of PostgreSQL. So PostgreSQL is the world's most advanced open source database and is free to download. It is compatible as it supports multiple operating systems such as Windows, Linux, and Mac OS. It is highly secure, robust, and reliable. PostgreSQL supports multiple programming interfaces such as C, C++, Java, and Python. PostgreSQL is compatible with various data types. It can work with primitives like integers, numeric, string, and boolean. It supports structured data types such as date and time, array, and range. It can also work with documents such as JSON and XML. And finally, PostgreSQL supports multi-version concurrency control or MVCC. Now with this theory knowledge, let's look at the PostgreSQL commands that we will be covering in the demo. So we will start with the basic commands such as select, update, and delete. We will learn how to filter data using where clause and having clause in SQL. We will also look at how to group data using the group by clause and order the result using the order by clause. You will learn how to deal with null values, get an idea about the like operator, logical operators such as AND and OR. We will also explore some of the popular inbuilt mathematical and string functions. Finally, we will see some of the advanced concepts in PostgreSQL, that is, to write case statements, subqueries, and user-defined functions. So let's head over to the demo now. Okay, so let's now start with our demo. So first we'll connect to PostgreSQL using PSQL cell. So here under type here to search, I'll search for PSQL. You can see this is the SQL cell. I'll click on open. Let me maximize this. Okay, so for server I'll just click enter. Database I'll click enter. Port number is already taken, which is 5432. I'll hit enter. Username is already given, and now it is going to ask for password. So here I'll give my password so that I can connect to my PostgreSQL database. So it has given us a warning, but we have successfully connected to PostgreSQL. Alright, so now to check if everything is fine, you can just run a simple command to check the version of PostgreSQL that we have loaded. So the command is select version with two brackets and a semicolon. I'll hit enter. Okay, you can see the version PostgreSQL 13.2. Okay, now let me show you the command that will help you display all the databases that are already there. So if I hit /L and hit enter, it will give me the list of databases that are already there. So we have PostgreSQL, there's something called template 0, template 1, and we have a test database as well. Okay, now for our demo, I'll create a new database. So first I'll write create space database, and I'll give my database name as SQL_demo. I'll give a semicolon and hit enter. You see we have a message here that says create database. So we have successfully created our SQL demo database. Now if you want to connect to that database, you can use \c space SQL_demo. There you go. It says you are now connected to database SQL_demo. So here we can now create tables, we can perform insert operation, select operation, update, delete, alter, and much more. Now I'll show you how to connect to PostgreSQL using pgadmin. So when you install the PostgreSQL database, you will get the SQL cell, and along with that you also have the pgadmin. So I'll just search for pg. You can see here it has prompted pgadmin. I'll click on open. This will open on a web browser. You can see it has opened on Chrome, and this is how the interface of pgadmin looks like. It is a very basic interface. So on the top you can see the files, we have object, there's tools, and we have the help section as well. And here you have dashboard, properties, SQL, statistics, dependencies, dependence, and here on the left panel you have servers Let me just expand this so it will connect to one of the databases. Alright, so if I go back, you see when I had run \L to display the databases, it had shown me PostgreSQL and test. Now you can see here we have the PostgreSQL database and the test database. Alright, now we also created one more database which was SQL demo. So let me show you how to work on this PG admin and the query tool. Alright, so I'll right click on SQL demo and I'll select query tool. I'll just show you how to run a few commands on the query tool. So let's say you want to see the version of PostgreSQL that you are using, so you can use the same command that we did on PSQL cell, which is select version closed with brackets and a semicolon. I'll select this, and here you can see we have the execute button. So if I hit execute or press F5, it will run that query. You can see we have the output at the bottom and it says PostgreSQL 13.2 compiled by Visual C++. It has the 64-bit system. Okay, now let me tell you how to perform a few basic operations using PostgreSQL commands. So here, let's say I'll write select 5 into 3. I'll give a semicolon, select this and hit F5. So this will run the query and it returns me the result, that is the product of 5 and 3, which is 15. Similarly, let's edit this. Let's say I'll write 5 plus 3 plus, let's say, 6. I'll select this and hit F5 to run it. It gives me the sum of 5 plus 3 plus 6, which is 14. Now the same task you can do it on this cell as well. Let me show you how to do it here. So let's say I'll write select. Let's say I want to multiply 7 into, let's say, 10. You know the result, it should be 70. If I hit enter, it gives me 70. Now this question mark column question wall, will deal with this later. Alright, let me go back to my PG admin again. Let me do one more operation. Let's say this time I'll write select 5 multiplied by, and within brackets I'll write 3 plus 4. I'll give a semicolon. So what SQL will do is, first it will evaluate the expression that is there inside the bracket, that is 3 plus 4, which is 7, and then it will multiply 7 with 5. Now let me select this and I'll hit execute. So you can see 7 multiplied by 5 is 35. Alright, now we'll go back to our shell, and here I'll show you how to create a table. So we are going to create a table called movies on the cell, that is PSQL cell. So here we will learn how you can create a table and then you can enter a few data into that table. Alright, let me just scroll down a bit. Okay, so my create command goes something like this. So I'll write create table followed by the table name, that is movies. Next, my movies table will have a few columns. Let's say I want the movie ID. After the column name, we need to give the data type. So movie ID, I'll keep it as integer. So integer is one of the data types that is provided by PostgreSQL. Next, my second column in the table would be the name of the movie. So I'll write movie underscore name. So all the variables or the column names should be as per SQL standards, so there shouldn't be any space between the column names. So I have used underscore to make it more readable. So my movie name will be of type varchar or variable character or varying character, and I'll give the size as 40 so that it can hold 40 characters maximum. Next, my third column will have the genre of the movie. So I'll write movie underscore genre, Again, genre is of type varchar. I'll give the size as, let's say, 30. And my final and the last column will have the IMDb ratings. So I'll write IMDb underscore ratings. Now the ratings will be of type real, since it can have floating or decimal point values. If I close the bracket, I'll give a semicolon and I'll hit enter. There you go. So we have successfully created a table called movies. Now let me go back to my PG admin. Alright, so here I have my database, that is SQL demo. I'll just right click on this and click on refresh. Now let me go to schemas. I'll just scroll down a bit. Here under schemas we have something called as tables. Let me expand this. Okay, so you can see we have a table called movies in the SQL demo database now, and here you can check the columns that we have just added. So our movies table has movie ID, movie name, genre and ratings. Alright, now there is another way to create a table. The previous time we created using the SQL cell. Now I'll tell you how to create a table using the PG admin. So here under tables I'll right click and I have the option to create a table, so I'll select table. Okay, so it's asking me to give the name of the table. So this time we are going to create a table called students. So I'll write my table name as students. Alright, these will be default as it is. Now I'll go to the columns tab. So here you can create the number of columns that you want. So you can see on the right I have a plus sign. I'll just select this so that I can add a new row. So my first column would be, let's say, the student roll number. I'll write student underscore roll number. Again, the column name should be as per SQL standards. The data type I'm going to select is integer. Alright, now if you want you can give these constraints such as not null, so that student roll number column will not have any null values, and I'll also check primary key, which means all the values will be unique for roll numbers. Alright, now if you want to add another column, you can just click on that plus sign, and let's say this time I want to give the student name as my second column. So I'll write student underscore name. Student name will be of type, let's say, character varying. If you want to give the length, you can specify the length as well, let's say 40. I'll click on the plus sign again to add my final column. The final column would be gender. So gender, I'll keep this time as type character. Okay, now you can click on save, so that will successfully create your students table. There you go. So here on the left panel you can see earlier we had only one table, that was movies, and now we have two tables. So one would be added, that was students. So if I expand this under columns, you can see we have the three columns here: student roll number, student name and gender. You can also check the constraints. It will tell you if you have any constraints. So you can see it says students roll number, there's one primary key. Alright, now let me run a select statement to show the columns that we have in the movies table. So I'll write select star from movies, give a semicolon, and let me execute this. Okay, so here on at the bottom you can see we have the movie ID, the movie name, movie genre and IMDb ratings. Now the next command we are going to learn is how to delete a table. So there is one way by using the SQL command, that is drop table followed by the table name. Let's say you want to delete students, you can write drop table students, and that will delete the table from the database. This is one of the methods, so you just select and run it. Now the other way is to you just right click on the table name, and here you have delete/drop. If I select this, you get a prompt, are you sure you want to drop table students? I'll select yes. So you can see we have successfully deleted our students table. Alright, now let's perform a few operations and learn a few more commands in PostgreSQL. So to do that, I'm going to insert a few records to my movies table. So for that, I'll use my insert command. So I have my insert query written on a notepad. I'll just copy this and I'll paste it on my query editor. Okay, so let me just scroll down. Alright, so here you can see I have used my insert command. So I have written insert into the name of the table, that is movies, and we have the movie ID, the movie name, movie genre, and IMDb ratings, and these are the records or the rows. So we have the first record as movie ID 101. The name of the movie is a very popular movie which is Vertigo. Then we have the movie genre, that is mystery. It is also a romance movie. And then we have the IMDb ratings, the current IMDb rating, that is 8.3. Similarly, we have Shawshank Redemption, we have 12 Angry Men, there's The Matrix, 7, Interstellar, and The Lion King. So there are total 8 records that we are going to insert into our movies table. So let me just select this and hit execute. Okay, you can see it has returned successfully 8 records. Now if I run select star from movies, you can see the records that are present in the table. So I'll write select star from movies, I'll select this and I'll execute it. There you go. At the bottom you can see 8 rows affected. If I scroll this down, you have the 8 records of information in the movies table. Alright, now if you want to describe the table, you can go to the SQL cell, and here if you write \D and the name of the table, that is movies, this will describe the table. So here you have the column names, this has the data type, and here you can specify if there are any null values or any constraints like default constant or primary key or foreign key and others. Let me go back to my PG admin. Okay, now first and foremost, let me tell you how to update records in a table. So suppose you have an existing table and by mistake you have entered some wrong values and you want to update those records later. You can use the update query for that. So I'm going to update my movies table and I'll set the genre of movie ID 103, which is 12 Angry Men, from drama to drama and crime. So in our current table we only have genre as drama for 12 Angry Men. I am going to update this column, which is the movie genre, to drama and crime. Okay, so let me show you how to do it. I'll write update followed by the name of the table, that is movies. Go to the next line. I'll write set, then I'll give the column name, which is movie underscore genre, equal to, I'm going to set it as drama, comma, crime. Earlier it was only drama, and I'll give my condition using the where clause. We'll learn where clause in a bit. So I'll write where movie underscore ID is equal to 103. So here our movie ID is the unique identifier. So it will first look for movie ID 103. It will locate that movie and it'll change the genre to drama and crime. So now you can see the difference. Earlier we had 12 Angry Men as drama as the movie genre. Now if I run this update statement, okay, you can see we have successfully updated one record. Now let me run the select statement again. Okay, so here you can see if I scroll down, there you go. So movie ID 103, movie name 12 Angry Men. We have successfully updated the genre as drama, crime. Okay, now let me tell you how you can delete records from a table. So for that you can use the delete command. So you'll write delete from the table name, that is movies, where let's say I want to delete the movie ID 108, which is the Lion King. So I'll write where movie underscore ID is equal to 108. This is one of the ways to delete this particular movie, or you can give, let's say, where movie name is equal to the Lion King. Let me select this and I'll hit execute. Now if I run my select query again, you see this time it has returned 7 rows and you cannot find movie with movie ID 108, that was the Lion King. So we have deleted it. Alright, next we are going to learn about where clause in PostgreSQL. So to learn where clause, I'll be using the same movie table again. Let's say we want to filter only those records for which the IMDb ratings of the movies is greater than 8.7. So this is my updated table now. I want to display only those records or those movies whose IMDb ratings is greater than 8.7. So we'll display 12 Angry Men, which is 9. Then we are going to display The Dark Knight, which is again 9. And we are also going to display the Shawshank Redemption, which has 9.3. The rest of the movies have an IMDb rating less than 8.7. So we are not going to display those. Alright, so let me show you how to write a where clause. So I'll write select star from movies where I'll give my column name, that is IMDb underscore ratings is greater than, I'll use the greater than symbol, then I'll pass my value, that is 8.7. I'll give a semicolon and let's run it. I'll hit F5. There you go. So we have returned the Shawshank Redemption, the Dark Knight and 12 Angry Men because only these movies had IMDb ratings greater than 8.7. Okay. Now let's say you want to return only those movies which have IMDb ratings between 8.5 and 9. So for that I am going to use another operator called between along with the where clause. So let me show you how to use between with where clause. I'll write select star from movies where my IMDb underscore ratings is between, I'll write 8.5, I'll give an AND operator and 9.0. So all the movies that are between 8.5 and 9.0 ratings will be displayed. So let's select this and I'll run it. There you go. So we have returned the Dark Knight, the Matrix, the 7, Interstellar, and we have the 12 Angry Men. So a few of the records that we missed out were, I think, Vertigo, which has 8.3, and there's one more. Alright. Now moving ahead, let's say you want to display the movies whose movie genre is action. So you can see in our table we have a few movies whose genre is action movie. So you can do that as well. I'll write select star from movies where the movie genre, I'm writing this time in one line. You can break it into 2 lines as well. I'll write movie underscore genre, which is my column name, equal to, I'll give within single quotes action. Now why single quote? Because action is a string, hence we need to put it in single quotes. If I run this, there you go. So we had one movie in our table whose movie genre was action, that is The Dark Knight. Okay. Now you can also select particular columns from the table by specifying the column names. Now here in all the examples that we saw just now, we are using star. Now star represents, it will select all the columns in the table. If you want to select specific columns in the table, you can use the column names. So you can specify the column names in the select statement. Let me show you. Let's say you want to display the movie name and the movie genre from the table. So you can write select movie underscore name, comma, I'll give the next column as movie underscore genre from my table name, that is movies, where let's say the IMDb underscore ratings is less than 9.0. So this time in our result it will only show two columns, that is movie name and movie genre. Let me run it. There you go. So these are the movie names and the movie genres you can see that have an IMDb ratings less than 9.0. Alright, like how you saw the between operator, there is one more operator that you can use with the where clause, that is the in operator. So the in operator works like a or clause or an or operator. So let's say I want to select all the columns from my movies table where the IMDb ratings is in 8.7 or 9.0. If I run this, it will display only those records whose IMDb ratings is 8.7 or 9.0. Alright, so up to now we have looked at how you can work on basic operations in SQL like your mathematical operations. You saw how a select statement works. We created a few tables, then we inserted a few records to our tables. We saw how you can delete a table from your database, and we have performed a few operations like update, delete, and we saw how a where clause works. Now it's time to load a employee CSV file or a CSV dataset to PostgreSQL. So I'll tell you how you can do that. But first of all, before loading or inserting the records, we need to create an employee table. So let me first go ahead and create a new table called employees in our SQL underscore demo database. So I'll write create table. My name of the table would be employees. Next, I'm going to give my column names. So my first column would be employee ID. So the employee ID will be of type integer. It is not going to contain any null values. So I'll write not null, and I'll give my constraint as primary key. So the employee ID, as you know, is unique for all the employees in a company. So once I write primary key, it will ensure that there are no repetition in the employee IDs. Okay. Next, I'll have my employee name. So my employee name is going to be of type varchar, and I'll give my size as 40. Okay. Next, we'll have the email address of the employee. Again, email address would be of type varchar and the size is 40 again. I'll give another comma. This time we'll have the gender of the employee. Gender is again varchar of size, let's say 10. Okay. Now let's include a few more columns. We'll have the department column. So I'll write department varchar. Let's say the size is 40. Then let's say we'll have another column that is called address. So the address column will have the country names of the employees. Address is also varchar. And finally we have the salary of the employee. Salary, I'm going to keep it as type real. So real will ensure it will have decimal or floating point values. Okay, so now let me select this create table statement and execute it. Alright, so we have successfully created our table. If you want, you can check by using select star from employees. Let me select this and I'll hit execute. Alright, you can see we have our employee ID as primary key. There's employee name, email, gender, there's department, address and salary. But we don't have any records for each of these columns. Now it's time for us to insert a few records to our employees table. Now to do that, I'm going to use a CSV file. So let me show you how the CSV file looks like. Okay, so now I am on my Microsoft Excel sheet, and on the top you can see this is my employee data.csv file. Here we have the employee ID, the employee name, email, gender, this department, address and salary. Now this data was generated using a simulator, so this is not validated, and you can see it has a few missing values. So under email column we have a few employees who don't have an email ID. Then you can see under department also there are some missing values here as well. Alright, so we'll be importing this table or the records present in this CSV file onto PostgreSQL. Alright, so here in the left panel under tables, let me right click and first refresh this. There you go. So initially we had only movies table, and now we also have the employees table. Now what we need to do is I'll right click again, and here you see we have the option to import or export. Let me click on this, and I don't want to export, I need to import, so I'll switch on import. Alright, now it is asking me to give the file location. So let me show you how to get the file location. So this is my file location actually. So my Excel file, which was this, is present in my E drive under the data analytics folder. I have another folder called PostgreSQL, and within the PostgreSQL folder I have my CSV file, that is employee data.csv. So I'll just select this. You can either do it like this or you can browse and do. Okay, now my format is CSV. Next, I'm going to select my headers as yes, and then let me go to columns and check if everything is fine. Alright, so I have all my columns here. Let's click on OK. You can see I have a message here which says import _ export. Alright, so here you can see successfully completed. We can verify this by using select star from employees again. If I run this, alright, let me close this. There you go, it says 150 rows affected, which means we have inserted 150 rows of information to our employees table. You can see we have the employee ID, these are all unique. We have the employee name, the email, we have the address and the salary. Let me scroll down so that, okay, you can see we have 150 rows of information. That means we have 150 employees in our table. Okay, now we are going to use this employees table and explore some advanced SQL commands. Now there is an operator called distinct. So say if I write select address from employees, this is going to give me 150 address of all the employees. There's some problem here, I did a spelling mistake. There should be another D. If I run this again, our query will return 150 rows. You can see we have the different country names under address, that is Russia, we have France, there's United States, we have Germany, okay, and I think we have Israel as well. Yeah. Now suppose you want to display only the unique address or the country names, you can use the distinct keyword before the column name. So if I write select distinct address from employee, it will only display the unique country names present in the address column. If I run this, see, it has returned us 6 rows of information. So we have Israel, Russia, Australia, United States, France and Germany. Alright, now as I said, there are a few null values which don't have any information. So you can use the isNull operator in SQL to display all the null values that are there. Suppose I want to display all the employee names where the email ID has a null value. So I'll write select star from employees where email is null. So this is another way to use your where clause. If I select and run this, there you go. So you see here, for all these employee names, there was no email ID present in the table. So it has returned us 16 rows of information. So around 10% of employees do not have an email ID, and if you see, a few of them do not have an email ID and also they don't have a department. So if you want to know for those employees which do not have a department, you can just replace where department is null instead of where email is null. Now if I select this, okay, it has returned us 9 rows of information, which means around 5% of employees do not have a department. Moving ahead, now let me show you how the order by clause works in SQL. Now the order by is used to order your result in a particular format, let's say in ascending or descending order. So the way to use is, let's say I want to select all the employees from my table, so I'll write select star from employees order by. I want to order the employees based on their salary, so I'll write order by salary. Let me select and run it. Okay, there is some problem. I made a spelling mistake. This should be employees. Let me run it again. Okay, now if you mark the output, our result has been ordered in ascending order. So all the employees which have salary greater than $45,000 appear at the top, and the employees with the highest salaries appear at the bottom. So this has been ordered in ascending order, which means your SQL or PostgreSQL orders it in ascending order by default. Now let's say you want to display the salaries in descending order so that all the top ranking employees in terms of salary appear at the top. So you can use the DESC keyword, which means descending. If I run this, you can see the difference now. So all the employees with the highest salary appear at the top, while those with the lowest salaries appear at the bottom. So this is how you can use an order by clause. Okay, so now I want to make a change in my existing table. So here, if you see, under the address column we only have the country names, so it would be better if we change the name of the address column to country. So I want to rename a column. You can do this using the alter command in PostgreSQL. So let me show you how to rename this column, that is address. So I'll write alter table followed by the table name, which is employees. Then I'm going to use rename column address. I'll write to, I want to change it to country. If I give a semicolon and hit execute, it will change my column name to country. Now you can verify this. If I run the select statement again, there you go. Earlier it was address column and now we have successfully changed it to country column. Okay, let me come down. Now it's time for us to explore a few more commands. So this time I'm going to tell you how an AND and an OR operator works in SQL. So you can use the AND and OR operator along with the where clause. So let's say I want to select the employees who are from France and their salary is less than $80,000. So let me show you how to do it. I'll write select star from employees where I'm going to give two conditions. So I'll use the AND clause or the AND operator here. I'll write where country is equal to France. Now mark here, I'm not using address because we just updated our table and changed the column name from address to country. So I'll write country equal to France, and my next condition would be my salary needs to be less than $80,000. I'll give a semicolon. Let me run this. Alright, so it has returned 19 rows of information. You can see all my country names are France and the salary is less than $80,000. So this is how you can use or give multiple conditions in a where clause using the AND operator. Now let's say you want to use the OR operator, and let's say you want to know the employees who are from country Germany, or the department should be sales. So I'll write select star from employees where country is equal to Germany, and instead of AND I'm going to use OR. The department should be sales. Okay, now let's see the output. I'll hit F5 this time to run it. Alright, so we have 23 rows of information now. Let me scroll to the right. You can see either the country is Germany or the department is sales. You see one of them in the table. So here for the first record the country was Germany, the second record the department was sales, again for the fourth record the country is Germany. So this is how the OR condition works. So if one of the conditions are true, it will return the result. It need not be that both the conditions should satisfy. Now in PostgreSQL there is another feature that is called limit. So PostgreSQL limit is an optional clause on the select statement. Now this is used as a constraint which will restrict the number of rows written by the query. Suppose you want to display the top 5 rows in a table, you can use the limit operator. Suppose you want to skip the first 5 rows of information and then you want to display the next 5, you can do that using limit and offset. So let's explore how limit and offset works. I'll write select star from employees. Let's say I'll use my order by clause. I'll write order by salary, let's say in descending, and limit it to 5. This is going to display the top 5 employees which have the highest salary. If I run this, there you go. You see it has given us 5 rows of information, and these are the top 5 employees that have the highest salary. Okay, so this is one method of, or one way of using the limit clause. Now in case you want to skip a number of rows before returning the result, you can use offset clause placed before the limit clause. So I'll write select star from employees, let's say order by salary, descending. This time I'm going to use limit 5 and offset 3. So what this query will do is it will skip the first 3 rows and then it will print the next 5 rows. If I run this, there you go. So this is how the result looks like. Okay. Now there is another clause which is called fetch. Let me show you how that works. I'll copy my previous SQL query. I'll paste it here, and here after descending I'm going to write fetch first 3 row only. So my fetch is going to give me the first 3 rows from the top. There you go. It has given us the first 3 rows, and you can see the top 3 employees that have the highest salary, since we ordered it in descending order of salary. Alright. You can also use the offset along with the fetch clause. I'll copy this again and let me paste it here. Now after descending, I am going to write offset, let's say 3 rows, and fetch first 5 rows only. So what this SQL query is going to do is, it will skip the first 3 rows of information and then it is going to display the next 5 rows. It is going to work exactly the same as we saw for this query. Let me run it. There you go. So these are the first 5 rows of information after excluding the top 3 rows. Alright. We have another operator that is called as like in PostgreSQL. So like is used to do pattern matching. So suppose you have a table that has the employee names. You forgot the full name of an employee, but you remember the few initials. So you can use the like operator to get an idea as to which employee name it is. Now let's explore some examples to learn how the like operator works in PostgreSQL. So suppose you want to know the employees whose name starts with A. So for that you can use the like operator. Let me show you how to do it. So I want to display the employee name, and let's say I want to know their email IDs from the table name, that is employee, where since I want to know the employees whose name starts with A, so I'll write employee name like. Now to use the pattern is within single quotes I'll write A and then followed by percentage. Now this means the employee name should have an A in the beginning, and percentage suggests it can have any other letter following A, but in the beginning or the starting should be A. If I run this, so there is an error here. The name of the table is employees and not employee. Let's run this again. There you go. You can see there are 16 employees in our table whose name starts with A. You can see this column employee name, all of them have a letter A in the beginning. Okay, now let me just copy this command or the query. I'll paste it here. Let's say this time you want to know the employees whose name starts with S. So instead of A, I'll write S. So this means the starting letter should be S and followed by it can have any other letter. If I run this, so there are 10 employees in the table whose name starts with S. Okay, let's copy the query again, and this time I want to know the employees whose name ends with D. Now the way to do it is, instead of a percentage, I'll write this time percentage D, which means at the beginning it can have any letter, but the last letter in the string or in the name should be ending with D. Now let me copy and run this. So there are 13 employees in the table whose name ends with a D. You can see it here. Alright, now let's say you want to find the employees whose name contains ISH or have ISH in their names. So the way to do is something like this. So I'll copy this. Now here, instead of a percentage, I'll replace this with percentage ISH percentage. Now this means that in the beginning it can have any letter, and towards the end also it can have any letter, but this ISH should appear within the name. Let me run and show it to you. Okay, so there is one employee whose name contains ISH. You can see here there is an ISH in the last name of the employee. Alright, now suppose you want to find the employee name which has U as the second letter. It can have any letter in the beginning, but the second letter of the employee name should have U. Now the way to do is, I'll copy this, and instead of %, I'll write underscore U followed by %. Now this underscore, you can think of a blank that can take any one letter. So the beginning can start with A, B, C, D, or any of the 26 alphabets we have. Then it should contain U as the second letter, followed by any other letter or letters. Let me run this. Okay, so there are 10 employees in the table whose name has a U as the second letter. You can see these. Okay. Now moving ahead, let me show you how you can use basic SQL functions or inbuilt functions. So we'll explore a few mathematical functions now. So let's say you want to find the total sum of salary for all the employees. So for that you can use the sum function that is available in SQL. So I'll write sum, and inside the sum function I'll give my column name, that is salary, from my table name, that is employees. Let's see the result. This will return one unique value. There you go. Now this is the total salary. Since the value is very large, it has given in terms of E. Now one thing to note here is, if you see the output, the column says sum real. So this output column is not really readable. So SQL has a method which can fix this, that is called an alias. So since we are doing an operation of summing the salary column, we can give an alias to this operation by using the as keyword. So if I write sum of salary as, let's say, total salary, then this becomes my output column. You can see the difference if I run this. Okay, you can see now in the output we have the total salary. Now this is much more readable than the previous one. So this is a feature in Excel where you can use or give alias names to your columns or your results. Now similarly, let's say you want to find the average of salary for all the employees. Now SQL has a function called AVG which calculates the mean or the average salary. If I write AVG, and I can edit my alias name as well. Let's see, I'll write mean salary. Let's run it. You can see the average salary for all the employees. It's around $81,000. Okay. Now there are two more important functions that SQL provides us, which is max and minimum. So if I write select maximum or max, which is the function name of salary, as, let's say, instead of total I'll write maximum. So this will return me the maximum salary of the employee. Let's run it and see what is the maximum salary that is present in the salary column. Alright, so we have $1,19,616 as highest salary of one of the employees. Similarly, you can use the min function as well. I'll just write minimum, and this will return me the minimum salary of one of the employees in the table. I'll replace the alias name as minimum. Okay, now run it. This will give me the minimum salary that is present in our table. So it is $45,685. Okay. Now let's say you want to find the count of department in the employees table. You can use the count function. So if I write select count, let's say I want to know the distinct department names, I can write inside the count function distinct department as total departments from employees. Let's run this. this will return me the total number of departments that are there. So it gives me there are 12 departments. Okay, now let me show you one more thing here. If I write select department from employees, let's run this. Okay, so it has returned me 150 rows of information, but what I'm going to do is I'll place my distinct keyword here just before the column name so that I can verify how many departments are there in total. There you go. So there are 13 departments and one of them is null. So moving ahead, we'll replace this null with a department name by updating our table. Okay. So now let's update our department column. So what we are going to do is, wherever the department has a null value, we are going to assign a new department called analytics. So earlier we have also learned how to use the update command. So I'm going to show it again. So we'll write update followed by the table name, that is employees. I'm going to set my column, that is department, equal to, within single quotes, my name of the department would be analytics, where department is, I'll say null. So wherever the department has a null value, we'll replace those information with department, that is analytics. Let's run this. You can see query returned successfully. Now let's say I'll run this command again, and this time you can see the difference. There you go. So we have 13 rows of information and there is no null department now. We have added a new department, that is analytics. Okay, now we are going to explore two more crucial commands or clauses in SQL, that is group by and having. So let's learn how group by clause works in PostgreSQL. So the group by statement groups rows that have the same values into summary rows. For example, you can find the average salary of employees in each country or city or department. So the group by clause is used in collaboration with the select statement to arrange identical data into groups. So suppose you want to find the average salary of the employees based on countries, you can use the group by clause. So let me show you how to do it. I'll write select. I want the countries and the average salary for each country. So I'll use the average function, that is avg, and inside the function I'll pass my column, that is salary. I'll give an alias name as, let's say, average underscore salary, from my table name, that is employees. Next I'm going to use my group by clause. So I'll write group by, since I want to find the average salary for each country, so I'll write group by country name. Let's give a semicolon and let me run it. I'll use F5. There you go. So here on the left you can see the country names. We have Israel, Russia, Australia, United States, France and Germany, and on the right, the second column, you can see the average salary for each of these countries. Now you can also order the result in whichever way you want. Suppose you want to arrange the results based on the average salary, so you can use the order by clause after the group by clause. So I'll write order by. Here you can use the alias name, that is average salary. This is actually average underscore salary, and let's say I want to arrange it in descending order, so I'll write DESC. Now let's run this. You can mark the difference in the average salary column. There you go. So as per our result, in United States the average salary is the highest, and if I scroll down, the average salary is the lowest in Germany. Now let's see one more example using group by. Suppose this time you want to find the maximum salary of male and female employees. You can do that too. So let me show you how to do it. So I'll write select. This time we want to find the maximum salary based on gender. So I'll select my gender column, comma, and this time I'll use my max function since I want to find the maximum salary for male and female employees. I'll give an alias name as maximum underscore salary from my table that is employees, group by, I'll write gender. Okay, so let's run this. There you go. You can see, so one of the female employees had a highest salary of $1,19,616, while of that of a male was $1,17,654. Alright, now suppose you want to find the count of employees based on each country. You can use the count function along with the group by clause. So I'll write the select statement, select, since I want to count the employees based on each country, so I'll first select my country column and then I'm going to use the count function. I'll write count emp underscore id from my table name that is employees. I'm going to group it by country. So this query will give me the total number of employees from each country. You can see here Israel there are 4 employees, in Australia there are 4 employees, in Russia we have 80 employees, in France there were 31, in United States we have 27, so on and so forth. Now let me scroll down. Okay, now it's time to explore one more clause, a very important clause that is used in PostgreSQL, that is having. So the having clause works like the where clause. The difference is that where clause cannot be used with aggregate functions. The having clause is used with the group by clause to return those rows that meet a condition. So suppose you want to find the countries in which the average salary is greater than $80,000. So you can use the group by clause and the having clause to get the result. So I'll write my select statement as select country, comma, I want the average salary, so I'll write avg of salary. I can give an alias name as average salary from employees. Now I'm going to group it by each country, so group by country column. Since I want to find the countries in which the average salary is greater than 80,000, so I'll use having clause after the group by clause. I'll write having average of salary is greater than 80,000. Now this condition cannot be specified in the where clause, so we need a having clause. You cannot use aggregate functions along with where clause. Let me just run it now. There you go. So we have Russia and United States where the average salary is greater than $80,000. Alright. Now let's say you want to find the count of employees in each country where there are less than 30 employees. So for this I am going to use the count function. First let me select the country column. Then I'm going to use the count function, and in the count function I'm going to pass my employee ID so that we can count the number of employees from my table that is employees. Now if you want you can use an alias name for this as well, but I am just skipping it for the time being. I'll write group by country. Next I'll write having count of employee ID less than 30. So this will return me the countries in which there are less than 30 employees. Let's run it. You can see here Israel, Australia, United States and Germany are the countries in which there are less than 30 employees. Okay, now if you want you can use the order by clause as well. So suppose I'll write here order by count of employee ID. So what this will do is it will arrange my result in ascending order of employee ID count. There you can see we have successfully arranged our result in ascending order of employee IDs. Okay. Next, we are going to explore one more feature of PostgreSQL, that is of using a case statement. Now in PostgreSQL, the case expression is same as if-else statement in any other programming language. It allows you to add if-else logic to the query to form a powerful query. Now let me just scroll down and I'll show you how to use a case statement. This is very similar to your if-else statement that you use on Excel, in C++, in Python, or any other programming language. So what I'm going to do is I'm going to write a SQL query that will create a new column, and the name of the column would be, let's say, salary range. So I'm going to divide my salary. Suppose if the salary is greater than $45,000 and if it's less than $55,000, in the new column, that is salary range, we are going to assign a value low salary. Now if the salary is greater than $55,000 and if it is less than $80,000, we are going to assign a value that is medium salary. If the salary is greater than $80,000, we'll assign a value high salary. So all this we are going to do using our case expression in PostgreSQL. So I'll start with my select statement. But before that, let me show you how to write a comment in PostgreSQL. So you can write a comment by giving a double dash. Comments are very helpful because they make your codes or the scripts readable. I'll write case expression in PostgreSQL. Similarly, if you want, you can go to the top and let's say here you can write with double dash having clause. Okay, let's come down. So I'll write my select statement as select. I want the department, the country, and the salary column. I'll give a comma and I'll start with my case statement. I'll write case when my salary is greater than 45,000 and my salary is less than 55,000, then the result would be, within single quotes, I'll write low salary. So this is exactly like an if-else condition. Next, I'll write another case when salary is greater than 55,000 and salary is less than, let's say, 80,000, then the result would be medium salary. And finally, I'll give my last condition, that is when salary is greater than 80,000, then the result will be high salary. Let me write this in a single line, then high salary. Now one thing to remember, in PostgreSQL the quotes are insensitive, so you can write your select statement in capital, in lowercase, or in sentence case. Similarly, I can write case as small c, or you can write as capital C. Alright, now moving ahead, after this I am going to write end. I'll give an alias name as salary range. Now this is going to be my new column in the output. Let me just come down. After this, we need to give our table name from employees. I'll order it by salary descending. Okay, So what I'm going to do here is I'll first select department, country and salary column from my employees table, and then I'm creating a new column that is salary range, and I'm specifying the range. So I have three conditions here for low salary, for medium salary and high salary. So let's run this and see the output. There you go. Here you can see we have added a new column known as salary range, and we have ordered our salary in descending order, so all the highest salaries appear at the top. If I just scroll down, you can see we have medium salaries here, and if I scroll down further, you can see these low salaries. So case statements are really useful when you want to create a new column based on some conditions in the existing table. Alright, now moving ahead, we are now going to see how to write subqueries in PostgreSQL. So subqueries, we write a query inside another query, which is also known as nested query. So suppose we want to find the employee name, department, country and salary of those employees whose salary is greater than the average salary. So in such cases you can use subqueries. Now let me show you how to write a query inside another query. First I'll write the select statement. I am going to select the employee name, comma, I want the department, comma, I also want to display the country name and the salary from the employees table, where my salary should be greater than the average salary. So after this where salary greater than, I am going to use brackets and write my subquery, that is select average salary from employees. Now let me break it down for you. So first we are going to select the average salary from the employees. So this particular SQL statement will find the average salary from the table. We will compare this average salary with salaries of all the employees. So whichever employee has the salary greater than the average salary will display their names, the department, country and their original salary. So if you want, you can run this statement as well. Let me select this statement and run it for you. You can see we have written the average salary of all the employees, which is nearly $81,466. So we want the salaries of the employees to be greater than this average value. So let me run this and see how many employees have a salary greater than the average salary. There you go. So we have around 75 employees whose average salary or whose salary is greater than the average salary. Alright, now moving ahead, this time I'm going to tell you how to use some inbuilt functions. We'll learn some inbuilt mathematical functions and string functions that are available in PostgreSQL. So I'll just give a comment. There's another way to write a comment. Instead of a double dash, you can use the / an asterisk, and inside the asterisk you can write, let's say, SQL functions, and you need to close this. So I'll give another asterisk and a /. So this is also a comment in PostgreSQL. Alright, so first of all we'll explore a few math functions. So there is a function called ABS which is used to find the absolute of a value. So if I write select ABS of, let's say, -100, it is going to return me +100 or just 100, because as you know, the absolute of any value will remove the negative sign involved in that value. There you go. So our original input was -100, the absolute of -100 is +100. Next, let's see another function that is called greatest. So the greatest function in PostgreSQL will return the greatest number in a range of numbers. So suppose I write select greatest. Inside the greatest function, I'll pass in a few numbers, let's say 2. I'm just randomly passing a few numbers, let's say 490, let's say 56.5, and let's say 70. I'll give a semicolon. Let me run this. You will see the greatest function will return the greatest integer value or greatest number that is present in the range of numbers that we have provided. So in this case 90 was the largest number or the greatest number, so we got the result as 90. Again, you can use an alias for each of these statements. Now like greatest, we also have a function called least, which is going to return the least number present in a range of numbers. If I run this, so the result is 2 because 2 is the least number that is present in this selection. Alright, now there's a function called mod which is going to return the remainder of a division. So suppose I write select mod, and this takes two parameters, let's say 54 divided by 10. As you can guess, the remainder is 4, and so is our result. You can see it has returned the remainder 54 divided by 10, the remainder is 4. Alright, if I scroll down, now let's see how to use the power function. So I'll write select power, let's say I want to know power 2, 3, which is 2 cube, that is 8. Let me just run this. There you go. So the result is 8. You can also check, let's say power of 5, 3, it should be 125. Alright. Next, you can use the sqrt function that is available in PostgreSQL to find the square root of a number. I'll write sqrt, and let's say I want to find the square root of 100. You can guess the result. The output should be 10. If I run this, you can see the output here 10. Let's say I want to find the square root of, let's say 144. You can again guess the result. It should be 12. Let's verify it. Okay, there is some error. Let me verify it again. There you go. It is 12. Now there are a few trigonometric functions as well. You can use the sine function, the cos function, and the tan function. Let's say I want to know the sine of 0. If you have studied high school mathematics, you would know the sine of 0 is 0. You can see the result, it is 0. Let's say you want to know sine 90. If I run it, you can see the output here 0.89. Alright. Now there are other functions like ceiling and floor that you can use. So let me show you what the ceiling and floor function does. I'll write ceiling. Let's say I'll pass my floating value as 6.45 and let me run it. You can see the ceiling function returns the next highest integer, that is 7 in this case, since the next highest integer after 6.45 is 7. Let's see what the floor function does, and let me run it. As you can see, the floor function returns the next lowest integer, that is 6 in this case, or the nearest lowest integer to any provided decimal value. Okay. Now that we saw how to use mathematical functions, there are a few string functions available in PostgreSQL. So let's explore them as well. I'll write string functions. Okay. We'll scroll down. Cool. There's a function called character length that gives you the length of a text string. Suppose I write select, give the function as character length, and inside this function I am going to pass in a text. Let's say India is a democracy. This is my text. Let me run this. Okay, you can see the result here, which is 20, since there are 20 characters in my string that I have provided. Alright. Now there's another function called concat in PostgreSQL. So concat is basically used to merge or combine multiple strings. So I'll write select concat, within brackets I'll give the text string. Now let's say I want to combine PostgreSQL I'll give a space, comma, I want to merge PostgreSQL is, I'll give another comma and write my final word, that is interesting. Now what we have done is, inside the concat function we have passed in separate strings, and now using the concat function we want to merge the three strings. Let's see what the result is. I'll run it. Alright, let me just expand this. You can see here we have concatenated the three strings successfully, so the output is PostgreSQL is interesting. Okay. Now there are functions like left, right and mid in PostgreSQL. So what the left function does is, it will extract the number of characters that you specify from the left of a string. Let's say I'll write select left and I'll pass in my text string as India is a democracy. I'll copy this and I'll paste it here. Let's say I want to extract the first 5 characters from my string, so I'll give 5. So what it will do is, it will count 5 characters from left, so 1, 2, 3, 4 and 5. If I run this, it should ideally print India for me. There you go, it has printed India for us. Alright, similarly you can use the right function to extract few characters from the right of a string. Let's say you want to extract, let's say I'll give 12 characters from right, so from here onwards it will count 12 characters. I'll change left to right now. Let me select this and run it. So you can see here, this is the output. From the right it has counted 12 characters and returned a democracy. Okay. Now there is a function called repeat. So the repeat function is going to repeat a particular string the number of times you specify. Let's say I want to select and use my repeat function, and inside the repeat function I'm going to pass in, let's say India, and I want India to be displayed 5 times. I'll give a semicolon and run it. In the output you can see India has been printed 5 times. Okay, let's scroll down. There is another function, a string function in PostgreSQL called as reverse. So what reverse function is going to do is, it is going to print any string passed as an input in reverse order. So if I write select reverse, and inside the reverse function I'll pass in my string, that is India is a democracy. I'm going to use the same string. I'll copy this and I'll paste it here. I'll close the quotes and the brackets. Let's print this. You can see it here. India is a democracy has been printed in reverse order. There you go. Alright. Now this time we explored a few inbuilt functions that are already present in PostgreSQL. Now PostgreSQL also has the feature where you can write your own user-defined functions. So now we will learn how to write a function of our own in PostgreSQL. So let's create a function to count the total number of email IDs that are present in our employees table. So for this we'll write a function, a user-defined function. So let me give my comment as user-defined function. Okay. So let me start by first writing create. So this is the syntax to write a function in PostgreSQL. So I'll write create or replace function. Then I'll give my function name as count emails. and as you know, functions have brackets. Then I'll write returns, the return type, as integer, then an alias with dollar symbol. I'll write total emails, since I'm going to display the total number of email IDs that are present in my table. I'll close the dollar symbol. Then I'm going to declare a variable. The variable name is going to be total underscore emails. This is of type integer. I'll write begin, and inside begin I'll write my select statement. So I'll write select. I want to count the email IDs that are present, so I'll pass my column name, that is email, into total emails from my table name, that is employees. I'll give a semicolon, and then we'll write return total emails. As you know, user defined functions often return a value, so hence we have mentioned the return statement as well. And now I'm going to end my function. Then the next syntax would be, let me just scroll down. Okay, so here I'll give my dollar symbol again, followed by total underscore emails. Next I'll write my language PostgreSQL. So the way to mention is PL PG SQL. Let's give a semicolon and end it. So this is my user defined function that I have written. So I created a function with the function name count underscore emails, and this would return integer as an alias, which is total underscore emails. We declared that variable as an integer. Then we started with a begin statement that has my select statement, where I am selecting the count of email IDs that are present in the employees table, and I am putting the value into total underscore email. So I have used the into keyword, and this returns the result as total underscore emails, and I have ended. Let's run this. Okay, there is some problem. There is an typo, so this should be integer. Okay, let me run it once again. There you go. So you've successfully created a user defined function. Now the final step is to call that function. Now to call this function, I'm going to use my select statement and the function name, that is count underscore emails. I'll give a semicolon. Let's execute this. There you go. So here you can see there are 134 email IDs present in our employees table. Now one thing to mark is there are total 150 employees in the table, but out of them 134 employees have email IDs, the rest of them don't have, so they would ideally have null values. Alright, so that brings us to the end of this demo session on PostgreSQL tutorial. Let me go to the top. We have explored a lot. So we started with checking the version of PostgreSQL. Then we saw how to perform basic mathematical operation, that is to add, subtract, multiply. Then we saw how to create a table that was movies. We inserted a few records to our movies table. Then we used our select clause. We updated a few values. Then we deleted one row of information. Then we learned how to use the where clause. We learned how to use the between operator. We also learned how to use the in operator. Let me scroll down. We created a table called employees, and then we learned how the distinct keyword works. We also learned how to use isNull with where clause. We learned about the order by clause. We saw how to alter or rename a column. Then we explored a few more examples on where clause, where we learnt about and or operator. Then we learnt how to use limit and offset, as well as the fetch operator or the fetch keyword in PostgreSQL. Moving further, we learnt about the like operator in SQL, which was used to perform pattern recognition or pattern matching, you can say. Here we saw how to use basic inbuilt PostgreSQL functions like sum, average, minimum, count, maximum. Next, we saw how to update a value in a column using PostgreSQL update command. We learned how to use group by. Then we learned how to use having clause. Then we learned how to use case expressions in PostgreSQL. So we saw how case expression is similar to our if-else in any other programming language. We explored a few mathematical and string functions. And finally, we wrote our own user-defined function. So that brings us to the end of this tutorial on PostgreSQL.
In this session, we will learn about how to join 3 or more tables in SQL. That's right. So far we have a fundamental understanding of how to join 2 tables. But in a few situations, you might have to extract the data by joining 3 or more tables, right? So that's exactly what we are going to discuss today. Now, without further delay, let's get started. Now, we will jump into the MySQL workbench where we have our query ready. So here we will be using 3 tables: employee details, employee register, and employee joining register. So we want employee name, contact number, and joining date. Joining date is available in joining register, contact number is available in employee register, and employee name is available in employee details, right? So here we are utilizing all 3 tables and joining them to extract these 3 columns. So here I'm providing the table name and the column name to make sure that the SQL workbench will not get confused which employee name column should I access, which table should I use. So to clear that confusion, I'm providing the table name. So MySQL will use employee details table, and from there it will extract the employee name column. And contact number, to be sure it is present in only one table, so it will go to employee register. And joining date, it is also present in only one table, so no need to specify the table name. But to be on safer side, if you want to add, you can add, that's well and good, and it will create an impact to your interviewer considering that you know about the syntaxes. So I'll just follow the normal syntax the way I'm going now. And now I'm trying to join. It's the same operation what you use to join 2 different tables. So you'll just use the join clause and give the second table name and on what basis. So I'm joining these 2 tables on the primary key employee ID. So both tables have the same common employee ID. So based on that, I'm joining these 2 tables, and then you will use the join clause once again and give the third table name here, and based on which primary key or which common key. So this is the one which is common in both the tables and is unique, which is the employee ID. So I'm using the same one to join the 2 tables with the third one. You can follow the same syntax and join another table to it as well. So with this, let's execute this particular query to find our answer. So there you go, you got the query executed and you have the table over here with employee name, contact, and joining date. Let's quickly get back to MySQL workbench. So here, let's say you wanted to create a table and load the data. So if the data is minimalistic, maybe the data about 10 rows or 15 rows, you can manually create a table and insert the elements into your table using such insert commands. But this set, like mine, which is in the Excel spreadsheet and has about 10,000 rows, would you like to, write 10,000 insert commands? No, right? It would be really time consuming. So for situations like this, MySQL Workbench has enabled developers to load the data from spreadsheets within a few steps. But before we get started, let's check our column headers. So here you can see it is not compatible with the MySQL Workbench or SQL commands, right? So it has a space and it has a word row and it is a keyword in MySQL, right? So we don't want that confusion. So for that reason, we will try to modify this maybe using an underscore, right? Similarly, for the row ID, you can eliminate space and use an underscore. And when it comes to order ID, the same. So just let us quickly change all the column headers so that they are SQL compatible. There you go. So we have replaced all the row headers with underscores and made them SQL compatible. So let us save it. And when you're saving it, just make sure that your Excel file data is also having the SQL compatible name. So here we have load CSV to MySQL. So here we have the name with space, right? So let's try to change that to lowercase Excel data, and right now it is SQL compatible. Now quickly let's go back to MySQL workbench. Here we have it. Now you can just create a new table. Just right click here, or you can also do it from here. Create a new database, and the new schema will be the name of your dataset. So let's type it as Excel data or just Excel, and apply. Now this is the schema. Apply. Now you have Excel right here. Just drop down, and here you can see the tables. Right click the tables, and here you have the option of import data wizard, right? Just click on that. Now browse your folders and have it. So yeah, another notification for you guys. So you need to save your Excel spreadsheet in the form of comma separated file, right? Let's quickly go back and do that. Open your spreadsheet, go to file, save as comma separated file, save. There you go. Now let's get back to workbench, and now I think you will be able to find it. Just open, next, drop table if exists. Make sure you do that to be on the safer side, and check all the names here. So we have a problem with row ID, but that is something which you can fix down the line. And before you go to the next step, check all the other names as well. Every other name on the column header is fine. Just the first one we can just alter the table, not a big deal. And next, it should start importing. There you go. The data file got imported. Of course, it took a little while because it's 10,000 rows. That's normal. Now let's quickly go to the next step, and here you can see 9,987 records imported successfully. Just click on finish, and I think it should be shortly done. Let's close the schema, go to the query table, and yeah, so you can quickly refresh so that you will have the Excel data over here. Now let's use the database, that is Excel. Now we are in Excel database. Now the table we are looking for is select star from the data name. The data table name is Excel data without a space, semicolon. Just quickly run it, and I think we should be shortly able to see all the data sets right over here. Yeah, about the first column ID, we can simply use the alter table function or query to change the name. Let's quickly do that with the table name, alter table, rename. Okay, what was this? Can you copy that? Copy field name, rename row ID to. So a small syntax error there. So I think they should be sorted. Yeah. And now let's quickly run this, and I guess it should be done. Now let's quickly run the select command again. There you go. So we have the row ID, order date, ship in mode, customer ID, customer name, etc. And everything is as per the expectations. And that's how you can load Excel data to MySQL workbench. We will learn about the top 5 interview questions in SQL that you must know to crack your business analytics interviews. Now, without further ado, let's get started. So speaking about the top 5 interview questions, let's quickly jump to the workbench of SQL. So I'm using MySQL workbench, and here we have a database called use Simplilearn. So SLP is the database name. So we'll be using the use command to get access to that particular database. So we are in access to it. And now let's quickly check our tables. Show tables. There you go. We have a few tables here: book collection, book order, employee details, joining register, and employee register. So let's go with the employee details. So I'll just simply shoot a command, select star from EMP details. So now we have our employee table. So we will be using this particular data set to run few queries from our interview questions. So getting back to the interview questions. So most commonly you will be asked the following interview questions. So the first question is, you will be asked to find out the names of the employees that start with the vowels. So A, E, I, O, U. So they will ask a question, give me the list of names that start with these 5 letters. It can be either A or E or I, O, U, right? So what's the question? So here you will be using like operators and not like operators. Let's say they want the names with vowels. So you can just use the like operator and use this particular command. Select employee name, that's the name of the column, from employee register or employee details, and then where employee name is like A modulus, which means it should start with A and it can have any number of alphabets after that, right? So let's quickly also check what do we have in employee register. So I think it's a similar table to employee details that we used before. We have the same details here, so no problem. Now let's try to extract the names of the employees whose names start with vowels, right? So we will be using the where clause and like operators. Run the command and there you go. So we have 3 names. So if you're able to answer this question, they might ask a similar question with a little modification. So this time they might ask you, give me the list of names that will not start with vowels. So you'll just replace the like operator with not like. So either they'll ask the questions which might start with vowels, or they might ask a question which does not start with vowels. This is one of the common questions. Now going to the second question. So here also they will give it a simple start. They will ask to give the details of the employee who has the highest salary, or they will ask you to give the highest salary. You can simply use the max aggregation and you can get the maximum salary. So we have $87,000. And sometimes if you are able to answer this question, they will make it a little tricky to you and they will ask, give the second highest salary. Here you can use offset, or there are multiple possibilities, but let me give you the simplest one where you can have the same query. Only difference is where salary is less than max of salary. First, the subquery will be executed which will extract the maximum salary, and the next one is less than. So it will give you only one row which has a little salary which is less than the maximum one, right? So simply let's execute the query. So we will have the answer. So the next highest salary is $78,000. Now moving on to the third question. So sometimes they will ask you to use the update commands as well. So here we have some salary details of our employees in the employee register. What I'm going to do here is, let's say this is the appraisal period and they're giving you 15% hike to all the employees. So you need to update the salary column. So what you do is simply update table name salary plus salary into the percentage of hike, which is 15%. So here we are adding that particular percentage in the form of decimal numbers, which is 0.15, and simply run the command and you have it. Now you can just simply query the same detail, which is select star from employee details. So you will have the updated salary list here. There you go. Now let's proceed with the next question that we have in our list, which is about select the employee name and salary from a given range, right? If they ask you, give me only the range of employees whose salary lies between 50,000 to 70,000. So you can use the between operator here and range of numbers, that is 50,000 and 70,000. Just run this particular code and there you go. You have the details. So there are 2 employees whose salary lies between 50,000 and 70,000. Now the last question is, they might ask you to extract the details from a certain department. So basically, this might also turn up to find a difference between having and group by clause. Having and where clause. Yeah. So this is one of the common interview questions where they will ask the difference between having and where clause. So when you are implementing group by in your query and you're also implementing some aggregate functions like count, sum, etc., minimum, maximum, In those situations, when a group by clause is involved, then you can use having. When there is no group by function, then you can simply go with the where clause. So here I'm trying to extract the number of people present in finance department. So I'm not grouping by department, so I can just use where clause and run this. And now in situations where I have to group by, when I have to implement group by, in those scenarios, you can include having clause in place of where. So that is the fundamental difference between having and group by. And also you got the understanding of group by command here.
Imagine walking into a giant library. This isn't just any library, it's huge. There are rows and rows of shelves, each packed with thousands of books. But wait, you don't need to read every book here. You're just looking for specific ones like books about space or stories about superheroes. But finding what you need is such a huge library. That's going to be tricky. This massive library is like a database. A database is a huge collection of information stored neatly, ready to be used. It holds everything: name, address, grades, prices, whatever data you can think of. But sometimes all that information can be overwhelming. You don't want to shift through everything every time. You need something specific, right? That's where views comes in. In this video, we will explore views in SQL, explaining what they are and how they simplify working with databases. We'll also cover how to create views, manage them by updating, deleting, and listing them, and also introduce different types of views like simple, complex, read-only, and those with check option. We'll also dive into materialized views which store data for faster queries. And by the end, you will understand how views can manage data easier and more efficient. We will also look into a quiz question to clarify your understanding. So, what exactly is a view? Let's go back to our library example. Imagine if you had a magic window, a special one that only shows you the books about space or superheroes that you are interested in. You don't have to wander through the entire library anymore. You just look through your magic window and it gives you exactly what you need. That magic window is what a view is in the world of databases. A view is a special virtual window into a data that shows you only what you need to see. And the best part is, it's not actually storing any new data. It's giving you a filtered look into a huge database. Think of view as a shortcut, making your life a whole lot easier. So let us get into the demo part about how to creating a view and the types of views in SQL.
So let's start with the demo part, that is how do we create a table in MySQL. So here, as you can see, I've just logged into an online compiler, and now we will just learn how we create a table, and then we'll move on to creating views and the types of views. So first, to create a table, just enter this command, just write over here, create table, and this, just enter the table name. It could be something like student details, and here you can give the student ID name. We want a student ID name in the first row, so we'll just keep SID, and the type of the variable is integer, so we'll just mention int over here. And since it's a primary key, we'll just mention it over here, primary key. Next variable can be something like name, and for this the type is varchar. You can just enter any number here. Suppose I've entered 255. Comma. Next, mention the address. Again, it's varchar address. So as you can see, we have created this table with student ID name. So we have to give your underscore. Student ID name with primary key integer type, and the name and the address over here. So after we have created this table, we want to insert data into the table. This is our next step. So to insert data, what could be the basic command which you can write? Can be something like insert into student, the table name, student details over here, and just mention what all columns which we have, attributes we have created, which is S underscore ID. Next is name, and then we have address over here. and then we mention the values. So now that we have created table, and then we can enter our details over here. So these are the values which I've inserted, which is Harsh, Ashish, Pratik, Dhanraj, Ram. Okay. So like this, you can enter the values over here. And now if I want my records to be displayed here, the command which I'm using is select star from student details. So all these, the table will be shown here. So we'll just click on this run button over here. Okay, so now you can see this is the SID name, number, and the names which we have mentioned over here. So as you can see, this is the output generated. This is the SID, the name, and here is the address. So as you can see, the table is created now, and the output is also shown. Now we will move on to the main step, which is creating a view. So what exactly is a view? A view is like a window that lets you see specific data, as I've already told you in the intro part. So now let's say we only care about students with SID less than 5. Okay. And instead of running the same query every time, we want to create a view. So here's how you can do it. You can just simply enter a command. So here's how you can create a view. So just mention this command, which is create view detail view as select name, comma, address from student details. So student details is the table here which we have already created before. And I want the student ID less than 5. Okay. So I want this to be shown here. So we'll just simply click on run over here. So as you can see, this is the error it's showing. Why is it showing? Because line number 20, create view, must be the first statement in a query batch. So to resolve this, we have to ensure that the SQL batch is properly separated by go command and the view creation is syntactically correct. Alright, so we haven't used the go command here to do that. We just simply, after we have inserted our records in the table, here you just type go, okay, and so this is the end of the first batch. And now since we have created a view in a new batch, we'll just mention this whatever command we have already given, and at the end of the second batch we'll again write go. Okay, and now next I want my query to be shown here, so I'll just write this command for generating my output, which is select star from and the table name. Okay, not that student details table name. I want the view table name to be shown, which is detail view, right? This is the table name. So just copy it from here. Just paste it. Just give this semicolon. So now you can see our view is created. So why have we used go? Because go ensures that the create view command is executed in a new batch, and this will help the SQL server properly separate commands and avoid conflict. Alright, and we have also used the select star from details view, which will fetch the data from the view and includes only student with student ID less than 5, which is Dhanraj, Pratik, Ashish and Harsh. Okay, name and the address is displayed over here. So this is our output generated. Now let's talk about managing views and updating the view. Let's say later on you want to update the view to also include the student's age. Instead of deleting or recreating the view, you can use create or replace view to update it. So let's add the age column to the table now. So we have to just insert the data for the students here. So to add a new column age to the student's detail table, we need to use this command, which is alter table, and then provide the name of the table, which is student details, add age, and the type is integer, and give the semicolon over here. Alright, and now we have to insert the age data for the student. So to do this, we will use the update command, and here we will just write this update, okay, name of the table, which is student, and here we use set age is equal to 19, where ID is equal to 2. No, sorry, with SID is equal to 1. So in a similar way, you have to just update all the table over here. So after updating it, you can just simply search run here. So like this, you will just update the student details and set the age accordingly. And now the next step is, after updating it, we have, as you can see, we have just entered all the age number which we want to be displayed here. And we have used the insert to command to insert records into the table with the age values. And now in order to select it, we will give the command which is select star from and the name of the table which is student details. And now if we want to end this batch, we have to use this go command, enter. So now as you can see, we have updated and inserted all the age data for the student, and we have selected all the data from student details to display the final result by giving this command which is select star from student details, and this is the name shown over here, and here is the address, and this is the age. So we have inserted all the age data, and we have also corrected the update statement. Set age is equals to 19, where SID is equals to 1. And do not forget to add this go. Okay. Now, the next thing which we will be talking about is deleting a view. In order to delete a view, you just simply have to give this command, which is drop view if exists, and then give the name and the table name, which is detail view, right? And just simply you can go to this, just run, and you can see that our table has been dropped. Okay, so now we have deleted our table just by giving this command now. So, and do not forget that this command will delete the view, but don't worry, the data in the original student details table will not be affected. Only the view table which we have created is deleted. And now next we will be talking about listing all the views. Okay, so now in order to list all the views, just you have to simply write this command, which is show full tables where table type is equals to VIEW, view. So by doing this thing, this output will give you all the views which we have created in this table, the name, student ID, okay, and the addresses, and also the age. Okay. So it will give you all the view table which we have created. Now let's move on to the main part, which is the types of views in SQL. Now let us first understand what is a simple view. So a simple view is created from a single table. It's straightforward and it doesn't involve complex logics like joins or subqueries. For example, to create a simple table, you just simply have to write this command, which is create view student names as, and then select name from student details. Okay, so if you query this view and then write select star from student names. Okay, so after doing this thing, you just simply click on run. So after we have written this view, simple view, which is create view student name as, select name from student details, and do not forget again to mention this go, and then select query the simple view to display student names and select star from student names. Alright, and at last again add this go, and here this is the output generated, the names. Alright, so by using simple query you can do this thing. Now let's move on to the second part, which is creating a complex view. A complex view involves multiple tables or complex logic. Let's say we have another table known as student marks that stores student marks. So let's say So let's say we have created this table student marks and we have given the details here. And again, we have inserted the data values, student ID, marks, 193. These are the values which we have inserted. This is the student ID and these are the marks which we have given. Alright. So now let's create a view that pulls data from both student details and student marks. So now as you can see, we have created a complex view by providing all these details, and this is the student ID and the marks shown over here. Alright. So now let's move on to the third part, which is read-only view. So a read-only view ensures that no one can modify the data through the view. This is useful when you want users to able to see the data but not change it. To make the view read-only, you can use permissions in your SQL databases, and this feature depends on your database engine. To create a read-only view in SQL Server, we cannot directly enforce read-only behavior with the create view statement. However, you can control access to the view using permissions. So here's how you can do it. So first you can create the view normally. You can use revoke, insert, update, and also delete permissions from users for that particular view, ensuring that they can only read the data. So now, this was all for the read-only view. Let's move on to the fourth type of the view which we are discussing today, which is the check option. So with the check option is SQL, which is with the check option. I'll just type here with check option. Okay. This is the fourth type of view which we are talking about with check option in SQL. It ensures that any insert or update operation performed through a view complies with the conditions specified in the where clause of the view. This means that you cannot insert or update records through the view that violate the condition of the view itself. So let's go through the creation of a view with the with check option and provide an example with an explanation and expected output. So now as you can see, we have the expected output for the valid insertion using this command, which is with check option. And with view creation with check option, we created a view named sample view, as you can see here, that selects student ID and name from the student details table, but only where the name is not null. Alright. So as you can see, we have clearly mentioned here not null. And the with check option ensures that any insert or update through the view must comply with the condition where name is not null. And the first insert into sample view inserts a student where student ID 6 name, which also has a valid name. And here is the output generated here. Alright. This is the student ID, the name over here, and that's it. So now we have learned about this with check option as well. Now I'll be talking about a materialized view. So what exactly is a materialized view? Well, a materialized view is different from a regular view because it stores the actual data in a database, meaning the data is pre-computed and doesn't need to be fetched from tables every time you query it. This makes accessing data from a materialized view much faster, especially for complex queries. Alright. So as you can see, we have created the table and we create three tables, the order details table and the product details and also the customer details table over here. And then we have provided the necessary data also. The second step was the sample data is inserted into all the three tables. The materialized view fast order summary is created to summarize orders, joining data from the three tables and computing the total cost. And the next step is the materialized view is queried, and because the data is pre-computed, it returns results very quickly. With new data, when added to the order details table, the materialized view is refreshed using refreshed materialized view to include the new data. Alright, I hope you get it. Why are we using the refreshed option? And the next step is the materialized view is deleted using the drop materialized table over here. We have used this drop materialized view, fast order summary, and in this way you can, create a materialized view. So now you might be wondering that what is the difference between the materialized view and the complex view and the simple view. I'll be seeing you that later. So First, let us now discuss why are views so useful. Okay, so why are views so useful? By now you might be wondering what's the big deal with the views, and here's why it's so useful. They make our life easy. You don't have to keep writing complex queries over and over. You create a view once and it saves you tons of time. They also help you in simplifying data. Instead of pulling everything from your database, views can help you narrow down exactly what you need. They also help in improving security. Want to show only certain parts of the data to certain people? Use views to control what others can see without letting them touch the raw data. You can also rename columns for clarity. You can rename confusing columns in the view without changing the original table, making it easier for users to understand the data. So, before we move on, if you are interested in making a career in data analytics, check out Simplilearn's postgraduate program in data analytics in collaboration with Purdue University. This comprehensive course is designed to transform you into a data analytical expert. The program covers essential skills such as data visualization, statistical analysis, and machine learning using industry-leading tools and technologies like Excel, R, Python, and Tableau. With expert instructors, real-world projects, and hands-on practice, you gain the knowledge and confidence needed to excel in today's data-driven market. So join now to advance your career and become a data analytical professional today. You can find the course link mentioned in the description box and in the pinned comment. So let us now discuss the differences between the simple, complex, and the materialized view. So here's a quick summary of the differences. So simple view pulls data from a single table, no complex logic or joins involved, and it doesn't store data. It also, the performance is it executes every query every time, whereas the complex view, it combines data from multiple tables using joins, aggregates, or other complex logic, and it doesn't store data, executes query every time. And talking about the materialized view, it stores the result of a query, making it faster to retrieve data without running the query again. It also stores data and it is much faster as it uses pre-computed data. So now it's time for the quiz. Here's a quiz question for you. What is the key difference between a regular view and a materialized view in SQL? The first option is regular views store data, but materialized views don't. Second option is materialized view stores data, but regular views don't. C, both regular and materialized view stores data. And number D is neither of them store data. So if you want to answer them, you can just write them in the comment section below. And that's it. Views are an incredible tool in SQL that can simplify your queries, improve security, and make your life easier.
What is PostgreSQL? PostgreSQL is an open source object relational database management system. It stores data in rows with columns as different data attributes. According to the DB Engine's ranking, PostgreSQL is currently ranked 4th in popularity amongst hundreds of databases worldwide. It allows you to store, process, and retrieve data safely. It was developed by a worldwide team of volunteers. Now, let's look at the history of PostgreSQL. So in 1977 onwards, the Ingress project was developed at the University of California, Berkeley. In 1986, the Postgres project was led by Professor Michael Stonebraker. In 1987, the first demo version was released, and in 1994, a SQL interpreter was added to Postgres. The first PostgreSQL release was known as version 6.0 or 6.0 on January 29, 1997, and since then, PostgreSQL has continued to be developed by the PostgreSQL Global Development Group, a diverse group of companies and many thousands of individual contributors. Now, let's look at some of the important features of PostgreSQL. So PostgreSQL is the world's most advanced open source database and is free to download. It is compatible as it supports multiple operating systems such as Windows, Linux, and Mac OS. It is highly secure, robust, and reliable. PostgreSQL supports multiple programming interfaces such as C, C++, Java, and Python. PostgreSQL is compatible with various data types. It can work with primitives like integers, numeric, string, and boolean. It supports structured data types such as date and time, array, and range. It can also work with documents such as JSON and XML. And finally, PostgreSQL supports multi-version concurrency control or MVCC. Now with this theory knowledge, let's look at the PostgreSQL commands that we will be covering in the demo. So we will start with the basic commands such as select, update, and delete. we will learn how to filter data using where clause and having clause in SQL. We will also look at how to group data using the group by clause and order the result using the order by clause. You will learn how to deal with null values, get an idea about the like operator, logical operators such as AND and OR. We will also explore some of the popular inbuilt mathematical and string functions. Finally, we'll see some of the advanced concepts in PostgreSQL, that is, to write case statements, subqueries, and user-defined functions. Okay, so let's now start with our demo. So first we'll connect to PostgreSQL using PSQL cell. So here under type here to search, I'll search for PSQL. You can see this is the SQL cell. I'll click on open. Let me maximize this. Okay, so for server I'll just click enter. Database I'll click enter. Port number is already taken, which is 5432. I'll hit enter. Username is already given, and now it is going to ask for password. So here I'll give my password so that I can connect to my PostgreSQL database. So it has given us a warning, but we have successfully connected to PostgreSQL. Alright, so now to check if everything is fine, you can just run a simple command to check the version of PostgreSQL that we have loaded. So the command is select version with two brackets and a semicolon. I'll hit enter. Okay, you can see the version PostgreSQL 13.2. Okay, now let me show you the command that will help you display all the databases that are already there. So if I hit /L and hit enter, it will give me the list of databases that are already there. So we have PostgreSQL, there's something called template 0, template 1, and we have a test database as well. Okay, now for our demo, I'll create a new database. So first I'll write create space database, and I'll give my database name as SQL_demo. I'll give a semicolon and hit enter. You see we have a message here that says create database. So we have successfully created our SQL demo database. Now if you want to connect to that database, you can use \c space SQL_demo. There you go. It says you are now connected to database SQL_demo. So here we can now create tables, we can perform insert operation, select operation, update, delete, alter, and much more. Now I'll show you how to connect to PostgreSQL using pgadmin. So when you install the PostgreSQL database, you will get the SQL cell, and along with that you also have the pgadmin. So I'll just search for pg. You can see here it has prompted pgadmin. I'll click on open. This will open on a web browser. You can see it has opened on Chrome, and this is how the interface of pgadmin looks like. It is a very basic interface. So on the top you can see the files, we have object, there's tools, and we have the help section as well. And here you have dashboard, properties, SQL, statistics, dependencies, dependence, and here on the left panel you have servers. Let me just expand this so it will connect to one of the databases. Alright, so if I go back, you see when I had run \L to display the databases, it had shown me PostgreSQL and test. Now you can see here we have the PostgreSQL database and the test database. Alright, now we also created one more database, which was SQL demo. So let me show you how to work on this pgadmin and the query tool. Alright, so I'll right click on SQL demo and I'll select query tool. I'll just show you how to run a few commands on the query tool. So let's say you want to see the version of PostgreSQL that you are using, so you can use the same command that we did on PSQL cell, which is select version closed with brackets and a semicolon. I'll select this, and here you can see we have the execute button. So if I hit execute or press F5, it will run that query. You can see we have the output at the bottom, and it says PostgreSQL 13.2 compiled by Visual C++. It has a 64-bit system. Okay. Now let me tell you how to perform a few basic operations using PostgreSQL commands. So here, let's say I'll write select 5 into 3. I'll give a semicolon, select this and hit F5. So this will run the query and it returns me the result, that is the product of 5 and 3, which is 15. Similarly, let's edit this. Let's say I'll write 5 plus 3 plus, let's say, 6. I'll select this and hit F5 to run it. It gives me the sum of 5 plus 3 plus 6, which is 14. Now the same task you can do it on this cell as well. Let me show you how to do it here. So let's say I'll write select. Let's say I want to multiply 7 into, let's say, 10. You know the result, it should be 70. If I hit enter, it gives me 70. Now this question mark column question wall will deal with this later. Alright, let me go back to my PG admin again. Let me do one more operation. Let's say this time I'll write select 5 multiplied by, and within brackets I'll write 3 plus 4. I'll give a semicolon. So what SQL will do is, first it will evaluate the expression that is there inside the bracket, that is 3 plus 4, which is 7, and then it will multiply 7 with 5. Now let me select this and I'll hit execute. So you can see 7 multiplied by 5 is 35. Alright, now we'll go back to our shell, and here I'll show you how to create a table. So we are going to create a table called movies on the cell, that is PSQL cell. So here we will learn how you can create a table and then you can enter a few data into that table. Alright, let me just scroll down a bit. Okay, so my create command goes something like this. So I'll write create table followed by the table name, that is movies. Next, my movies table will have a few columns. Let's say I want the movie ID. After the column name, we need to give the data type. So movie ID, I'll keep it as integer. So integer is one of the data types that is provided by PostgreSQL. Next, my second column in the table would be the name of the movie. So I'll write movie underscore name. So all the variables or the column name should be as per SQL standards, so there shouldn't be any space between the column names. So I have used underscore to make it more readable. So my movie name will be of type varchar or variable character or varying character, and I'll give the size as 40 so that it can hold 40 characters maximum. Next, my third column will have the genre of the movie. So I'll write movie underscore genre. Again, genre is of type varchar. I'll give the size as, let's say, 30. And my final and the last column will have the IMDb ratings. So I'll write IMDb underscore ratings. Now the ratings will be of type real, since it can have floating or decimal point values. If I close the bracket, I'll give a semicolon and I'll hit enter. There you go. So we have successfully created a table called movies. Now let me go back to my PG admin. Alright, so here I have my database, that is SQL demo. I'll just right click on this and click on refresh. Now let me go to schemas. I'll just scroll down a bit. Here under schemas we have something called as tables. Let me expand this. Okay, so you can see we have a table called movies in the SQL demo database now, and here you can check the columns that we have just added. So our movies table has movie ID, movie name, genre and ratings. Alright, now there is another way to create a table. The previous time we created using the SQL cell. Now I'll tell you how to create a table using the pgadmin. So here under tables, I'll right click and I have the option to create a table. So I'll select table. Okay, so it's asking me to give the name of the table. So this time we are going to create a table called students. So I'll write my table name as students. Alright, these will be default as it is. Now I'll go to the columns tab. So here you can create the number of columns that you want. So you can see on the right I have a plus sign. I'll just select this so that I can add a new row. So my first column would be, let's say, the student roll number. I'll write student underscore roll number. Again, the column name should be as per SQL standards. The data type I'm going to select is integer. Alright, now if you want, you can give these constraints such as not null, so that student roll number column will not have any null values. And I'll also check primary key, which means all the values will be unique for roll numbers. Alright, now if you want to add another column, you can just click on that plus sign, and let's say this time I want to give the student name as my second column. So I'll write student underscore name. Student name will be of type, let's say, character varying. If you want to give the length, you can specify the length as well, let's say 40. I'll click on the plus sign again to add my final column. The final column would be gender. So gender, I'll keep this time as type character. Okay, now you can click on save, so that will successfully create your students table. There you go. So here on the left panel you can see earlier we had only one table, that was movies, and now we have two tables. So one would be added, that was students. So if I expand this under columns, you can see we have the three columns here: student roll number, student name and gender. You can also check the constraints. It will tell you if you have any constraints. So you can see it says students roll number, there's one primary key. Alright, now let me run a select statement to show the columns that we have in the movies table. So I'll write select star from movies, give a semicolon, and let me execute this. Okay, so here on at the bottom you can see we have the movie ID, the movie name, movie genre and IMDb ratings. Now the next command we are going to learn is how to delete a table. So there is one way by using the SQL command, that is drop table followed by the table name. Let's say you want to delete students. You can write drop table students and that will delete the table from the database. This is one of the methods, so you just select and run it. Now the other way is to you just right click on the table name and here you have delete / drop. If I select this, you get a prompt, are you sure you want to drop table students? I'll select yes. So you can see we have successfully deleted our students table. Alright, now let's perform a few operations and learn a few more commands in PostgreSQL. So to do that, I'm going to insert a few records to my movies table. So for that, I'll use my insert command. So I have my insert query written on a notepad. I'll just copy this and I'll paste it on my query editor. Okay, so let me just scroll down. Alright, so here you can see I have used my insert command. So I have written insert into the name of the table, that is movies, and we have the movie ID, the movie name, movie genre and IMDb ratings, and these are the records or the rows. So we have the first record as movie ID 101. The name of the movie is a very popular movie which is Vertigo. Then we have the movie genre, that is mystery. It is also a romance movie. And then we have the IMDb ratings, the current IMDb rating, that is 8.3. Similarly, we have Shawshank Redemption, we have 12 Angry Men, there's The Matrix, 7, Interstellar, and The Lion King. So there are total 8 records that we are going to insert into our movies table. So let me just select this and hit execute. Okay, you can see it has returned successfully 8 records. Now if I run select star from movies, you can see the records that are present in the table. So I'll write select star from movies, I'll select this and I'll execute it. There you go. At the bottom you can see 8 rows affected. If I scroll this down, you have the 8 records of information in the movies table. Alright, now if you want to describe the table, you can go to the SQL cell, and here if you write \d and the name of the table, that is movies, this will describe the table. So here you have the column names, this has the data type, and here you can specify if there are any null values or any constraints like default constraint or primary key or foreign key and others. Let me go back to my pgadmin. Okay, now first and foremost, let me tell you how to update records in a table. So suppose you have an existing table and by mistake you have entered some wrong values and you want to update those records later. You can use the update query for that. So I'm going to update my movies table and I'll set the genre of movie ID 103, which is 12 Angry Men, from drama to drama and crime. So in our current table we only have genre as drama for 12 Angry Men. I am going to update this column, which is the movie genre, to drama and crime. Okay, so let me show you how to do it. I'll write update followed by the name of the table, that is movies. I'll go to the next line. I'll write set, then I'll give the column name, which is movie underscore genre, equal to, I'm going to set it as drama, comma, crime. Earlier it was only drama, and I'll give my condition using the where clause. We'll learn where clause in a bit. So I'll write where movie underscore ID is equal to 103. So here our movie ID is the unique identifier. So it will first look for movie ID 103. It will locate that movie and it'll change the genre to drama and crime. So now you can see the difference. Earlier we had 12 Angry Men as drama as the movie genre. Now if I run this update statement, okay, you can see we have successfully updated one record. Now let me run the select statement again. Okay, so here you can see if I scroll down, there you go. So movie ID 103, movie name 12 Angry Men, we have successfully updated the genre as drama, comma, crime. Okay, now let me tell you how you can delete records from a table. So for that you can use the delete command. So you'll write delete from the table name, that is movies, where, let's say I want to delete the movie ID 108, which is the Lion King. So I'll write where movie underscore ID is equal to 108. This is one of the ways to delete this particular movie, or you can give, let's say, where movie name is equal to the Lion King. Let me select this and I'll hit execute. Now if I run my select query again, you see this time it has returned 7 rows and you cannot find movie with movie ID 108, that was the Lion King. So we have deleted it. Alright, next we are going to learn about where clause in PostgreSQL. So to learn where clause, I'll be using the same movie table again. Let's say we want to filter only those records for which the IMDb ratings of the movies is greater than 8.7. So this is my updated table now. I want to display only those records or those movies whose IMDb ratings is greater than 8.7. So we'll display 12 Angry Men, which is 9. Then we are going to display The Dark Knight, which is again 9. And we are also going to display the Shawshank Redemption, which has 9.3. The rest of the movies have an IMDb rating less than 8.7. So we are not going to display those. Alright, so let me show you how to write a where clause. So I'll write select star from movies where I'll give my column name, that is IMDb underscore ratings is greater than, I'll use the greater than symbol, then I'll pass my value, that is 8.7. I'll give a semicolon and let's run it. I'll hit F5. There you go. So we have returned the Shawshank Redemption, The Dark Knight and 12 Angry Men because only these movies had IMDb ratings greater than 8.7. Okay. Now let's say you want to return only those movies which have IMDb ratings between 8.5 and 9. So for that I am going to use another operator called between along with the where clause. So let me show you how to use between with where clause. I'll write select star from movies where my IMDb underscore ratings is between, I'll write 8.5, I'll give an AND operator and 9.0. So all the movies that are between 8.5 and 9.0 ratings will be displayed. So let's select this and I'll run it. There you go. So we have returned The Dark Knight, The Matrix, The 7, Interstellar, and we have the 12 Angry Men. So a few of the records that we missed out were, I think, Vertigo, which has 8.3, and there's one more. Alright. Now moving ahead, let's say you want to display the movies whose movie genre is action. You can see in our table we have a few movies whose genre is action movie. So you can do that as well. I'll write select star from movies where the movie genre, I'm writing this time in one line. You can break it into two lines as well. I'll write movie underscore genre, which is my column name, equal to, I'll give within single quotes action. Now why single quote? Because action is a string, hence we need to put it in single quotes. If I run this, there you go. So we had one movie in our table whose movie genre was action, that is The Dark Knight. Okay. Now you can also select particular columns from the table by specifying the column names. Now here in all the examples that we saw just now, we are using star. Now star represents, it will select all the columns in the table. If you want to select specific columns in the table, you can use the column names. So you can specify the column names in the select statement. Let me show you. Let's say you want to display the movie name and the movie genre from the table. So you can write select movie underscore name, comma, I'll give the next column as movie underscore genre from my table name, that is movies where, let's say, the IMDb underscore ratings is less than 9.0. So this time in our result it will only show two columns, that is movie name and movie genre. Let me run it. There you go. So these are the movie names and the movie genres. You can see that have an IMDb ratings less than 9.0. Alright, like how you saw the between operator, there is one more operator that you can use with the where clause, that is the in operator. So the in operator works like a or clause or an or operator. So let's say I want to select all the columns from my movies table where the IMDb ratings is in 8.7 or 9.0. If I run this, it will display only those records whose IMDb ratings is 8.7 or 9.0. Alright, so up to now we have looked at how you can work on basic operations in SQL like your mathematical operations. You saw how a select statement works. We created a few tables, then we inserted a few records to our tables. We saw how you can delete a table from your database, and we have performed a few operations like update, delete, and we saw how a where clause works. Now it's time to load a employee CSV file or a CSV dataset to PostgreSQL. So I'll tell you how you can do that. But first of all, before loading or inserting the records, we need to create an employee table. So let me first go ahead and create a new table called employees in our SQL_demo database. So I'll write create table. My name of the table would be employees. Next, I'm going to give my column names. So my first column would be employee ID. So the employee ID will be of type integer. It is not going to contain any null values, so I'll write not null, and I'll give my constraint as primary key. So the employee ID, as you know, is unique for all the employees in a company. So once I write primary key, it will ensure that there are no repetition in the employee IDs. Okay. Next, I'll have my employee name. So my employee name is going to be of type varchar, and I'll give my size as 40. Okay. Next, we'll have the email address of the employee. Again, email address would be of type varchar and the size is 40 again. I'll give another comma. This time we'll have the gender of the employee. Gender is again varchar of size, let's say 10. Okay. Now let's include a few more columns. We'll have the department column. So I'll write department varchar. Let's say the size is 40. Then let's say we'll have another column that is called address. So the address column will have the country names of the employees. Address is also varchar. And finally we have the salary of the employee. Salary, I'm going to keep it as type real. So real will ensure it will have decimal or floating point values. Okay, so now let me select this create table statement and execute it. Alright, so we have successfully created our table. If you want, you can check by using select star from employees. Let me select this and I'll hit execute. Alright, you can see we have our employee ID as primary key. There's employee name, email, gender, there's department, address and salary. But we don't have any records for each of these columns. Now it's time for us to insert a few records to our employees table. Now to do that, I'm going to use a CSV file. So let me show you how the CSV file looks like. Okay, so now I am on my Microsoft Excel sheet, and on the top you can see this is my employee data.csv file. Here we have the employee ID, the employee name, email, gender, there's department, address and salary. Now this data was generated using a simulator, so this is not validated, and you can see it has a few missing values. So under email column we have a few employees who don't have an email ID. Then you can see under department also there are some missing values here as well. Alright, so we'll be importing this table or the records present in this CSV file onto PostgreSQL. Alright, so here in the left panel under tables, let me right click and first refresh this. There you go. So initially we had only movies table and now we also have the employees table. Now what we need to do is I'll right click again, and here you see we have the option to import or export. Let me click on this, and I don't want to export, I need to import, so I'll switch on import. Alright, now it is asking me to give the file location. So let me show you how to get the file location. So this is my file location actually. So my Excel file, which was this, is present in my E drive under the data analytics folder. I have another folder called PostgreSQL, and within the PostgreSQL folder I have my CSV file, that is employee data.csv. So I'll just select this. You can either do it like this or you can browse and do. Okay, now my format is CSV. Next, I'm going to select my headers as yes, and then let me go to columns and check if everything is fine. Alright, so I have all my columns here. Let's click on OK. You can see I have a message here which says import _ export. Alright, so here you can see successfully completed. We can verify this by using select star from employees again. If I run this, alright, let me close this. There you go, it says 150 rows affected, which means we have inserted 150 rows of information to our employees table. You can see we have the employee ID, these are all unique. We have the employee name, the email, we have the address and the salary. Let me scroll down so that, okay, you can see we have 150 rows of information. That means we have 150 employees in our table. Okay, now we are going to use this employees table and explore some advanced SQL commands. Now there is an operator called distinct. So say if I write select address from employees, this is going to give me 150 address of all the employees. There's some problem here, I did a spelling mistake. There should be another D. If I run this again, our query will return 150 rows. You can see we have the different country names under address, that is Russia, we have France, there's United States, we have Germany, okay, and I think we have Israel as well. Yeah. Now suppose you want to display only the unique address or the country names, you can use the distinct keyword before the column name. So if I write select distinct address from employee, it will only display the unique country names present in the address column. If I run this, see, it has returned us 6 rows of information. So we have Israel, Russia, Australia, United States, France and Germany. Alright, now as I said, there are a few null values which don't have any information. So you can use the isNull operator in SQL to display all the null values that are there. Suppose I want to display all the employee names where the email ID has a null value. So I'll write select star from employees where email is null. So this is another way to use your where clause. If I select and run this, there you go. So you see here for all these employee names there was no email ID present in the table. So it has returned us 16 rows of information. So around 10% of employees do not have an email ID, and if you see, a few of them do not have an email ID and also they don't have a department. So if you want to know for those employees which do not have a department, you can just replace where department is null instead of where email is null. Now if I select this, Okay, it has returned us 9 rows of information, which means around 5% of employees do not have a department. Moving ahead, now let me show you how the order by clause works in SQL. Now the order by is used to order your result in a particular format, let's say in ascending or descending order. So the way to use is, let's say I want to select all the employees from my table, so I'll write select star from employees order by. I want to order the employees based on their salary, so I'll write order by salary. Let me select and run it. Okay, there is some problem. I made a spelling mistake. This should be employees. Let me run it again. Okay, now if you mark the output, our result has been ordered in ascending order. So all the employees which have salary greater than $45,000 appear at the top, and the employees with the highest salaries appear at the bottom. So this has been ordered in ascending order, which means your SQL or PostgreSQL orders it in ascending order by default. Now let's say you want to display the salaries in descending order so that all the top ranking employees in terms of salary appear at the top. So you can use the DESC keyword, which means descending. If I run this, you can see the difference now. So all the employees with the highest salary appear at the top, while those with the lowest salaries appear at the bottom. So this is how you can use an order by clause. Okay, so now I want to make a change in my existing table. So here if you see, under the address column we only have the country names, so it would be better if we change the name of the address column to country. So I want to rename a column. You can do this using the alter command in PostgreSQL. So let me show you how to rename this column, that is address. So I'll write alter table followed by the table name, which is employees. Then I'm going to use rename column address. I'll write to, I want to change it to country. If I give a semicolon and hit execute, it will change my column name to country. Now you can verify this. If I run the select statement again, there you go. Earlier it was address column and now we have successfully changed it to country column. Okay, let me come down. Now it's time for us to explore a few more commands. So this time I'm going to tell you how an AND and an OR operator works in SQL. So you can use the AND and OR operator along with the where clause. So let's say I want to select the employees who are from France and their salary is less than $80,000. So let me show you how to do it. I'll write select star from employees where I'm going to give two conditions. So I'll use the AND clause or the AND operator here. I'll write where country is equal to France. Now mark here I'm not using address because we just updated our table and changed the column name from address to country. So I'll write country equal to France, and my next condition would be my salary needs to be less than $80,000. I'll give a semicolon. Let me run this. Alright, so it has returned 19 rows of information. You can see all my country names are France and the salary is less than $80,000. So this is how you can use or give multiple conditions in a where clause using the AND operator. Now let's say you want to use the OR operator, and let's say you want to know the employees who are from country Germany or the department should be sales. So I'll write select star from employees where country is equal to Germany, and instead of and I'm going to use or. The department should be sales. Okay, now let's see the output. I'll hit F5 this time to run it. Alright, so we have 23 rows of information now. Let me scroll to the right. You can see either the country is Germany or the department is sales. You see one of them in the table. So here for the first record the country was Germany, the second record the department was sales, again for the fourth record the country is Germany. So this is how the OR condition works. So if one of the conditions are true, it will return the result. It need not be that both the conditions should satisfy. Now in PostgreSQL there is another feature that is called limit. So PostgreSQL limit is an optional clause on the select statement. Now this is used as a constraint which will restrict the number of rows returned by the query. Suppose you want to display the top 5 rows in a table, you can use the limit operator. Suppose you want to skip the first 5 rows of information and then you want to display the next 5, you can do that using limit and offset. So let's explore how limit and offset works. I'll write select star from employees. Let's say I'll use my order by clause. I'll write order by salary, let's say in descending, and limit it to 5. This is going to display the top 5 employees which have the highest salary. If I run this, there you go. You see it has given us 5 rows of information and these are the top 5 employees that have the highest salary. Okay, so this is one method of or one way of using the limit clause. Now in case you want to skip a number of rows before returning the result, you can use offset clause placed before the limit clause. So I'll write select star from employees, let's say order by salary, descending. This time I'm going to use limit 5 and offset 3. So what this query will do is it will skip the first 3 rows and then it will print the next 5 rows. If I run this, there you go. So this is how the result looks like. Okay. Now there is another clause which is called fetch. Let me show you how that works. I'll copy my previous SQL query. I'll paste it here. And here, after descending, I'm going to write fetch first 3 row only. So my fetch is going to give me the first 3 rows from the top. There you go. It has given us the first 3 rows and you can see the top 3 employees that have the highest salary since we ordered it in descending order of salary. Alright. You can also use the offset along with the fetch clause. I'll copy this again and let me paste it here. Now after descending I am going to write offset, let's say 3 rows, and fetch first 5 rows only. So what this SQL query is going to do is it will skip the first 3 rows of information and then it is going to display the next 5 rows. It is going to work exactly the same as we saw for this query. Let me run it. There you go. So these are the first 5 rows of information after excluding the top 3 rows. Alright. We have another operator that is called as like in PostgreSQL. So like is used to do pattern matching. So suppose you have a table that has the employee names. You forgot the full name of an employee, but you remember the few initials. So you can use the like operator to get an idea as to which employee name it is. Now let's explore some examples to learn how the like operator works in PostgreSQL. So suppose you want to know the employees whose name starts with A. So for that you can use the like operator. Let me show you how to do it. So I want to display the employee name, and let's say I want to know their email IDs from the table name that is employee, where since I want to know the employees whose name starts with A, so I'll write employee name like. Now to use the pattern is within single quotes I'll write A and then followed by percentage. Now this means the employee name should have an A in the beginning, and percentage suggests it can have any other letter following A, but in the beginning or the starting should be A. If I run this, so there is an error here. The name of the table is employees and not employee. Let's run this again. There you go. You can see there are 16 employees in our table whose name starts with A. You can see this column employee name, all of them have a letter A in the beginning. Okay, now let me just copy this command or the query. I'll paste it here. Let's say this time you want to know the employees whose name starts with S. So instead of A, I'll write S. So this means the starting letter should be S and followed by it can have any other letter. If I run this, so there are 10 employees in the table whose name starts with S. Okay, let's copy the query again, and this time I want to know the employees whose name ends with D. Now the way to do it is instead of a percentage, I'll write this time percentage D, which means at the beginning it can have any letter, but the last letter in the string or in the name should be ending with D. Now let me copy and run this. So there are 13 employees in the table whose name ends with a D. You can see it here. Alright, now let's say you want to find the employees whose name contains ISH or have ISH in their names. So the way to do is something like this. So I'll copy this. Now here instead of a percentage, I'll replace this with percentage ISH percentage. Now this means that in the beginning it can have any letter and towards the end also it can have any letter, but this ISH should appear within the name. Let me run and show it to you. Okay, so there is one employee whose name contains ISH. You can see here there is an ISH in the last name of the employee. Alright, now suppose you want to find the employee name which has U as the second letter. It can have any letter in the beginning, but the second letter of the employee name should have U. Now the way to do is I'll copy this, and instead of a%, I'll write underscore U followed by %. Now this underscore, you can think of a blank that can take any one letter. So the beginning can start with A, B, C, D or any of the 26 alphabets we have. Then it should contain U as the second letter followed by any other letter or letters. Let me run this. Okay, so there are 10 employees in the table whose name has a U as the second letter. You can see these. Okay, now moving ahead, let me show you how you can use basic SQL functions or inbuilt functions. So we'll explore a few mathematical functions now. So let's say you want to find the total sum of salary for all the employees. So for that you can use the sum function that is available in SQL. So I'll write sum and inside the sum function I'll give my column name, that is salary, from my table name, that is employees. Let's see the result. This will return one unique value. There you go. Now this is the total salary. Since the value is very large, it has given in terms of E. Now one thing to note here is, if you see the output, the column says sum real. So this output column is not really readable. So SQL has a method which can fix this, that is called an alias. So since we are doing an operation of summing the salary column, we can give an alias to this operation by using the as keyword. So if I write sum of salary as, let's say, total salary, then this becomes my output column. You can see the difference if I run this. Okay, you can see now in the output we have the total salary. Now this is much more readable than the previous one. So this is a feature in Excel where you can use or give alias names to your columns or your results. Now similarly, let's say you want to find the average of salary for all the employees. Now SQL has a function called AVG which calculates the mean or the average salary. If I write AVG, and I can edit my alias name as well. Let's see, I'll write mean salary. Let's run it. You can see the average salary for all the employees. It's around $81,000. Okay, now there are two more important functions that SQL provides us, which is max and minimum. So if I write select maximum, or max, which is the function name of salary, as, let's say, instead of total I'll write maximum. So this will return me the maximum salary of the employee. Let's run it and see what is the maximum salary that is present in the salary column. Alright, so we have $1,19,616 as highest salary of one of the employees. Similarly, you can use the min function as well. I'll just write minimum, and this will return me the minimum salary of one of the employees in the table. I'll replace the alias name as minimum. Okay, now run it. This will give me the minimum salary that is present in our table. So it is $45,685. Okay, now let's say you want to find the count of department in the employees table. You can use the count function. So if I write select count, let's say I want to know the distinct department names, I can write inside the count function distinct department as total departments from employees. Let's run this. This will return me the total number of departments that are there. So it gives me there are 12 departments. Okay, now let me show you one more thing here. If I write select department from employees, let's run this. Okay, so it has returned me 150 rows of information, but what I'm going to do is I'll place my distinct keyword here just before the column name so that I can verify how many departments are there in total. There you go. So there are 13 departments and one of them is null. So moving ahead, we'll replace this null with a department name by updating our table. Okay, so now let's update our department column. So what we are going to do is, wherever the department has a null value, we are going to assign a new department called analytics. So earlier we have also learned how to use the update command. So I'm going to show it again. So we'll write update followed by the table name, that is employees. I'm going to set my column, that is department, equal to, within single quotes, my name of the department would be analytics, where department is, I'll say, null. So wherever the department has a null value, we'll replace those information with department, that is analytics. Let's run this. You can see query returned successfully. Now let's say I'll run this command again, and this time you can see the difference. There you go. So we have 13 rows of information and there is no null department now. We have added a new department, that is analytics. Okay, now we are going to explore two more crucial commands or clauses in SQL, that is group by and having. So let's learn how group by clause works in PostgreSQL. So the group by statement groups rows that have the same values into summary rows. For example, you can find the average salary of employees in each country or city or department. So the group by clause is used in collaboration with the select statement to arrange identical data into groups. So suppose you want to find the average salary of the employees based on countries, you can use the group by clause. So let me show you how to do it. I'll write select. I want the countries and the average salary for each country. So I'll use the average function, that is avg, and inside the function I'll pass my column, that is salary. I'll give an alias name as, let's say, average underscore salary, from my table name, that is employees. Next I'm going to use my group by clause. So I'll write group by. Since I want to find the average salary for each country, so I'll write group by country name. Let's give a semicolon and let me run it. I'll use F5. There you go. So here on the left you can see the country names. We have Israel, Russia, Australia, United States, France and Germany, and on the right, the second column, you can see the average salary for each of these countries. Now you can also order the result in whichever way you want. Suppose you want to arrange the results based on the average salary, so you can use the order by clause after the group by clause. So I'll write order by. Here you can use the alias name, that is average salary. This is actually average underscore salary, and let's say I want to arrange it in descending order, so I'll write DESC. Now let's run this. You can mark the difference in the average salary column. There you go. So as per our result, in United States the average salary is the highest, and if I scroll down, the average salary is the lowest in Germany. Now let's see one more example using group by. Suppose this time you want to find the maximum salary of male and female employees. You can do that too. So let me show you how to do it. So I'll write select. This time we want to find the maximum salary based on gender. So I'll select my gender column, comma, and this time I'll use my max function. Since I want to find the maximum salary for male and female employees, I'll give an alias name as maximum underscore salary from my table, that is employees. Group by, I'll write gender. Okay, so let's run this. There you go. You can see, so one of the female employees had a highest salary of $1,19,616, while of that of a male was $1,17,654. Alright, now suppose you want to find the count of employees based on each country. You can use the count function along with the group by clause. So I'll write the select statement, select. since I want to count the employees based on each country, so I'll first select my country column and then I'm going to use the count function. I'll write count emp_id from my table name, that is employees. I'm going to group it by country. So this query will give me the total number of employees from each country. You can see here Israel there are 4 employees, in Australia there are 4 employees, in Russia we have 80 employees, in France there were 31, in United States we have 27, so on and so forth. Now let me scroll down. Okay, now it's time to explore one more clause, a very important clause that is used in PostgreSQL, that is having. So the having clause works like the where clause. The difference is that where clause cannot be used with aggregate functions. The having clause is used with the group by clause to return those rows that meet a condition. So suppose you want to find the countries in which the average salary is greater than $80,000, so you can use the group by clause and the having clause to get the result. So I'll write my select statement as select country, comma, I want the average salary, so I'll write avg of salary. I can give an alias name as average salary from employees. Now I'm going to group it by each country, so group by country column. Since I want to find the countries in which the average salary is greater than 80,000, so I'll use having clause after the group by clause. I'll write having average of salary is greater than 80,000. Now this condition cannot be specified in the where clause, so we need a having clause. You cannot use aggregate functions along with where clause. Let me just run it now. There you go. So we have Russia and United States where the average salary is greater than $80,000. Alright. Now let's say you want to find the count of employees in each country where there are less than 30 employees. So for this I am going to use the count function. First let me select the country column. Then I'm going to use the count function, and in the count function I'm going to pass my employee ID so that we can count the number of employees from my table, that is employees. Now if you want you can use an alias name for this as well, but I am just skipping it for the time being. I'll write group by country. Next I'll write having count of employee ID less than 30. So this will return me the countries in which there are less than 30 employees. Let's run it. You can see here Israel, Australia, United States and Germany are the countries in which there are less than 30 employees. Okay, now if you want you can use the order by clause as well. So suppose I'll write here order by count of employee ID. So what this will do is it will arrange my result in ascending order of employee ID count. There you can see we have successfully arranged our result in ascending order of employee IDs. Okay, next we are going to explore one more feature of PostgreSQL, that is of using a case statement. Now in PostgreSQL the case expression is same as if-else statement in any other programming language. It allows you to add if-else logic to the query to form a powerful query. Now let me just scroll down and I'll show you how to use a case statement. This is very similar to your if-else statement that you use on Excel, in C++, in Python or any other programming language. So what I'm going to do is I'm going to write a SQL query that will create a new column, and the name of the column would be let's say salary range. So I'm going to divide my salary. Suppose if the salary is greater than $45,000 and if it's less than $55,000, in the new column, that is salary range, we are going to assign a value low salary. Now if the salary is greater than $55,000 and if it is less than $80,000, we are going to assign a value that is medium salary. If the salary is greater than $80,000, we'll assign a value high salary. So all this we are going to do using our case expression in PostgreSQL. So I'll start with my select statement. But before that, let me show you how to write a comment in PostgreSQL. So you can write a comment by giving a double dash. Comments are very helpful because they make your codes or the scripts readable. I'll write case expression in PostgreSQL. Similarly, if you want, you can go to the top and let's say here you can write with double dash having clause. Okay, let's come down. So I'll write my select statement as select. I want the department, the country and the salary column. I'll give a comma and I'll start with my case statement. I'll write case when my salary is greater than 45,000 and my salary is less than 55,000, then the result would be, within single quotes, I'll write low salary. So this is exactly like an if-else condition. Next, I'll write another case when salary is greater than 55,000 and salary is less than, let's say, 80,000, then the result would be medium salary. And finally, I'll give my last condition, that is when salary is greater than 80,000, then the result will be high salary. Let me write this in a single line, then high salary. Now one thing to remember, in PostgreSQL the quotes are insensitive, so you can write your select statement in capital, in lowercase or in sentence case. Similarly, I can write case as small c or you can write as capital C. Alright, now moving ahead, after this I am going to write end. I'll give an alias name as salary range. Now this is going to be my new column in the output. Let me just come down. After this we need to give our table name from employees. I'll order it by salary descending. Okay, so what I'm going to do here is I'll first select department, country and salary column from my employees table, and then I'm creating a new column that is salary range, and I'm specifying the range. So I have three conditions here, for low salary, for medium salary and high salary. So let's run this and see the output. There you go. Here you can see we have added a new column known as salary range, and we have order our salary in descending order, so all the highest salaries appear at the top. If I just scroll down, you can see we have medium salaries here, and if I scroll down further, you can see these low salaries. So case statements are really useful when you want to create a new column based on some conditions in the existing table. Alright, now moving ahead, we are now going to see how to write subqueries in PostgreSQL. So subqueries, we write a query inside another query, which is also known as nested query. So suppose we want to find the employee name, department, country and salary of those employees whose salary is greater than the average salary. So in such cases you can use subqueries. Now let me show you how to write a query inside another query. First I'll write the select statement. I am going to select the employee name, comma, I want the department, comma, I also want to display the country name and the salary from the employees table, where my salary should be greater than the average salary. So after this where salary greater than, I am going to use brackets and write my subquery, that is select average salary from employees. Now let me break it down for you. So first we are going to select the average salary from the employees. So this particular SQL statement will find the average salary from the table. We will compare this average salary with salaries of all the employees. So whichever employee has the salary greater than the average salary will display their names, the department, country and their original salary. So if you want, you can run this statement as well. Let me select this statement and run it for you. You can see we have written the average salary of all the employees, which is nearly $81,466. So we want the salaries of the employees to be greater than this average value. So let me run this and see how many employees have a salary greater than the average salary. There you go. So we have around 75 employees whose average salary or whose salary is greater than the average salary. Alright. Now moving ahead, this time I'm going to tell you how to use some inbuilt functions. We'll learn some inbuilt mathematical functions and string functions that are available in PostgreSQL. So I'll just give a comment. There's another way to write a comment. Instead of a double dash, you can use the forward slash, an asterisk, and inside the asterisk you can write, let's say, SQL functions, and you need to close this. So I'll give another asterisk and a forward slash. So this is also a comment in PostgreSQL. Alright. So first of all, we'll explore a few math functions. So there is a function called ABS which is used to find the absolute of a value. So if I write select ABS of, let's say, -100, it is going to return me positive 100 or just 100, because as you know, the absolute of any value will remove the negative sign involved in that value. There you go. So our original input was -100, the absolute of -100 is +100. Next, let's see another function that is called greatest. So the greatest function in PostgreSQL will return the greatest number in a range of numbers. So suppose I write select greatest. Inside the greatest function, I'll pass in a few numbers, let's say 2. I'm just randomly passing a few numbers, let's say 490, let's say 56.5, and let's say 70. I'll give a semicolon. Let me run this. You will see the greatest function will return the greatest integer value or greatest number that is present in the range of numbers that we have provided. So in this case, 90 was the largest number or the greatest number, so we got the result as 90. Again, you can use an alias for each of these statements. Now, like greatest, we also have a function called least, which is going to return the least number present in a range of numbers. If I run this, so the result is 2, because 2 is the least number that is present in this selection. Alright. Now there's a function called mod which is going to return the remainder of a division. So suppose I write select mod, and this takes two parameters, let's say 54 divided by 10. As you can guess, the remainder is 4, and so is our result. You can see it has returned the remainder. 54 divided by 10, the remainder is 4. Alright, if I scroll down, now let's see how to use the power function. So I'll write select power. Let's say I want to know power 2, 3, which is 2 cube, that is 8. Let me just run this. There you go. So the result is 8. You can also check, let's say, power of 5, 3. It should be 125. Alright. Next, you can use the sqrt function that is available in PostgreSQL to find the square root of a number. I'll write sqrt, and let's say I want to find the square root of 100. You can guess the result. The output should be 10. If I run this, you can see the output here 10. Let's say I want to find the square root of, let's say, 144. You can again guess the result. It should be 12. Let's verify it. Okay, there is some error. Let me verify it again. There you go. It is 12. Now, there are a few trigonometric functions as well. You can use the sine function, the cos function, and the tan function. Let's say I want to know the sine of 0. If you have studied high school mathematics, you would know the sine of 0 is 0. You can see the result, it is 0. Let's say you want to know sine 90. If I run it, you can see the output here, 0.89. Alright. Now, there are other functions like ceiling and floor that you can use. So let me show you what the ceiling and floor function does. I'll write ceiling. Let's say I'll pass my floating value as 6.45 and let me run it. You can see the ceiling function returns the next highest integer, that is 7 in this case, since the next highest integer after 6.45 is 7. Let's see what the floor function does, and let me run it. As you can see, the floor function returns the next lowest integer, that is 6 in this case, or the nearest lowest integer to any provided decimal value. Okay. Now that we saw how to use mathematical functions, there are a few string functions available in PostgreSQL. So let's explore them as well. I'll write string functions. Okay. We'll scroll down. Cool. There's a function called character length that gives you the length of a text string. Suppose I write select, give the function as character length, and inside this function I am going to pass in a text. Let's say India is a democracy. This is my text. Let me run this. Okay, you can see the result here, which is 20, since there are 20 characters in my string that I have provided. Alright. Now there's another function called concat in PostgreSQL. So concat is basically used to merge or combine multiple strings. So I'll write select concat, within brackets I'll give the text string now. Let's say I want to combine PostgreSQL I'll give a space, comma, I want to merge PostgreSQL is, I'll give another comma and write my final word, that is interesting. Now what we have done is, inside the concat function we have passed in separate strings, and now using the concat function we want to merge the three strings. Let's see what the result is. I'll run it. Alright, let me just expand this. You can see here we have concatenated the three strings successfully, so the output is PostgreSQL is interesting. Okay. Now there are functions like left, right and mid in PostgreSQL. So what the left function does is it will extract the number of characters that you specify from the left of a string. Let's say I'll write select left and I'll pass in my text string as India is a democracy. I'll copy this and I'll paste it here. Let's say I want to extract the first 5 characters from my string, so I'll give 5. So what it will do is it will count 5 characters from left, so 1 2 3 4 and 5. If I run this, it should ideally print India for me. There you go, it has printed India for us. Alright, similarly you can use the right function to extract few characters from the right of a string. Let's say you want to extract, let's say I'll give 12 characters from right, so from here onwards it will count 12 characters. I'll change left to right now. Let me select this and run it. So you can see here, this is the output. From the right it has counted 12 characters and returned a democracy. Okay, now there is a function called repeat. So the repeat function is going to repeat a particular string the number of times you specify. Let's say I want to select and use my repeat function, and inside the repeat function I'm going to pass in, let's say, India, and I want India to be displayed 5 times. I'll give a semicolon and run it. In the output you can see India has been printed 5 times. Okay, let's scroll down. There is another function, a string function in PostgreSQL called as reverse. So what reverse function is going to do is it is going to print any string passed as an input in reverse order. So if I write select reverse, and inside the reverse function I'll pass in my string, that is India is a democracy. I'm going to use the same string. I'll copy this and I'll paste it here. I'll close the quotes and the brackets. Let's print this. You can see it here. India is a democracy has been printed in reverse order. There you go. Alright, now this time we explored a few inbuilt functions that are already present in PostgreSQL. Now PostgreSQL also has the feature where you can write your own user-defined functions. So now we will learn how to write a function of our own in PostgreSQL. So let's create a function to count the total number of email IDs that are present in our employees table. So for this we'll write a function, a user-defined function. So let me give my comment as user-defined function. Okay, so let me start by first writing create. So this is the syntax to write a function in PostgreSQL. So I'll write create or replace function, then I'll give my function name as count emails, and as you know functions have brackets. Then I'll write returns, the return type, as integer, then an alias with dollar symbol. I'll write total emails, since I'm going to display the total number of email IDs that are present in my table. I'll close the dollar symbol. Then I'm going to declare a variable. The variable name is going to be total underscore emails. This is of type integer. I'll write begin, and inside begin I'll write my select statement. So I'll write select I want to count the email IDs that are present, so I'll pass my column name, that is email, into total emails from my table name, that is employees. I'll give a semicolon and then we'll write return total emails. As you know, user defined functions often return a value, so hence we have mentioned the return statement as well. And now I'm going to end my function. Then the next syntax would be, let me just scroll down. Okay, so here I'll give my dollar symbol again, followed by total underscore emails. Next I'll write my language as PostgreSQL. So the way to mention is PL PG SQL. Let's give a semicolon and end it. So this is my user defined function that I have written. So I created a function with the function name count underscore emails, and this would return integer as an alias, which is total underscore emails. We declared that variable as an integer. Then we started with a begin statement that has my select statement, where I am selecting the count of email IDs that are present in the employees table, and I am putting the value into total underscore email. So I have used the into keyword, and this returns the result as total underscore emails, and I have ended. Let's run this. Okay, there is some problem. There is an typo, so this should be integer. Okay, let me run it once again. There you go. So you've successfully created a user defined function. Now the final step is to call that function. Now to call this function, I'm going to use my select statement and the function name, that is count underscore emails. I'll give a semicolon. Let's execute this. There you go. So here you can see there are 134 email IDs present in our employees table. Now one thing to mark is there are total 150 employees in the table, but out of them 134 employees have email IDs, the rest of them don't have, so they would ideally have null values. Alright, so that brings us to the end of this demo session on PostgreSQL tutorial. Let me go to the top. We have explored a lot. So we started with checking the version of PostgreSQL. Then we saw how to perform basic mathematical operation, that is to add, subtract, multiply. Then we saw how to create a table that was movies. We inserted a few records to our movies table. Then we used our select clause. We updated a few values. Then we deleted one row of information. Then we learned how to use the where clause. We learned how to use the between operator. We also learned how to use the in operator. Let me scroll down. We created a table called employees, and then we learned how the distinct keyword works. We also learned how to use isNull with where clause. We learned about the order by clause. We saw how to alter or rename a column. Then we explored a few more examples on where clause, where we learned about and OR operator. Then we learned how to use limit and offset, as well as the fetch operator or the fetch keyword in PostgreSQL. Moving further, we learned about the like operator in SQL, which was used to perform pattern recognition or pattern matching, you can say. Here we saw how to use basic inbuilt PostgreSQL functions like sum, average, minimum, count, maximum. Next, we saw how to update a value in a column using PostgreSQL update command. We learned how to use group by. Then we learned how to use having clause. Then we learned how to use case expressions in PostgreSQL. So we saw how case expression is similar to our if-else in any other programming language. We explored a few mathematical and string functions, and finally we wrote our own user-defined function. So that brings us to the end of this tutorial on PostgreSQL. Now if you want to get this SQL file that we have used in the demo, you can give your email IDs in the comment section and our team will share this SQL file with you over email.
So, what exactly is a CT, you ask? Now, if you are a beginner in SQL, let's say you wanted to club two different tables or more different tables, maybe 3 or 4, right? So you will be using one keyword, which is join, right? And let's say you may have to create a query in such a way that you have to club different tables and you have to extract the results from one table into another and finally create a output table, right? So this might be sounding a little too complex. So basically what CTE does is it acts as a temporary table, right? Now you can write a query and save it as a CTE, right? And that particular resultant table from CTE will not be created, but will be in the memory as a temporary data or an intermediate resultant data, right? Now, whenever you want to use a join or whenever you want to use the same query inside a bracket or inside something in your query, you can just simply use the name of the CTE and then the data you require, the columns you require, and done. You will get the data. Now, this might be a little too complicated to understand in just mere words. Now, let's just go through the formal definition of what exactly is a CTE and what it does, and then let's quickly. So, it's a little too complicated to understand it just with mere words. So, let's get started with the practical examples. But before that, let's understand a formal definition of what exactly is a CTE in SQL. So, CTE, also known as or also called as the common table expression, or some people also are used to call it as a with expression. So the keyword is with. So a common table expression in SQL is a temporary result set that you can define within a query. As I said, it helps to break down the complex queries, make the code more readable, and allows you to reuse the result set multiple times within the same query. Just you need to use the name of the CTE in the places where you want in your query, and it reduces the code length as well as the execution time. Now, CTEs are defined using the with keyword as we discussed before, followed by the CTE name, right? So for every column name or anything in your dataset, you give a name, right? Similarly, when you are using CTEs in SQL, you also need to give a name to the CTE, and that particular name will be used in your subquery positions that will reduce the query length and execution time. So you should be giving a name and the query that generates the result set. The CTE is available only during the execution of that particular query or specific query, right? So as I said, the CTE table, the resultant table which is created while you are using the CTE, will not be created as a permanent table in the database, right? It will be a temporary or intermediate result which will be active as long as your current query, which is using the CTE, is active. Now, let's go to the demonstration mode where we will try to create some simple queries, right? And we will understand how exactly a CTE can be beneficial in those situations. Now, let's go to the MySQL workbench. This is my MySQL workbench. So I have a lot of tables here. We have the credit card dataset. We have the Sakila dataset, SLP dataset, SIS, Superstore, World, etc. Right? So we will be using the Superstore dataset. The database. So firstly, we need to write in the query, which means that I am going to use the Superstore database, right? Sorry, Superstore. So I prefer using smaller case or lowercase for database names and column names, and uppercase for the keywords. For example, here use is uppercase and Superstar is the name of the keyword, right? So that is for identifying or easy readability, which is a keyword and which is a name, right? So let's execute this query and have access to the Superstore dataset. And in Superstore dataset, I have one table called as Excel data. Now let's quickly check what we have in Excel data. Select star from Excel data. Here we have row ID, order date, ship mode, customer care, everything, right? So we have region, we have sales, quantity, discount, profit rate. So we have a number of possibilities, a number of reports that we can generate. But let's try to keep it simple. Let's try to find out unique regions, right? Select unique of regions, right? Or just regions, Excel data. Group by regions. So let's quickly execute this statement and see the output, or maybe we can make some modifications to it, right? Instead of that, you might want to use distinct function so that you don't get all 10,000 plus rows. So basically this particular dataset has about 10,000 or more rows in it, and it's not real, it's completely made up report using artificial intelligence. So we use ChatGPT to create 10,000 rows of data for 30 years, maybe from 2000 or 2001 to up to 2030 or 31, right? So we don't want all those 10,000 plus columns, rows. So let's use a distinct here and try to execute this statement so that we get 5 of the regions what we have. So there you go, we have 5 regions as expected: Northeast, Southwest, and Central. Now you can also select a kind of maybe average of sales, maximum of sales, and total sales. So this is bringing us somewhere we can try to find out region-wise sales, right? So region-wise sales grouped by years, like 30 years. What was the sale happened in the year 2001, right? We begin from 2000 or 2001 to all the way up to 2030 or 2031, right? So we can see if there is an increase in the year-on-year sales or decrease in the year-on-year sales. We can identify the best performing year, the worst performing year, right? So this sounds like a good use case. Now let's go to the code where I've written it as a CTE and understand the workflow. So here I have named my CTE as sales CTE. So I'm starting it with the keyword with, right? So with sales CTE as. Now this is our query, right? What am I doing? I'm extracting. So according to the dataset, we have the date, right? So the date is year, month, and date of that particular day, right? But we want just the year. So we're using the year function to extract the year from the date as sales year, region, sum of sales, right? We wanted to find out the total sales happened in that particular year as total sales from the dataset Excel data, and group by year, right? We wanted it in increasing order. So 2000 to all the way up to 230 or 2031, correct? So that's how it is. And I'm saving all this as a CTE named as sales CTE. Now I want to select some parts of that particular CTE. So I want to select sales year, region, total sales from sales CTE, which is right over here, and order it in form of sales and region, right? Now let's try to copy this code and run this in our workbench. Right, now let me close this quickly so that we have a complete view of the code, right? So let's now select all the code So now we have selected this particular code. Let's try to run this and see the output. There you go. We have the output, but there is something wrong. We did not get the years, right? So all the 30 years of data, here it is grouped by region, which is fine. Okay, we don't want region, we want to group it by year. That's okay. And the thing is, we need to fix this particular year. So maybe there is something wrong with the order date, right? So I think the database has saved this particular. Oh, okay. Since this is generated by ChatGPT, maybe the data type of the date is other than data, right? Other than data type. It may be string. Now, we might have to do some typecasting to change the data type of the order date, and let's quickly do that. So now we have updated the year. So what we have done is just cast here, right? So we have changed the string type of date to the normal date, which follows by year, month, and date. So this is a simple typecasting that you can do, and rest everything. And we've also added a where condition. So where date is not added or date is equals to null, then you can just ignore that. And now let's try to execute this query, and we have also removed that region thing, right? Group by region or order by region. So we want that to be ordered according to the year, which should start with 2001 or the first ever year to the last ever year according to the dataset. Now let's select the entire CTE query and run that and check our outputs. So there you go. So you have the year-on-year sales from 2001 to all the way up to the year 2030 and 2031, right? So that's how the CTE or common table expressions in SQL or the with query in SQL can be used.
So welcome to the demo part of the SQL project. So in this we will do digital music store analysis. Okay, so this SQL project is for the beginners. So what you will learn from this project, main thing is like, so what's the objective of this project, this particular project? So this project is for beginners and will teach you how to analyze the music playlist database, and you can examine the dataset with SQL and help the store understand its business growth by answering simple questions. So as you can see, I will show you. So I have three set of questions. First one is easy, okay, and the second one is moderate, and the third one is advanced level. So we have three set of questions: easy, set, moderate, and the advanced. Okay, so every set is of three questions, I guess. Yes, in every set there is three questions. So okay, in easy one there are 5. So we have 5 plus 3 8, 8 plus 3 11. We have 11 questions to solve. Okay, from this you will understand how you can analyze data with SQL, how you can extract something from database, how you can store something like this. Okay, so, and one more thing, I will show you the schema of the particular data set which we will soon we will restore. So we have the tables in this: artist, album, track, media type, genre, invoice line, invoice, customer, employee ID, playlist track, and all. Okay, so this is the music playlist database schema. So without any further ado, let me create one database. So here, just right click, create database. Okay, here I will write music. Okay, and save. So now our database is created. Okay, so if you will go to schema and if you go to tables, there is no tables in it. Means there is database, but nothing is there. The database is empty. So now what I will do, just go to your database, just right click. Here you can see the restore option. Okay, restore. So format as it is. Then here file name, go to this music store database. I will put this database link in the description box below. Don't worry. Open. Then restore. Process started, process complete. Some people will face this that the process is failed or something. Okay, so for that what you have to do, just go to file, then preferences. Here you have to set the path, just binary path. Okay, see, I am using the 15th version. Okay, so I have set the path here also and this also, but you have to set this path is important. Okay, if you will not set this edv advanced server path, it's fine, but this path is most important. Okay, but for the future reference I have added on the both. So what you have to do, you have to just see where you will find this path. Just go to this PC, then OS, then program files. Here you will find this PostgreSQL. Then I'm using C15, 15, then bin. So you have to copy this path, right? You have to just copy it and paste it here, and then select this one. After that, just save. You won't find any failed thing. Okay, the process will complete. Right, so now let's move forward and see the tables. Okay, it's still empty. Why? Just refresh it. See, now you can see all the columns in my tables. Okay, so what I will do for the checking, I will run one query here. Okay, let me close it. Okay, I will write here select star from album. Okay, let me run it. So now, as you can see here, my table is working fine, everything seems good. Okay, so now what we will do, we will solve question one by one. Okay, so the first question, let's see the first question, easy one. Who is the senior most employee based on job title? Okay, who is the senior most? Okay, so I will write here like the first question is, who is the senior most employee based on job title? Okay, so this is our question. So we know we have the table name called employee, so we will select that table first. So I will write here select star from employee. So you should know which table should to select. Okay, so here as you can see in this question, there is word employee. Who is the senior most employee based on the job title? Most employee means employee is an employee table, right? So I will run it. Okay, so what I will do, I will just select this and run it. Okay, so now you can see there in employee, there is employee ID, last name, first name, title, report levels, birth date, hire date, and all the details of the particular. Okay, so we will do, so there is one more thing, you can see the levels. Okay, level 1, level 2. So we have to write who is the senior most employee based on the job title. So what I will do, I will write here order by levels in decreasing order. Okay, so first I will do, so now you can see the levels are in the descending order from senior to this. Okay, L7 to L1. So what we want only one employee name. So what I will write here, limit is 1. Okay, I will copy this and I will done it. Okay, so now you can see the last name is Mohan Madan. This is last name, this is first name. So Mohan Madan is the senior most employee based on the job title. So question first is done. So the second question is, which countries have the most invoices? Okay, first I will write down the question, which country has the most invoices. Okay, so for this what we have to do, see, just first we have to check from which table we will get the solution. So here you can see the word invoices. Okay, so we have one table, invoice and invoice line. We have to select it from this. Okay, so I will write here, select star from invoice. Okay, so we have customer ID, invoice date, billing address, billing city, billing state, and everything. So here you can see we have the billing country as well. Okay, because we need the country name, so we will take this column, right? So I will write here, so I will write select, change it, select count star from name, select star billing country from invoice, group by billing country. So why I am doing this group by? Because as you can see, we have USA multiple times, USA, then Canada also, then the other countries as well. So from this I will get only the one. Okay, I will group them and I will get the one. Fine. So from this we will get the count. So after this I will write order by. So here I will write C descending. Okay, let me run it. So now you can see the billing, this is the billing order. Okay, so or you can say the invoices, USA got the 131 and Canada 76, Brazil 61. If I will write here again that limit 1, what I will get, see, USA, we got the USA. So USA is the country which have the most invoices. Okay, if you will remove this limit, so you will get the other country as well. Second in Canada, third is Brazil, and like this. Okay, and the third question is, what are the top 3 values of total invoices? Okay, again we need the same table. Okay, first I will write the question. Third question is, what are the top 3 values of total invoices. Top 3 value of total invoices. Okay, I know I can just solve this question by the second one, but I want to do it from the starting. Okay, so first I will select stuff from invoice. Let me run it. So first we will sort the data. Here I will write order by total, because the last, this is the table name. Okay, total in the descending order. So first I will select. So we need just the top 3. So first I will do, everyone know, limit 3. Okay. Okay. So here I have wrote this star. That is why it's giving me all the values. If I want this, only this value, so I can write select total from invoice order by this. Okay, I will write and run it. So I have this total like 23.75999 and 19.8 and 19.8. So these are the top 3 values of total invoices. Okay. So here the fourth question is, which city has the best customer? We would like to throw a promotion music festival in the city. We made the most money. Write a query that returns one city that has the highest sum of invoice total. Return both the city name and sum of the all invoice total. So let me write the question first. Okay, I am writing question for your better understanding. Okay, question fourth. Which city has the best customers? We would like to throw a party or promotional music festival in this city. We made the most money. We made the most money. Write a query that returns one city that has the highest sum of invoices total. Return both the city name and sum of all invoices. Okay. So we have this question. Okay. So which city has the best customer? We would like to throw a promotional music festival in the city. We made the most money. Write a query that returns one city that has the highest sum of invoice total. Return both the city name and the sum of all the invoices. Okay. So first, what we will do, we will select stuff from invoice. Okay, sorry. We'll select this. Okay, so first we will select the billing city. We have to focus on this and the total. In this two table, we have to just focus on. Okay, so here I will write sum of total as invoice total, comma billing from invoice. So this time we will do group by billing city because we need the city names. Then I will add order by invoice total in the descending order. Seems good. Select some total as invoice total billing city from invoice billings. Okay, so let me select this. So as you can see, the highest billing city is Prague, and the best customer is from the Prague city. Okay, so which city has the best customer? Obviously Prague, or sorry for the mispronunciation. Okay, so this is how we have solved our fourth question as well. Okay, because written both the city name and the sum of all the invoices. This is the city names and the invoice total. Okay, moving forward to our fifth question, which is again the long one. Who is the best customer? The customer who has spent the most money will be declared the best customer. Write a query that returns the person who has spent the most money. Okay, so I will write here who is the best customer. The customer who has spent the most money will be declared the best customer. So write a query that returns the person who has spent the most money. Okay, yeah, so who is the best customer? The customer who has spent the most money will be declared as the best customer. Write a query that returns the person who has spent the most money. Okay, so for this we have to take this customer table data. Okay, so I will write as select stuff from customer. Okay, I will select this and I will run it. Okay, so this is our table data of customer. Okay, so we have the country, fax, emails, state, city, address, last name, first name. Okay, so as you can see, there is nothing like no detail of invoice or the money, okay, which have spent by the customer. So what we will do, we will look at our schema. So now what we can do, if we can't solve a particular question from with one table, we have to join the table to the other table. So here we have to join customer table to invoice table. So in this you can see there is customer ID and here also customer ID. So on the basis of customer ID, we can join both the table, and with the help of this total we will sort out the that guy, okay, that customer, right? So for this I will write here select customer ID comma customer dot first name comma customer dot last name, because we need the full name of that guy, comma sum invoice dot total as total. Okay, let me can be paused. Okay, I don't need the search pad, right? Then I will write from customer. Okay, my bad. Then join invoice on customer dot customer ID equals to invoice dot customer ID. Then I need group by. Okay, group by customer dot customer ID. After this, let me order it by the descending order, so the most spend customer will come up. So I will write here order by total, the descending order, then limit equals to 1. Fine, let me run it. Let's see what output should become. Okay, some error is coming. Limit. Okay, sorry. Okay, so as you can see, the customer ID is 5. The first name is R, the last name is Madhav. R Madhav is spent the highest value 144.54, 0000 and 2. So who is the best customer? Madhav, R Madhav, sorry, my bad. R Madhav, right? R Madhav has spent the most money. Okay, so this is how we are done with our easy set of questions. Now let's jump into the moderate one. Okay, so let me write the question first for the moderate. So I will write here moderate questions. So these analytics skill help you in the data analytics to become a data analyst or to become a data scientist. Okay, so the question first is write query to return. Okay, write query to return the email. Query to return the email, comma first name, comma last name, and genre of all rock music listener. Okay, then return your list ordered alphabetically by email starting with A. Okay, let me get to yeah. So for this, okay, let me open this first. Yeah. Okay, fine. So first, what I will do. So now in this question, as you can see, we have to return the email, first name and the last name and the genre of all rock music listener. So if you will see, select stuff from customer. Okay, let me run this. And if I will see, there is no column name genre. Okay, if I will show you the schema of this, see the genre is here and the customers is here. Okay, we need the first name, last name, and the email ID and the genre. Okay, and the genre should be rock. Okay, so what I can do, I can connect this genre with track. Then because here is also track ID and here is also track IDs. Then track ID to invoice line, then invoice line to invoice, then invoice to customer with the customer ID. Okay, this pattern I have to follow. Right. So for this, I will write select, just copy this. Okay, just follow these steps. Select distinct email, comma first name, comma last name from customer, join invoice on customer dot customer ID equals to invoice dot customer underscore ID, then join invoice underscore line on invoice dot invoice ID. Okay, then invoice underscore ID, then where track ID should be in. Here I will do select track ID, okay, from track, then join genre, yeah, on track dot genre dot ID equals to genre dot genre ID, where this is important, genre name like rock, because we need, as you can see, write a query to return this is this and genre of all rock music listeners. Okay, rock, right? Then order by email. Okay, before that, let me show you this track. Okay, select star from track. Okay, let me show you this table. You can see the name, the track ID, album ID, media type, genre ID. Okay, then the composer, this, bytes, and the unit price. Right? Okay, so you know this, we have then this customer. Okay, invoice ID we took. Right, fine. So now what I will do, I will just select this and okay, invoice ID. Okay, invoice ID is ambiguous. Here I have to write invoice line dot invoice ID. Okay, let me now run. Let me run it. Okay, one more. Join genre on track dot genre ID. There is entry for table genre, but it cannot be referenced from this part of the query. Okay. Okay. As you can see here, the table name is genre underscore ID. That was the mistake. Okay, one more, genre dot name. Spelling mistake. Sorry, my bad guys. No issues, it happens. Okay, now you can see we have all the people who love rock music, and we have the email, then first name, then the last name. See, Aaron Mitchell, Alexandra Roca, Astrid Gruber, like this, Camille, Dan, Edward, like this. Okay, so there are total 59 people who loves rock music from this particular database. Okay, now question 2. Question 2 is, first let me show you. Let's invite the artists who have written the most rock music in our dataset. Write a query that returns the artist name and the total track count on the top 10 rock bands. Okay, so let's invite the artist who have written the most rock music in our dataset. So write a query that returns the artist name and the total track count of top 10 rock bands. So now what we need here, okay, let me do this. So what we need here, so let's invite the artists who have written the most rock music. First we need the artist, okay, and the second is rock music, then we need track, okay, and the total track count means we will get from the track. So here we have track column, track table, and we have the artist. So now let's see the schema part. So we need genre, okay, for the rock music. Then we have to combine this with the track ID because genre ID is there. From track ID to album because we need the artist name. See, artist ID and artist ID. So this is how we have to connect the table. Now, so for this, I will write here. Just follow the steps. Select artist dot artist ID, comma artist dot name, comma count artist dot artist ID as number of songs because we need the total number, okay, who have written the most rock music, number of songs, find from track. Now we have to join album on album dot album ID equals to track dot album ID. Okay, then we have to join the artist with artist ID. So join artist column on the basis of artist ID equals to then album to album dot artist ID. Okay, so here I have joined the artist to the album column table. Okay, then I have to join genre to the track table with the track table. Okay, so here I will write join genre on genre dot genre ID equals to genre ID. Okay, sorry, track ID. Track dot genre ID. Okay, so here I will write where genre dot name like rock. Okay, rock. Fine. Then I will group by group by artist dot artist ID. I need the ID as well. Then order by number of songs in the descending. Then limit, I need only 10 rock bands. Limit will be 10. Let me run it. Okay, let me run it. Okay, album. Okay, now let me run it. Okay, now you can see this guy Led Zeppelin, artist ID is 22 and wrote the most songs 144. Then U2 122, Deep Purple 92, then this, then this. Okay, so this is how we solved our second question, right? So now the third question. Okay, return all the track names that have a song length longer than the average song length. Return the name and the millisecond of the each track ordered by the song length. Okay, so first I will write this question. Q3. So return all the track names that have a song length longer than the average song length. Okay, first we return all the track names that have the song length longer than the average song length. Okay, then return the name and milliseconds for each track. Fine. After that, order by the songs with the longest song listed first. Okay, fine. So we have to return all the track names that have a song length and the okay. First we will find the total length of this songs, then we will do the where then we will put the where clause to find out the particular longest song. Okay, so this will do in the two step. First we will find the average stack length. Okay, so I will write here select name comma milliseconds. Okay, from track where milliseconds here I will write select average from the millisecond. Okay, then I will write here as average track length okay, then here I will write from track. After this I will write here order by milliseconds. I need in the descending order. Okay, so let me run it. So now you can see first I will read it again. So return all the track names that have a song length longer than the average song length. Return the name and the millisecond for each track. Order by the song with the longest song listed first. Okay, so this is the longest song. Okay, so we have all the songs which are the longer than the average song length, right? So now moving forward, we have jump into the advanced set of questions. Okay, so now we will do the advanced questions. Okay, so let's see first. Find how much amount spent by each customer on artist. Write a query to return customer name, artist name, and total spends. Okay, so first we will write down the questions. Okay, then question one. Okay, find how much amount spent by each customer on artist. Write a query to return customer name, comma artist name, comma total spend and total spent. Okay, so how to solve this? So first find which artist has earned the most according to the invoice lines. Okay, first let me show you the schema. Okay, we need the artist name, we need the customer name, and we need the total spent. Okay, with the invoice line, because the quantity should be there. Okay, so first we'll see how to join these three tables: artist table, customer, invoice, and invoice line, like this. Okay, this is how we will join the table. Fine. So now I will tell you the steps. So first find which artist has earned the most according to the invoice line. Okay, the second, now use the artist to find which customer has spent the most on the artist. So for this query you will we need to use the invoice line, track, customer, album, and the artist table. So just remember, this one is tricky because the total spent in the invoice table, right? Let me show you. So total spent on the invoice table might not be a single product. So that is why I was saying we need the quantity. So we need the invoice line table to find out how many each product was purchased. Then we have to multiply this by the price of each artist. Okay, fine. So now, so this is a lengthy one. I will just write it for you and get back to you. Yeah, so this is how you can see. Okay, group by 5. I have wrote this. You can just write it like this. Okay, we took artist name, then sum of invoice line, unit price into invoice line, the quantity that I showed you. Okay, we have multiplied this total with the quantity. Okay, then we joined the table track with invoice, album with track, artist with album. Okay, so now let's run it. Yeah, so now you can see this Hugh O'Reilly Queen, amount spent 27, the customer ID is this. Okay, then Nicholas Schroeder, then 18. Okay, we have the everything. Okay, customer name, artist name, and the total spent. This is the customer name, the artist name, and the total amount they spent. Fine. So now let's move forward to the next one, which is okay. Yeah. So the second one is this. We want to find out the most popular music genre for each country. We determine the most popular genre as the genre with the highest amount of purchase. So write a query that returns each country along with the top genre. For countries with the maximum number of purchases, shared return all the genres. Okay. So what I will do first, I will write the question. Okay. So question 2. So find how the most popular music genre for each country. Okay, determine the most popular genre as the genre with the highest amount of purchase. Okay, then write a query that returns each country along with the top genre for countries where the maximum number of purchase. Okay, so so there are two parts in this question. First, the most popular music genre, and the second is the need of data at the country level. Okay, so we can do it from the two methods. Okay, using CT and using the recursive method. So I will use the using CT. I will do this CT. So for that you have to write with popular genre as select count invoice line dot quantity. Okay, as purchases comma customer dot country comma genre dot name comma genre dot genre ID. Okay, then here I will write row underscore number then I will write over partition by customer.country, order by count, invoice line dot quantity, okay, into descending order, as row number. Okay, so from invoice line, okay, yeah. So here I will join the tables, join invoice on invoice dot invoice ID equals to invoice line dot invoice ID. Okay, then again join customer on customer dot customer ID dot ID underscore ID equals to invoice dot customer ID. Fine. Then again we have to join track on track dot track ID equals to invoice underscore line dot track underscore ID. Then join genre on genre dot genre ID. Okay, then track dot genre ID. Okay, then I will do group by 2, 3, 4. Then I will do order by 2, then ascending order, and then 1 to descending order. Okay. Then now I will write select star from popular genre where row number is less than greater than 1. Okay, now let me run it. So now you can see we have, okay, let me read it. So we have to find the most popular music genre for each country. Okay, so now we have the country name Argentina, the most popular is alternative and punk, genre is this, row number is this. Okay, purchase is this. Then the Australia, this rock. Okay, certain rock, USA rock, and everything is there. Right? So this is how you can find the most popular music genre for each country. Okay, the last question is there here. Now the last question is, write a query that determines the customer that has spent the most on the music for each country. Write a query that returns the country along with the top customer and how much they spent. Okay, for the countries where the top amount of spent is shared, right? And they provide all the customer who spent this amount. Okay, so for this, this is like a similar to this question. Okay, so there are two parts in this question. Find the most spent on music for each country, and the second is to filter the data for the respective customer. It's very easy. Okay, so okay, I will write the solution. Okay, you can check the question from there. Okay, I will write customer with country as I will here select customer dot customer ID comma first name comma last name comma billing country comma sum should be total as total spending, right? Then I will write row number same over, we have also written here, no? Right, the same we have to write here over, then partition by billing country, order by sum, total, descending order as row number. Okay, so after this I will write here from invoice you have to fetch, then again the same thing, you have to join the table, join customer on customer dot customer ID equals to invoice dot customer ID. Okay, then here I will write group by I1, 2, 3, 4, okay, that's it. Okay, then I will write here order by 4 ASC ascending order, 5 to descending order. Fine. So now I will write here select star from customer with country where ROW number is 1. Fine. So let me run it. See, we have first name, last name, billing country, total spending, row number, and the customer ID. Let me show you the question. Here, write a query that determines. Okay, let me make it this one. Okay. Yeah. So write a query that determines the customer that has spent the most on the music. So customer, we have the customer name for each country. Write a query that returns the country along with this. So we have the country name, with the top customer and how much they spend. We have the total spending. For the countries where the top amount is shared, provide all the customer who spent this amount. Okay, so we have everything here, right? We have this Lewis from Brazil, this is okay with the customer ID. So this is how you can solve these questions. So till now, I can say you have a good data analytics skills. So for this, I can say this will help you in the interview of data analyst, in data science, or any SQL.
Today, we will learn Python exploratory data analytics. In this tutorial, we will be going through the fundamentals of data analysis with Python that covers the data analysis libraries, data visualizations, and much more. For better understanding, let's go through a simple use case on analyzing student performance so that we can come up with a report to assess improvisation in their academic performance. So here's the context. Let's imagine our client from the educational institute who runs a couple of schools in the city. He and his school administration identified a growing concern about the overall development of their students, realizing that academic focus alone was not yielding the desired results. To address this issue, they hired a data analyst to investigate key factors influencing student success. The analyst highlighted critical parameters like physical fitness, parental education, rest and recovery, and access to resources as contributors to students' performance. Based on these findings, the school recognized that a holistic approach is needed. They decided to invest in programs that promote overall development by focusing on key areas targeted by the analyst. The school now successfully enhances both academic performance and overall development of their students. The key to this success was Python's exploratory data analysis, using which the analyst deep dived into data about critical aspects of a student's day-to-day schedule. Now, let's go through a similar approach through our demonstration on Python's exploratory data analysis. But before that, if these are the type of videos you'd like to watch, then hit that like and subscribe buttons and the bell icon to get notified. Now, without further delay, let's get started with our Python exploratory data analysis. But before getting started with the demonstration, let's have a brief understanding of exactly what is exploratory analysis. Is this anything different from regular data analysis? Yeah, that's exactly what we're going to discuss. Now, types of data analysis. So basically, there are two different types of data analysis: initial data analysis and exploratory data analysis. Now, what is initial data analysis and what is exploratory data analysis? Let's understand a little briefing about these both. First, let's get started with initial data analysis. So what exactly do you mean by initial data analysis? So data can be in any form. It can be an Excel file, it can be a SQL file, it can be a PDF, it can be an XML, it can be even a website. Whatever it is data. If you have some information in this which can be used to extract some valuable information, then it is data. So, initial data analysis is a process of inspecting the data and screening the data that takes place after data collection and before statistical analysis. So, before you conduct any statistical formulas and analysis on the data and squeeze the data to extract some valuable insights, the process which you perform is called as initial data analysis. Like taking the data from the source, cleaning the data, transforming the data into a readable format, and using that readable data to build some basic charts. What exactly is happening with this particular company, brand, or anything. Let's say I give you some data from the company, then you get some insights of it. How many number of traffic you received, how many number of orders you received, what's the sale that you made in a specific month, specific quarter, or specific year, and what was the profit. So basic information which you convert from the data and create a dashboard, right? That is called as initial data analysis. So a step beyond initial data analysis is known as the exploratory data analysis. This is where you perform some statistics and probability and predict the future, right? So let's dive deep and learn what exactly is exploratory data analysis. So a simple definition for exploratory data analysis is as follows. Exploratory data analysis is a key step in data analysis process that helps you identify patterns, outliners, and relationships between variables before making assumptions. It is not like you just create a dashboard out of the initial data analysis and you can predict the future. No, it's not like that. You might have to you might have to go through some permutations and combinations. You might have to check the seasons. You might have to check the possibilities, right? During some particular seasons in the year, let's say it's Christmas, then you can expect some good sales. Let's say it's some festival, it's some special occasion, you can expect some good sales on the product, right? And maybe a part of the year, maybe a part of 10 years, a decade, right? In a certain period of time, there might be some reason due to which the sales of a certain product were high. So to make sure that your assumptions, to make sure that your projection of the sales is 100% accurate, or at least 90 to 95% accurate, then you might have to go through the exploratory data analysis, where you make use of statistics in your data analysis. Now, there are certain steps that you might have to follow while going through exploratory data analysis. So following are the steps. So first few steps might be slightly relevant to initial data analysis, like connecting data, cleaning it, transforming it, and loading it. After that, you will import certain libraries from Python. And after that, you read the data, what exactly you have in your data, the number of columns, the number of rows, and if there are any null values, if there are any entries which are invalid, you might have to check that, read that, and you might have to check for duplicate entries. It is possible that one entry might have been entered by two different people, right? There might be a duplication, so you might have to eliminate those duplications. You might have to check for some missing values. You might have to calculate the total number of missing values from the dataset and try to eliminate them from the calculation during your exploratory data analysis. Followed by that, you have to do some model engineering. Followed by that, you might have to do some feature engineering, creating features, and then you will get started with exploratory data analysis. And at the end, you will generate a projection or a prediction or give your assumption that this might happen in the future, and you might have to take action to avoid it, or you might have to take action to improvise it, right? So this is how the steps in exploratory data analysis take part. Now, let's proceed and start with our demo on Python's exploratory data analysis. And in this session, we will be using the use case that we discussed before, which happens to be the student's performance dataset. So in this particular dataset, we will be having some columns based on physical activity, the distance from home, parental education, the subjects, the marks they have scored in the previous exam, the marks that they have scored in the previous exam, and if they have any disabilities, if they are having any resources that they require to write the exams, right? So a few parameters, the important parameters that we will be discussing in this session, and followed by that, we will project the future, that how they will, improve in their exams, and if there is a problem and if there is a solution to that, then we can implement that solution and help students to gain better marks in their exam. So that's the overall use case for this demonstration. Now let's get started with our Jupyter notebook. Now we are on a Jupyter notebook. Now let's get started. So I would like to have a title for my notebook. So I'll write an HTML code for that. So HTML code, and I have 3 apostrophes. And here I would like to write something in H1, so I want my title to be in H1. So style will be background color. Color name will be dark blue. So let's proceed with the Simplilearn's background, which will be dark blue usually. And the color of text will be orange. And I also want to have the font. Let me give the font size as 30. And in the next line, I'd like to have border radius. I can give the border radius as 20 pixels. And padding to be 16 pixels. text alignment, I'd like to keep it center. There you go. Let's close the H1. Now let's code the background color or border color. So B style. So what we can do is we can basically have this code here, and what we will do is we will reuse this particular code segment, because we will be having multiple HTML codes in this particular workbook, which will explain the results of the analysis that we are doing. So the way we just run the code, and after that we will be getting some visualizations, and I will be writing some textual content in HTML page, so that it will be easier for the people to understand what exactly is happening here, right? So the color will be light blue, and now comes the text. We will close this, and here we will write the text as Python exploratory data analysis, and we will break here for student performance. And here we will close the H1. And lastly, we will display this in HTML code. So basically we missed this library. So we will be importing from IPython display import HTML to display this particular code. So without this particular library, we cannot display any HTML codes in our notebook. So we will quickly run that, and we have our title over here. Now let's proceed with the next part. Now we will use some libraries like CatBoost and LightBGM. So for that we might have to install these libraries. So we will be using pip install here, pip install CatBoost, and control enter to run this particular code segment, or you can also use run, and it's installed. And after that we will also install LightBGM. Sorry, not BGM. So it's already installed. Now we will start importing the libraries that we need. So we will be needing NumPy, Pandas, Seaborn, Matplotlib, and we will also import another special library which is for ignoring warnings. So we will import warnings, and after that we will be importing that warnings from IPython display import clear output, and after that we will tell the Jupyter Notebook to import if there are any warnings. So that code will be warning.filter warnings, and in the brackets we will write ignore. So the basic libraries which we will be needing are as follows: import NumPy as np. Let's quickly copy this and proceed, enter. And now we will be needing Pandas as pd, enter. And now we will be needing Seaborn SNS, and we will also use matplotlib.pyplot as plt, and after that we will import warnings from ipython.display import clear output warnings dot filter warnings ignore. Now we'll just quickly run this query, run, and now we will proceed with feature engineering. So you can use a hashtag to ignore that particular line from execution for Jupyter Notebook. And here we will be importing import re from sklearn.impute import simple imputer from sklearn dot model selection import kfold. There you go. Now let's quickly run this query. There you go. Now we will proceed with modeling and model evaluation. Once we are done with this, then we will directly import the data into our notebook. So for modeling the data, we will again use a hash code so that this particular line will not execute, and import some libraries ligt gbm as lgb from light gbm library, import lgbm regressor from catboost, import catboost regressor. There you go. Let's quickly run this command. There you go. Now lastly, we have one more task before importing the data, that is model evaluation. Once that is done, we can proceed with importing the data. There you go. Let's quickly run it. And now, so far so good, we have done the basic library imports, and feature engineering is done, modeling is done, and model evaluation is also done. Now we can begin with importing the data. So let's also add the HTML code where we have done this importing. So here I will try to add another segment, and I will import the HTML code here, which displays a similar HTML format which explains what exactly is happening here. Just a moment, I have the code ready. I'll just paste it here. There you go. Let's quickly run this so that we have a HTML code here, page here, which explains what exactly is happening here. So we are importing libraries and also student data. Now let's import the student data. For that, let's write the query. So we are importing the data as data frame, and after that we will write pandas read CSV, right? And here we will add the location of the file, right? So the file is located in my downloads section. So let's quickly copy that location and paste it here. So this is the location of my file. Let's quickly run it. So there might be some error. It's okay, we can resolve it. So in such scenarios, you don't have to worry. Either you can add an R, but even if that doesn't work, you might have to change. In this case it worked, but in case if it doesn't work, what you can do is you can eliminate the R, and you can just change this from forward slash to backslash. This will also help. So this could be worth it. So this can also work. So these are the situations where you can use this. Now let's proceed with some more interesting facts. Let's try to understand what's going on with our data set, right? So what you can do is, now the data is stored in df variable as a data frame. So what you can do is read this particular data, df dot shape, so that you can understand what's happening with this data, right? So it can tell you that there are 6,607 rows and 20 columns. Now let's add another query part, and here you can try to see the head, right? What head means? Basically, head means the column headers. So what you can do is just write df dot head and run. Now you have the column headers and couple of sample columns, couple of sample rows. Now let's proceed with checking the duplicates and identifying the total number of duplicate entries in this particular data set. So you can write down df dot duplicated dot sum, and you will get the number of duplicates present in this particular file. So we have 0 duplicate entries. Now let's see if there are any null elements in this particular data frame. So df dot is null dot sum. So these are all functions. Control enter. There you go. So in the column teacher quality, there are 78 null entries, and in parental educational level there are 90 null entries, and distance from home there are 67 null entries. Now what we can do is from df shape we can add a new cell here and we can write a HTML code so that the viewer can understand that we are trying to understand our data. So let's write a quick code for that. So let's not waste much time in just writing the HTML code. So I've got that HTML code written in a notepad already. So I'll just paste it over here and let's quickly run it so that we have a HTML visibility here. So this was supposed to be the result, so we will add it here. So what we will do is quickly edit this particular content. We'll just quickly copy this code and paste it over here. Change the content from importing libraries to reading student data, and we will cut this code from here and we will paste it in here so that it will give us some information. Let's also run this particular code segment so that we have reading student data. There you go. Now the next part of this session will be about creating a target variable. So overall target of this particular data analysis is about exam score, right? So we can name our target variable as exam score, and let's understand the distribution of this particular exam score with the variables we have. Now let's write down plot dot figure size should be around 15,9 equals to, let's add a bracket here, 15,9, or let's keep it as 6. No, 9 would be a little bigger. Now enter. Now we'll use cbound library here, sns dot count plot x is equals to data frame cleaned target. Okay, before cleaned target we might have to run a few more. Okay, we did not perform data cleaning so far, right? So let's proceed with data cleaning so far. So we found some empty entries, right, null entries, and we also found some. So here we have 299 rows which have missing values, so we will have to remove that. For that we might have to create a new column which has to be named as not assigned, right? df data frame not assigned, which is equals to df dot drop na. So we will be dropping the null values here. It's a function, and here let's print the values. Print df underscore na dot shape. So how many number of rows and columns we have, right? And after that, let's also try to eliminate the null values as well. Dot is null. So we don't have null values, but we have some illegal entries, maybe some. There you go. Now let's quickly run this query. So there you go. So the new data is about 678,20. So there is some, okay, we did some mistake here. So we are supposed to add it as null, null. Now quickly run this. So we should not get any errors this time. There you go, no errors. So far so good. Now let's describe the new data set. df na dot describe. So these are the new columns and the rows that we have, and we have mean, standard variation, standard deviation, minimum, maximum. So the scores are split into 25%, 50%, and 75%, which could be based on hours studied, which could be based on attendance, sleep hours, previous scores, tutoring sessions, everything. So minimum sleep hours, maximum sleep hours, 25% of that, 50% of that, 75% of that. So that is supposed to be the describe. Now what we will do is we have a target variable which is exam score, right? Now we will do some changes to it. We already know in an exam there will be a threshold value. It can be 25 marks per exam, it can be 50 marks per exam, and it can be 100 marks per exam, right? In our situation, let's consider the threshold value is 100 marks, right? If there is a situation where marks is entered in a wrong way, right? It can, if they wanted to add 11, But by mistake, if they added another one, right, triple one, it's not a right entry, right? So we will try to eliminate those kind of data. So we will create a new data frame here, which is data frame cleaned is equals to data frame underscore not null. So we have eliminated the null values, df underscore na. Now we will add our target variable, which is exam score should be. So let's come out of this, and here we will add it as should be less than or equal to 100, but not more than 100. Let's use square brackets. Here we also, the format is square brackets actually. Now enter, and we will describe this particular data set. Instead of dfna, we will copy paste this here. Now let's run this. Okay, exam score is not identified. Let's quickly check the error and resolve it. Yeah, so we missed out to add colons here. It's okay, not a problem. So this was supposed to be how it is. Now let's run this, and we will have the answer over here. So we have the output. Now let's check the head of this particular cleaned data set. So we can make use of the same code here and paste it right here. And instead of describe, let's write head, so that we have the header of this particular data set. So we have our study and everything normal, and we will categorize the data, right? So we will make use of 3 columns: hours studied, attendance, and previous course. And after that, we will also make use of other columns in this particular data set, which happens to be the parental involvement, access to resources, sleep hours, tutoring sessions, etc. And now our target will be the exam score that we created over here, right? This exam score will be our target. And using this particular exam score target, we will categorize the data, okay? We will categorize the data in terms of, let's say, first class, second class, and pass or something like that, right? So if a student is scoring below 64, and that is a separate category. If the student is scoring equals to or above 65, that is a different category. And if the student is scoring beyond 70, that's a different category. And before we proceed with that, let's try to add a HTML code before this particular data set, so that we have an understanding of what exactly happened here. So I'll just quickly copy paste this particular code here. So we will run it. And now next we will check the data type, column separated and everything, and we will create data type category variables, right? And now so far so good. Now we will create the categories. So num call equals to hours studied, comma, attendance. So let's quickly add the data. Previous exam scores. Just a minute, let's quickly add the columns. Let me take a while. So there you go, I've added the columns. So we are considering 3 different columns: hours studied, attendance, and previous course. For num call and cat call, we are considering the other columns apart from the first 3, and our target value is exam score. Let's quickly run this. There you go. And now we will try to build some visualizations. And before that, let's try to add some data from in HTML. Let's try to create a, okay, what we can do is simply copy this particular HTML file here. We can take this and add it here, so that we will understand what exactly is happening next. And in place of reading student data, we will write data visualization for student data. And we will keep the colors same, dark blue background, and the color for data visualization will be light blue, and student data will be orange. Let's quickly run, and there we have it. Now our target variable is exam score, right? Now we will compare this particular target variable with 3 other parameters. So our parameters will be the following, as we discussed, creating the segregation in dataset, right? So first will be distribution of target variable with other parameters. So we will create another HTML file for that right here. Just a minute while I paste the code for HTML. Quickly run this. There you go. So distribution of target variable exam score against some parameters. Now we will write the plot for that. Plot.figure. So we are going to consider the size equals to 15,6. Fig size is equals to 15,6, the same one that we considered before, and we will be using cbon SNS dot count plot, open bracket, is the function, x is equals to df cleaned. Okay, what we can do is just quickly take the column name so that we don't create any mistakes here, and we will paste it over here instead of df. There you go, of target. So our target is exam score, comma, and we will use the palette as green, and the plot title will be distribution of target variable exam score. We can copy this. Okay, just a minute. Before that, plt dot title should be, let's use double quotes. Now copy this and paste it here. I think semicolons went off. Okay, not a problem. It's right here. Let's add a dot as a full stop, and the next line, if you need you can add the full stop, if not you can ignore. plt dot grid true, which equals to major, comma, axis is equals to y, comma, line style equals to, so I want lines to be hyphen hyphen, in this way I want the lines, and comma, line width, let's say 0.5 or 0.7, let's go with 0.7, line width equals to 0.9 mm. There you go. Now let's quickly run this query. There you go, done, and we have the first visualization. So here you can see there are some students which are scoring 58, 59, and you can see maximum number of students are already scoring good marks, which is under 65 and which is under 70 and above 65, and there is a good number of students which are also scoring above 65 as well, right? So 70 as well. So we have now less than or equal to 70, 71, and highest scorer in some situations there is also 100. If you can see, there is slight growth here. There are a few students, toppers maybe, which have already scored 100 as well. Now we have the list here. Now what we need to do is we need to segregate. That is part 1, which is less than or equal to 64, which falls under 65, and another category which falls in between 65 to 70 and above 70. So we need to categorize these three datas and segregate them as bottom 65, top which is above 70, and mid between 70 to 65, right? Now before that, if you want to add an HTML document segment here which explains about the distribution of target, you can also do that. It's already added here. Now let's continue. But in case if you want to add some data which explains that we are trying to segregate, you can also do that. I would like to do that. Let's quickly add that HTML code here. So what this particular code will do is it will tell the percentage of students which are scoring less than 65, number of percentage of students scoring in between 65 and 70, and the percent of students which are scoring beyond 70. Right, let's run this, and here we have the result. Bottom 21.81% scores under 64, while 24% scores over 70, and 50% are in between 65 to 69. Right, now let's continue with the segregation part of the data. So for segregation, we will create 3 different variables, A, B, C. So first, A is equals to length of df cleaned. So let's copy the column name, data frame name, length of df cleaned. Inside the square brackets, we'll again add df cleaned of target variable, which is exam score, let's also add single quotes here, who are scoring in between or less than. Let's start with less than or equal to 64. We'll not consider 65, we'll consider 64 divided by ln of df cleaned target variable exam score single quotes into 100, which will give us the percentage. Now similarly, let's just copy and paste this 3 more times for B and C. So here instead of minus, I was supposed to add equals to, and another one. So here equals to, and instead of A, I will write B, and the last one is C. And instead of 64, we will add 70 here for top, and here we will make some changes. It should be greater than or equal to 65. So this is the third category, A, B, C, and then we will proceed with printing the files. So print the bottom for the first one, which is f of A is to dot to f, and we will add the percentage symbol over here, R under 64. Now we can copy paste the same here, and we can change the variables. So here we will be adding under over 70. Lastly, in between, the ones in between, 65 and 70. There you go. Here we will change the values from A to B, and here A to C. There you go, and we can quickly run this query. So it's not 70, it was supposed to be 69. There you go. So we forgot to mention this particular one. Now let's run this. There you go. So we have 21% of people who are scoring under 64, 24% over 70, and 53% are in between average. So I think the school is focusing on improving this particular percentage, reducing this particular percentage, and increasing this particular percentage, and try to eliminate if possible this particular one which are under 64. So that is the overall motto, I guess. Now, so far so good. Let's now try to remove infinite values from HTML. Right, so before that, let's add this particular HTML code here, so which explains what we are trying to do. So we will first implement the code that prevents warning about infinite values during data visualization. And now let's add the code which will try to eliminate the infinite values. Let's copy this particular data frame cleaned data frame name here. Now df cleaned dot replace square brackets np dot info comma minus np dot info out of these square brackets dot np dot na non-na values. We're trying to eliminate na values. In place of those values, you can write true. And after that, we will try to eliminate the null. So if it is null, dot sum, give me the total number of null values after this, right? So let's try to execute that. There you go. So all the null entries have been removed here. Now let's see the distribution of numerical values here. So before that, let's add the HTML code for that. So let's quickly run this. So distribution of numerical values. So we will be considering these three parameters. So if you go back, here you can see hours studied, attendance, and previous course. So we will be considering these three values or these three columns and check the distribution of these variables against the exam score. So is it making any kind of variation if the attendance is high? If the attendance is high, is the exam score high? And apart from that, we have if our studies is high, is the mark score is high, and if the previous scores are high, is there a chance to get better scores in this particular exam? So what we are trying to do is we are trying to see if there is any direct involvement of number of study hours and number of days attended and number of or the number of marks they received in their previous course. And we'll try to build a visualization on that front. So let's go and build that. So we'll try to write the code here. Figure access equals to ELT dot subplots. So we will be having 3 different plots here since we're considering 3 different categories, and the fixed size should be equal to 12,4. There you go. Now access is equals to access dot rebel for IDX comma call in enumerate. Call. And we will try to import the cbound library here. We will try to create histoplots here, histograms here, histoplot. So line style, we will be selecting this one, and comma. Line width will be 0.7. There you go. Next will be access IDX dot set title. So for this we will be setting the title as distribution of columns. So the columns will be the 3 ones: attendance, hours studied, and what was the third one that we considered? Previous course, right? So instead of mentioning them specifically, what we can do is we can just write columns here, COL, and close. There you go. And lastly, plt.height and show the plot. There you go. Let's try quickly run this query. Run, and now we will be having the visualizations here. So you can directly see the involvement of these 3 parameters here if they are trying to help. If the number of hours are increased, then you can see if there is a better improvement in scores. If the attendance is increased, if there is a betterment in scores, or if the previous scores are helping, then you can find it out how it is. There you go. Now we can write a result here in the form of HTML page, and if we run this, it will give you the result. The breaks or gaps in the hours studied variable may be due to the respondents answering appropriately. The variables attendance and previous scores, which exhibit a uniform distribution, have a normal impact on exam scores variable, which is our target variable. Now let's proceed with another part of this session, which will be about the relationship between the numerical values and the target variables. Now we will copy paste the same code and make some minute changes to it. So the only change that we did to it is we're trying to build a scatter plot. So we will be getting a scatter plot here, but before that, let's try to add another column here and try to add an HTML code which explains why we are doing it. There you go. A scatter plot. So basically these two are one and the same. Here we use some column graphs. So here we did the same using the scatter plot, which will help for a better understanding. Now we will try to build some correlations. So basically a list is called correlation is created containing the names of the columns for which you want to calculate the correlation. So here in our situation it is the df.corr, which is a data frame, and it is created by selecting only these columns for df cleaned data frame, effectively created a new data frame containing only the specified columns. Now the second one, which is the corr, which is a calculate correlation. So this method computes the correlation matrix for selected columns, which is in df.corr. The 1 indicates perfect positive correlation, -1 indicates the perfect negative correlation, and 0 indicates no correlation. And lastly, the setup of plot. This line sets up the figure size of the plot. In this particular situation, we are choosing 5 and 4. Right, now let's quickly try to execute this query and see the answer. And we will also add the HTML code for this so that we have a better understanding for this. So we will be adding that HTML box here, which will explain what exactly happened here. So this is our plot and this is the correlation. Now let's try to add that HTML code right here. So the result of this particular data visualization will be maintained here. So the hours studied and attendance shows a positive correlation with the target variable, which is exams hour. However, previous course appears to have no or little relationship with the target variable. Right, now let's continue with our next part of this session. So now we will try to identify the relationship between studies, hours, and attendance and extracurricular scores. Right, so we have other columns to consider, which is extracurricular activities. So there is a belief that extracurricular activities will also help students to study better. So we will find if there is a relation between the target variable and these extracurricular activities, attendance and study hours. Now let's quickly add the code here. Now let's quickly execute the code. Now we have the visualization, which explains the relationship between the number of hours studied, extracurricular activities, etc. So here it is. And now let's add an HTML code which explains about this result. I think this particular code was supposed to be added here. So this is the resultant column here. Now here it explains about the influences that it performs. So the extracurricular activities, parental income, and extra things that influence the scores. And there you go. Now let us also consider other columns, right? The other parameters like resources are available or not, parental education, and other things which also might have influenced the exam scores of students. So for that, let's add an HTML code so that we have an HTML page here which explains what is the next procedure that we are following, right? Now let's add the query here. So here we are considering the other parameters like family income, peer influence, motivation level, gender, parental involvement, parental educational level, and extracurricular activities. And we are considering them against the target variable, which is exam score. And now let's execute this query. There you go. Now we have generated a graph which explains about this particular parameters against the target variable. And now let's add the HTML page here which explains about these results. Let's quickly run it, and there you go. So when certain factors affect Q1 and Q2 but not Q2, it can be understood that individual has overcome challenges through personal effort, right? So if government policies and corporate social contributors are focused on addressing these aspects, it seems that we could create a dynamic country with greater social mobility and open opportunities for all, right? So if extracurricular activities can outweigh the influence of other variables in academic performance, then we should foster that kind of an environment, right? So this is how you can extract some statistical analysis on this particular data set. Now let's quickly rename this Python EDA students performance, and you can quickly rename and save it. Today we will learn data analytics with AI. That's it. If these are the type of videos you'd like to watch, then hit that like and subscribe buttons and the bell icon to get notified. Let's get started with the main topic of today's session, which is data analytics with AI. So before proceeding with data analytics with AI, let's understand what exactly is data analytics. So data analytics is not just a step where you just give your data to AI and it will be done, right? So it's a stage by stage process. Let's understand all the stages one after the other. Firstly, you might have different sources. So before we go ahead with the sources, let's understand the situation. You might be dealing with your client. You might be working with the company as a data analyst. So before you begin with the data analysis, you might have to have a conversation with your client or the company. You might have to go through something called as requirement gathering, right? So requirement gathering will let you know from where exactly you're getting the data. Is it in the form of a PDF? Is it in the form of an Excel spreadsheet? Or is it going to be cloud, or anything like that, right? So you'll be understanding what the source exactly is. And followed by that, you will understand what is the request of your client, what he's looking for, what he wants you to give him, right? The insights of the data, which part of the business he wants you to focus on, and which part of the business he wants to improve, right? And followed by that, you will come up with a time span. Within that time span, you need to use that data, build some insights, and give it to the client or your business owner so that he comes up with a business decision, right? So that's the first requirement gathering step. Once you have the source, you come up with the next step of the data analytics, which is cleaning the data and transforming the data. So it's really obvious for any beginner or an expert who is a data analyst. It is cleaning and transformation what makes or what adds value to your data. Once you clean your data and transform it. So what exactly you mean by clean and transform? So let's say you might have some blank entries, or might be some wrong data type, or there might be some places where you might have to split the data. For example, if there is a customer and customer ID mixed up together, let's say customer ID 1345 hyphen the name of the customer, right? You wanted to split the customer ID and split the customer name. Then comes the data split option. Apart from that, if you want to categorize the data into buckets, let's say you might have a column for customer age. There might be customers starting from 10 and all the way end up to 80, right? In those scenarios, you might want to split the data into buckets. Let's say 10 to 20 are teenagers, and above 20 to 30 are youth, and above 30 to under 50 or under 60, let's say like 59 are adults, and after that maybe senior citizens, right? Then you have a smaller window so that you can capture which category of the age group is bringing you the most of the revenue, right? So these are the parts of cleaning the data and transforming the data. And once you're comfortable with it, then you can choose a platform where you want to analyze your data, which can be Tableau, which can be Power BI, ClickView, or Excel, or any of the tools that you might want to prefer. In our scenario, we want to go with AI, right? So AI can be anything. You can go with the Microsoft's Copilot. You can go with the OpenAI's ChatGPT. You can go with Google's Gemini, or any of the AIs which can perform data analytics. There are some AI tools out there which are dedicated for AI data analytics, right? And once you're done with it, and the final stage is analyzing the outcomes and reporting that to your business owner or client. So I hope I made myself clear with the stages of data analytics and reporting. Now let's look at an example to explain this a little better. So I have the dataset in Excel for now. This is our source, the first part of data analytics. Let's expand the columns. So there you go. I said something about data type. So here you can see we have some different data type which we don't want, which is in general. So we will change this data type to short date to make a little more meaning out of it. And after that, here we have customer ID, right? So what we will do is use data split here. Go to text to columns, delimited. Next. So we have other. So here's the preview. So you will be receiving it in this form. And if you want to format the data as you like, you can go ahead. So I'll leave it as general for now and finalize the data type after the split is finished. So what you can do is add a column, new column here, so that you can get an empty column here to split the data. Go to text to columns once again. Select delimited. Select next. And we have the input other. Next and finish. There you go. You have customer ID and you have customer name, the respective customer name here itself. So, proceeding ahead, we have quantity, the quantity of product ordered, and we have traffics, leads, orders, and revenue, right? Cost to company and delivery status. So, in case if you wanted to kind of calculate profit, what you can do is add a new column, profit, and here you can do a mathematical calculation equals to revenue minus cost to company, and you can extend this particular column all the way to the end so that you have the profit numbers. And here you can also change the data type to currency and go to home, and here the data type from general to currency, and there you go. And if you want it in rupees, you can go with rupees, or if you want it in dollar, you can also have dollars, right? So that's how you do it. I would like to go with dollars, so more, and here go to currency, and in currency symbol I'll go with the dollar. Then okay, there you go. You can quickly save it. If you want to add some borders to the data, you can also do that. There you go. So far so good. So we are now good data. Now comes the next step, which is loading the data and analyzing it, right? So currently we choose the platform as Excel. So you can do this on Excel, Power BI, and ChatGPT as well. So let's go with the first one, which is Excel's AI. So here you can see analyze data, or also people call it the co-pilot of Excel, right? Now you can just click all the data and click on analyze. Basically what you can do is insert and go to the pivot table option, and here you can insert a pivot table, and after that you can find out the requirements what you want, the sales from the central region, south region, and which category of the products have been sold the highest, and what's the highest grossing product, what are the number of leads, and you can estimate the performance of traffic on a month-on-month basis, right? You can do that all, but if you want to reduce the time, basically I would like to tell you, go to that particular part first. Understand manual process, and after that, go to the analyze data option, which is the automated or AI generated report, right? It will now read your data and it will give you some insights from the data given. Right here you can see the cost to company by order status, and here you can see you can set up a pivot table for that, and here you can see you can insert some graphs and charts here, bar graph, and here you have another one. Now you can see that it has all 24 results, all the insights. Now if I can ask, give me a pie chart of sales and category. Here you go. Here you have so basically what Copilot did is it created a pivot table of sales and category, and out of that pivot table it extracted the pie chart and generated one for you. In this way you can create multiple options. Let's say I want to create a line graph month on month. Enter. Now here it again created a pivot table, and here it generated a line graph on month basis and how many number of traffic or how many number of visitors your website had. Right? In this way you can create a long list of all the required charts and graphs for your website and or the client, and create a dashboard out of it, which is completely interactive. Now this was the Excel's AI. Now if we go to another one, which is Power BI, so here you can see a completely prepared dashboard in Power BI, and we can create this once again, or you can at least understand how it was done, right? Now let's get the data from Excel workbook, So my workbook or my data set is somewhere here, sales data. I would like to go with orders data. Only one file is enough for 2024, and your data will be shortly loaded. Select spreadsheet 1 and load the data. Since we already transformed it, there is no need for transforming it once again. So the data is being loaded successfully. It's going to take some time. 2000 rows loaded. Sheet 1. So we are going to work with sheet 1. Now you can select the visualization you want. Like I want to create a line graph here. Repeat. Like I want to create a line graph here. Select. And for this particular line graph, you will have fields, x-axis and y-axis. Now what I'll do is I'll drag and drop date to x-axis field and traffic to y-axis field. Now here in x-axis, I would eliminate year, I would eliminate quarter, I would eliminate date. I just want month on month, right? Here you have a clear month on month traffic line graph. Right now, let's quickly delete it. We don't want this now. And remove it. Now, what if I tell you there is an option where you can just double click and or right click and you will get an option. Here you can query, right? You can just write down the query, line graph, type of graph you require, traffic, write the spellings correctly, month on month. And enter, you will get the graph you are looking for. There you go. Right? So apart from this, let's put the month on month graph here. Apart from this, let's double click once again and category wise sales. Category sale, pie chart. There you go. And now region wise, double click once again. Region wise sales, bar graph. Select the first one and there you go. I think there is a small mistake in the selection, spelling. Select the first one once again and there you go. You will have a bar graph in region wise basis. Or we can also go with similarly, we can also go with a map chart for states and revenue. Select the first option and you will have all the American states and their revenue details here. Right? So in such way, you can use the artificial intelligence of Power BI and create a completely interactive graph just like this one. So if I select the standard shipment mode, what are the sales reports? And if I select the entire shipment modes, what are the reports? And if I select the home category, what are the sales reports and which part of the nation and which and what are the sales and order per month, traffic and everything details here, right? In one go. It's completely interactive. Now, let's move on to the next part of our session for today. So we will be using ChatGPT for our data analytics. So here you go. Now, let's load the data. Before that, let's write a prompt. Some data on sales. Or sales reporter. Visualization. And now load the data. Upload from computer. And we have the sales data here. The orders data. Select the orders data file and open. The data will be loaded shortly, and since it's loaded, you can just push the command or prompt. It'll first review the contents and understand what exactly is present in your content and the data type along with the data type, right? It has 2000 entries, 17 columns. Here's the brief overview of all the columns. So it's asking you, would you like an overall summary or a specific aspect? So let's go with the specific aspect instead of overall summary. I want region-wise sales as a bar graph. Okay, we didn't have a column as bar sales. It's in turn taking revenue. Yes, there you go. Sales revenue by region as a bar graph. Now, pie chart for category revenue. Okay, so there is some limit for analysis. Okay, that's not a problem. We can change the account and try to do it once again, or I should have chosen the overall summary, right? But if you go to the ChatGPT Plus edition, you can get that. Let's try the Plus edition once. So we are on the Plus edition now. So it generated some visualizations, which is completely downloadable here. You can go with that as well. So the prompt is still running. Let's wait for a couple of more minutes and see what exactly ChatGPT is up to. So here we have a profit by category, which was our second request, which did not get successfully authorized because we didn't have a +1. So now we can see revenue versus cost to company in top 10 products. So which are the top 10 products which are giving the maximum revenue? And here is a detailed report. And if you would like to continue with a few more reports like we did before in Power BI and Excel, like traffic versus month on month is a line graph. Let's try that. There you go. So we have a line graph of traffic on a month-on-month basis. So that's how you can conduct some data analytics using different AIs on different platforms. So there are many number of platforms: Tableau, Power BI, ClickView, Excel, SQL, ChatGPT, Gemini, and a few more dedicated artificial intelligence tools which are for AI data analytics. And that brings us to the next part of data analytics with AI. So how does data analytics and AI work? So first, basically, once you load the data, AI will start preparing and processing your data, right? So the transformations, what you do, are also can be possible in AI as well. If you request AI to do the transformations, it can do itself. But I would recommend you perform the transformations because you know what the exact requirements are. Once your data is completely transformed, you can load it and get the reports. The next part of it is pattern recognition. As you have already seen, ChatGPT recognizes each and every aspect of the data, from the data type to the minute details like currency and everything. It understands the data first, and then it will request you. It will ask you if you want a complete summary or if you are looking for a particular aspect, right? Machine learning algorithms can identify patterns, trends, and relationships that may not be apparent to human analysts. And there is a possibility that ChatGPT can even identify a few more insights that you never expected to have, right? And moving on to the next part, predictive analytics. AI can also perform some predictive analytics and give you the forecast of what exactly is going to happen in the upcoming future in your business. That may or may not happen. If you find something is about to go down, you can prevent it by taking some predictive steps or measurable steps which can avoid that loss, right? And automated insights and reports. You can also request ChatGPT, right? In Excel, there is something called as Power Query. It acts like a macro or Excel VBA where it stores each and every transformation step you apply. In a similar way, Each and every transformation or step that you apply to modify or try to add value to your data and teach that to your AI so that it can also understand that particular automated transformation steps and report to you on a month-on-month basis, right? So this will stop your month-on-month activity of cleaning your data, transforming your data, loading your data, analyzing, extracting some insights, and then creating a strategy. So all these steps will be eliminated because ChatGPT or any other AI will take care of it, and you can focus on implementing some business strategies. And we have decision making. So AI can also help you with some critical business strategies and also help you in decision making. AI algorithms can optimize complex processes and decision making by evaluating multiple variables and multiple scenarios. Now, last but not least, continuous learning. So AI is capable to adapt and learn new things in your business, like how it processes, how it functions, and what's the data source, and most of the aspects in which are involved in business and data analytics. AI systems have the ability to continuously learn and adapt based on the new data and feedback.
Imagine you are getting ready for a big road trip with friends. You are excited, but when you open the trunk to load your bags, you realize it's a disaster. Old stuff from previous trips, random items you don't need, and half of your essentials are missing. Would you just hit the road? Of course not. You would first clean out the trunk, sort through the clutter, pack what's important, and make sure everything is in place. This is exactly what data cleaning does for your data before you dive into analysis. Hey everyone, welcome back to Simplilearn's YouTube channel. Today we have got an exciting topic lined up, data cleaning in data mining. I will be taking you through what data cleaning is, why it's super important, the steps involved, and some of the top tools you can use to make your data shine. And most importantly, at last, I have a surprise test for you guys on the same topic. Let's get started and turn your messy data into pure gold. Before jumping into the video, let's have a glance at data mining. Data mining is a process of uncovering patterns, trends, and valuable insights from large amounts of data. It helps people find hidden information that can guide better decisions in areas like businesses, healthcare, and more. Data pre-processing is an important step in the data mining process. It refers to the cleaning, transforming, and integrating of data in order to make it ready for analysis. By now, you must be curious about data cleaning. Let us understand what data cleaning actually is. Data cleaning. Data cleaning, also known as data cleansing or data scrubbing, is the process of identifying and collecting errors, inconsistencies, and inaccuracies in a data set to improve its quality and reliability. In simple terms, it involves making sure that the data you are working with is accurate, consistent, and ready for analysis. Now let's understand why data cleaning is important. Imagine trying to bake a cake with expired ingredients. Your final product would not turn out great, right? That's exactly why data cleaning is so important. If your data is messy, with errors, missing values, or duplicates, any analysis or insights you try to get from it won't be reliable. Clean data ensures that the results you get are accurate and trustworthy, helping you make better decisions. It's like starting with fresh quality ingredients, you will end up with a much better outcome. So, before diving into data analysis, always make sure your data is squeaky clean. Just a quick info for you guys. If you are really interested, then do kickstart your career in data analytics with Simplilearn's #1 Data Analyst Certification Program in collaboration with IBM. This action-packed course is designed to equip you with cutting-edge skills in SQL, Python, R, data visualization, and predictive analysis, all while working on real-world projects. With live classes by industry experts, exclusive masterclasses from IBM, and hands-on hackathons, you will gain the confidence and expertise to excel in the fast-growing world of analytics. Don't wait, join thousands of learners and take your career to the next level. Link to the course is in the description below. Let's now move on to the various steps involved in data cleaning. Step number 1 is data import and understanding. This step involves loading your raw data into a tool like Excel, Python, or R and getting a general sense of what's inside the dataset. For example, taking this table, you notice the following issues. The data for the age of one employee is missing. Duplicate entries for John Smith. Now moving on to the step number 2, that is remove duplicates. Sometimes the same data might be entered twice, either by accident or due to data merging. For example, John Smith has duplicates. So, you need to remove the duplicate rows where all the fields are identical. You can spot that John Smith has two identical rows, and after removing the duplicates, John Smith has only one row. Now moving on to the third step, that is handling missing data. Data is often incomplete, meaning some entries are missing important information. Some common ways to handle missing data are imputation, removing missing data, flag missing data, and etc. Taking an example, you see that Emma Johnson's age has a missing value in the age column. You can choose to fill this with the average age of employees or other techniques like imputation. So after handling the missing data, we can see that Emma Johnson's age is 38. Missing data can throw off your analysis or make the dataset incomplete, so you must handle it very carefully. Now moving on to the fourth step, that is correct structural errors. In this step, you correct issues such as inconsistent formatting. For example, you might see the department names recorded differently. Like, the department is human resource and in one of the department is written HR. So after we handle it, it comes as the department should be written in the same format, either HR or human resources. Now moving on to the fifth step, that is standardization and normalization. This step ensures that your data uses the same format or scales. For example, John Smith has 50,000 salary and Jane Doe has a 60,000 salary, but the comma is missing. You might also normalize the salary values if you're going to compare them on a different scale, like scaling them between 0 and 1 for machine learning models. So after we handle it, either we write everything as same or we include comma in both. Now moving on to the next step, that is handling outliers. Outliers might include a very high salary that doesn't fit the usual pattern. For example, you notice that Mark Davis has a salary of such a high range. If you check the outlier, it is either real or an error. If mistake, you need to correct it. So after we handle it, we can name it as 90,000. Now moving on to the next step, that is the filter unnecessary data. You might find that some columns are not necessary for your analysis. For example, if you're analyzing the salary trends, you don't need the employee's favorite snack column if it is in your data set. So we need to handle it and remove it for a better understanding. Now moving on to step number 8, that is handling inconsistent data. Sometimes data is recorded in different ways across your data set. For example, someone wrote NY for New York while another person wrote New York completely. So, after handling the inconsistencies, either we choose NY or New York. Now moving on to the ninth step, that is data validation and integration checks. You ensure that the data follows logical rules. For example, you find an employee with a negative salary or an impossible age. That is, Mark Davis has -5 age and it has John Smith has negative salary. That is not possible. So after we handle it, we must be Mark Davis age as 45 and John Smith's salary as 50,000. Now, the last but not the least, the last step is export clean data. Once you have cleaned the data, you save it in a format that's ready for analysis. Save the clean data set in a file format that suits your tools like CSV, Excel, SQL. After all the cleaning, it's crucial to store your data correctly for future use or analysis. By following the steps, you're turning messy data into a clean, accurate, and consistent resource that's ready for analysis. Just like preparing ingredients for a great meal, clean data leads to better insights and smoother decision making. Now, performing all the steps manually can be a bit hectic, but that's where data cleaning tools came to the rescue. So, to make your work easy, I will tell you the top 6 tools for data cleaning. Let's jump into those. So let's see what are the tools for data cleaning. The number 1 tool that comes is OpenRefine. OpenRefine is an open source tool designed for working with messy data. It helps clean, explore, and transform large data sets. It's perfect for users who need powerful data cleaning without breaking the bank since it's free. The second tool is Trifactor Wrangler. Refactor Wrangler is a cloud-based tool that automates data preparation with smart suggestions for cleaning and transforming data. Its user-friendly interface and automation saves tons of time, making it ideal for both beginners and professionals. The third is TIBCO Clarity. TIBCO Clarity helps businesses clean and standardize data, removing duplicates and ensuring accuracy. It offers powerful features for data validation and cleansing, all within a simple cloud-based platform. Now coming to the fourth one is WinPure. WinPure specializes in data cleansing and data duplication, making it easier to manage clean, accurate databases. It's a go-to for businesses that need to clean customer data or CRM systems efficiently. The second last one is Melissa Clean Suite. This tool focuses on data quality, helping companies clean and enrich their data with standardized formatting and validation. It's great for ensuring data consistency, especially for postal addresses and contact information. Last but not the least is Data Ladder. And Data Ladder provides tools for cleaning, matching, and deduplicating data, helping businesses manage their data more efficiently. Users love it for its reliability and effectiveness, especially when dealing with large volumes of data. Basically, there are a lot of tools available for data cleaning. Choose according to your need and requirement. So, here is a question for you guys. I hope everyone will comment on your answer in the chat section, and let's see how many of you have really understood the topic. So the question is, which of the following is not a common data cleaning technique? And here are the options: removing duplicate records, handling missing data, normalizing data, and adding random noise to data. I will allot a time of 1 minute for you guys to answer this.
Welcome to Simplilearn. In this video, we are focusing on ChatGPT and its groundbreaking role in data analytics. In a world where data is the new gold, understanding and analyzing this wealth of information is crucial. But as the volume of data grows exponentially, traditional analysis methods are being pushed to their limits. Enter ChatGPT, a revolutionary AI developed by OpenAI that's transforming how we approach data analytics. But what makes ChatGPT stand out in the crowded field of data analytics tools? How can it not only streamline complex processes, but also uncover insights that were previously hidden in plain sight? Stay tuned as we unravel the capabilities of ChatGPT, share real-world applications, and show you how it's being used by analysts and businesses alike to make smarter, data-driven decisions. And whether you are a data scientist, a business professional, or just a tech enthusiast curious about the future of AI in data analytics, this video is for you. So let's dive in and discover how ChatGPT is not just revolutionizing data analytics, but also how we understand and interact with the vast universe of data. And don't forget to hit that like button, subscribe, and ring the bell to stay updated on all our future explorations into the fascinating world of technology. Now let's get started and unlock the potential of ChatGPT for data analytics together. So guys, an Excel data analyst always looks for ways to improve their efficiency and gain deeper insights from the data. That's where ChatGPT comes in handy. So ChatGPT is an AI-powered language model that can assist you in various tasks, including Excel-based data analysis. And for that data analysis, let's dive into some demos to see how it works. So guys, as you can see, this is the ChatGPT 4, and you could see this has the support of DALL-E, browsing and analysis, and usage limits may apply. Like we have the version that has some usage limits. And for the data, I have downloaded the data from the Kaggle. I will provide you the link in the description. If you want to download the same data, you can. And I have that in my downloads. So this is the data that we'll be using. So the first thing we'll be doing is data cleaning and preparation. So firstly, let's explore data cleaning and preparation. Before diving into analysis, it's essential to ensure our data is clean and ready for processing. So for that, we will write a prompt in ChatGPT and ask him to clean the data. ChatGPT has the feature to insert the files, provide the Excel file to the ChatGPT, and we'll ask him that can you help me identify and remove duplicates in this Excel spreadsheet. So let's ask him, can you help me identify and remove duplicates? Duplicates from this Excel spreadsheet, from the provided Excel spreadsheet. So you could see that ChatGPT has started generating the response, and he is telling us that he can definitely help us with that, and he is analyzing that. So you could see that ChatGPT has provided us the response. So let's first go to our spreadsheet. So this is the spreadsheet: order number, quantity ordered, price of each quantity, and order lines. So you could see that first ChatGPT has encountered an error, and that is with the character and coding mismatch. And then he has loaded the spreadsheet successfully with the second attempt, and you could see that he has provided like the smaller or the briefer version of the spreadsheet. That is, the dataset consists of sales data with columns such as order number, quantity order, price each, order line, sales, order date, status. So he's asking us, could you specify how you would like to identify duplicates? For example, should we consider a row a duplicate if all its values match another row exactly, or are there specifically columns we should focus on to determine duplicates? So we should, or here we'll be focusing on the column section. So here we want to identify column section. So is asking which columns they should identify duplicates. So we want the duplicates in order number. So the ChatGPT has started analyzing the spreadsheet. So you could see that ChatGPT has produced the response that they have identified a total of 2,807 rows in the spreadsheet that have duplicates based on the order number column. So this indicates that multiple rows share the same order number, suggesting there might be different items or transactions within the same order. So would you like to proceed by removing these duplicates while keeping either the first or last occurrence of each order number, or do you have another approach in mind for handling these duplicates? So before identifying the duplicates, what we'll do is we'll first get rid of the extra spaces. So we'll ask ChatGPT that first find the extra spaces in the spreadsheet and help us remove them. So you could see that it has started analyzing it. So he is asking us that would you like to proceed with any further cleaning or data manipulation? Yes, we want to proceed further with data cleaning only. And now we will treat all the blank cells if there are any. Now treat all the blank cells if there are any. So the spreadsheet contains blank cells in the following columns with the respective counts of blank entries. That is, address line 2 has 2521 blank cells, then the state. So depending on your preference or the requirements of your data analysis, we can treat these blank cells in several ways, such as filling them with a placeholder value that is not provided using a specific value that makes sense for data. That is, example, a default state or territory, but potentially leaving them as if blanks carry meaningful information in the context of your data. So what we will do, we will provide a placeholder. Provide a placeholder instead, that is not provided or not applicable. Okay. So you would see that ChatGPT has responded that it has replaced the blank cells in the columns, that is address line 2, state, postal code, and territory with the placeholder not provided. So you could see there's a verification sample showing the updates. So this is how you could clean the data. And now with ChatGPT, you can quickly identify and eliminate duplicates in your Excel spreadsheet using built-in functions and formulas, saving your time and effort. So that would be done by the ChatGPT, and you can download the Excel file from the ChatGPT only. After that, you can just ask him that provide me the output or the resulted spreadsheet. So if we talk about now data analysis and visualization, let's delve into that. So Excel offers powerful tools for analyzing and visualizing data, and ChatGPT can help you make the most of them. So for this also we'll write a prompt to the ChatGPT, and we'll write, for example, please create a pivot table and a corresponding chart to analyze sales performance by region. So let's see, like this prompt, what output does ChatGPT show to us. So let's ask him, please create a pivot table and a corresponding chart to analyze sales performance by region. So you could see that ChatGPT has started analyzing the data and the spreadsheet, and you could see that the pivot table below shows the sales performance by region or the territory. So this table indicates that the EMEA region has the highest sales performance, followed by regions where the territory was not provided, then APAC, and finally Japan. So now let's create a chart to visually represent this sales performance by region. You could see that it has provided a chart, that is a bar chart illustrating the sales performance by territory. So you could see the guys that it has provided us the analysis, and ChatGPT can guide you through the process of creating pivot tables, charts, and other visualizations in Excel, enabling you to gain valuable insights from your data with ease. So let's move to advanced analysis and automation. So lastly, we will explore advanced analysis and automation. So Excel capabilities extend beyond basic functions, and ChatGPT can help you leverage its full potential. And for this also, we'll write a prompt to the ChatGPT that can you assist me in building a forecasting model to predict future sales based on historical data present in the spreadsheet. So let's see what ChatGPT respond to us. So let's ask him, can you assist me in building a forecasting model to predict future sales based on historical data. So let's see what ChatGPT respond to us. So you could see that building a forecasting model to predict future sales based on historical data involves several steps. So for this, you have to prepare the data, select a model, train the model, evaluate the model, and make predictions. So let's start by preparing the data. We'll aggregate sales by order date to create a time series of total daily sales. Then we'll choose a model based on data's characteristics. So we will grant the permission to ChatGPT to proceed with the steps. So we have started analyzing the data. So you could see that the data has been prepared into a time series of total daily sales. And before choosing a forecasting model, it's helpful to visualize the sales time series to understand its characteristics such as trend and seasonality. So ChatGPT has plotted a daily sales data, and then he has given the visual trends and the possible seasonal patterns. And the next steps would include testing for stationarity, model selection and parameter tuning, model training, and then forecasting. So you could follow all these steps with the help of ChatGPT and could create a forecasting model. If you want, we can move to the next step. So you could provide a prompt to the ChatGPT that move to or proceed with next step. So step by step, ChatGPT will provide you a forecasting model, or it will help you create a forecasting model. As you can see, it has started analyzing it. So the augmented Dickey-Fuller, that is ADF test, gives up a p-value of approximately 0.0033. Since this p-value is less than the common significance level of 0.05, we can reject the null hypothesis that the time series has a unit root, meaning the time series is stationary. So you could see that he's asking us, shall we proceed with the Sarima model parameter selection? Yes, here is the model parameter selection. So you could select any based on the trends and the bar graphs plotted by the ChatGPT. So you could see guys that the ChatGPT has analyzed the spreadsheet and provided the response that the grid search for the optimal Sarima parameters based on the lower ACLI information criterion, such as the best fit model uses the parameter 011 and for ARIMA and 01112, that is for the seasonal component. So you could see that it has provided the model and the parameters. Now it's asking us, shall we move on to forecasting future sales with this model? Yes, proceed with that. So you could see that with ChatGPT's assistance, you can build complex forecasting models in Excel, allowing you to make informed decisions and plan for the future effectively. So ChatGPT is a valuable tool for Excel users and data analysis, offering assistance in data cleaning, analysis, visualization, and automation. And by integrating ChatGPT in your Excel workflows, you can enhance your productivity and uncover new insights from your data. So you can try ChatGPT for Excel data analytics today and take your Excel skills to the new level. And you could see that there's an error in the analyzing, and he has encountered an error while trying to plot the forecast with its confidence intervals. So this type of error can occur due to data type issues, particularly when handling data indices and forecast. And despite this hiccup, the forecasting process using the Sarima model was completed and we were able to generate forecast for the next 12 months. Unfortunately, due to the plotting issue, we couldn't visually display it. So we'll ask him, can you try once again? So you could see that this time ChatGPT has provided us the forecast for the next 12 months. That is, the forecast have been successfully plotted along with the historical daily data. So here we have our forecast model, and with the ChatGPT's assistance, we can move with other analysis also.
So let's start with the first question. What is SQL? SQL stands for Structured Query Language. It's a programming language used to manage and manipulate databases. With SQL, you can query, update, insert, and delete data in a database. Imagine it as a librarian who knows where every book in a library is. When you need information, you ask the librarian and they fetch it for you. Similarly, with SQL, you write queries to get the data you need from a database. For example, to find all the customers in a database who live in New York, you'd write select star from customers where city is equal to New York. Now this is a query. So this command tells the database to find all the records in the customers table where the city is New York. SQL is essential because it provides a consistent way to interact with relational databases which store data in structured tables. Now the second question is, what is a database? Now, a database is an organized collection of data stored electronically. Think of it as a digital filing cabinet where you can store and retrieve information quickly. Managed by Database Management Systems or DBMS. Databases allow you to use SQL to interact with data. For example, an online bookstore uses a database to keep track of books, authors, customers, and orders. So tables like books, customers, and orders store all the necessary information. SQL queries help the bookstore to find in-stock books, top customers, or total sales easily. Now let's move on to the next question. What is DDL, or Data Definition Language? So DDL primarily stands for Data Definition Language, which is a subset of SQL that deals with the management of database structures. It includes commands for defining and modifying the structure of database objects such as tables, indexes, and constraints. Now here are some key DDL commands. Create, which is used to create new database objects like tables, indexes, or views. The second one is alter, which modifies existing database objects such as adding, deleting, or modifying columns in a table. Next, we have drop, which deletes an entire database object such as a table or index. So DDL commands are crucial for database administrators and developers to manage the structure of databases effectively. They allow for the creation, modification, and deletion of database objects, ensuring the database remains organized and optimized for data storage and retrieval. Now let's move on to the next question, which is, what do you mean by DML or data manipulation language? So data manipulation language is a subset of SQL used for managing data within database objects. So unlike data definition language, which focuses on defining database structures, DML deals with retrieving, inserting, updating, and deleting data stored in the database tables. So here are some key DML commands. The first one is select, which retrieves data from one or more tables based on specified criteria. Next, you have insert, which adds new rows of data into a table. Then you have update, which modifies existing data in a table. And at last, you have delete, which removes rows of data from a table. So DML commands are essential for applications to interact with and manipulate the data stored in databases. They allow users to perform tasks such as querying for specific information, adding new records, updating existing ones, and deleting unnecessary data. Now let's see what the fifth question is. What do you mean by a foreign key? So a foreign key in the context of databases is a column or a set of columns that establishes a link between two tables in a relational database. So it represents a relationship between two tables when a value in the foreign key column of one table matches a primary key value in another table. So this relationship helps enforce referential integrity between the tables, ensuring that every foreign key value points to an existing primary key value in the reference table. For example, consider two tables, orders and customers. So the orders table may have a column named customer ID, which is a foreign key referencing the customer ID column in the customers table. This foreign key relationship ensures that every customer ID in the orders table corresponds to a valid customer ID in the customers table, thereby maintaining consistency and integrity of the data. So now let's move on to the next question. What are table and field? So in the context of databases, a table is a fundamental structure in a relational database that organizes data into rows and columns. Each table represents a collection of relatable data entries. Table consists of columns and rows. Columns define the types of data that can be stored in each field, such as integers, strings, dates, etc. Tables are used to store and organize data in a structured manner, facilitating efficient data retrieval, manipulation, and storage. Now, a field, also referred to as a column, is a vertical element within a table that represents a specific attribute, a property of the data being stored. Each column in a table has a name and a data type that defines the kind of data it can hold, such as numbers, text, dates, or binary data. Fields are the building blocks of tables and define the structure of the data stored within the table. For example, consider students table. So in this example, student ID, first name, last name, date of birth, and grade are fields or columns within the students table, each storing specific information about each student record. Tables and fields are fundamental concepts in relational databases, allowing for efficient organization, storage, and retrieval of structured data. Now moving on to the seventh question, what is normalization? So normalization is a process of organizing data in a database efficiently to reduce redundancy and dependency. It involves breaking down large tables into smaller related tables and defining relationships between them. Now the main goal of normalization are to minimize data redundancy, ensure data consistency, and improve data integrity. So in simpler terms, normalization helps to structure data in such a way that avoids storing the same information multiple times and reduces the likelihood of errors or inconsistencies in the database. So it typically involves dividing large tables into smaller ones and establishing relationships between them using keys, like primary key and foreign keys, to ensure data is stored logically and efficiently. Now, what is a query? So a query is a command used to retrieve, update, or manipulate data stored in a database. It's written in a query language like SQL and specifies a criteria for selecting or modifying data according to the user's needs. For example, a simple query might retrieve all records from a table, while more complex queries can filter data based on specific conditions or perform calculations. Queries are essential for interacting with databases and retrieving meaningful information efficiently. Now let's move on to the ninth question, which is, what are the different operators available in SQL? SQL operators are special symbols or keywords used to perform operations on data. They can be categorized into several types. Let's go through them with examples. The first one is arithmetic operators, which perform mathematical operations like addition, subtraction, multiplication, and division. Then you have comparison operators which compare two values and return a Boolean result, which is equal, not equal, greater than, less than, and so on. Then you have logical operators which combine multiple conditions such as and, or, not. Then you have bitwise operators which perform bit level operations like bitwise and, bitwise or, etc. Then you have set operators which combine results of two queries like union, union all, intersect, and except. And then you have other operators like between, in, is null, etc. So these were the operators in SQL. Now the 10th question is, what are user-defined functions in SQL? So user-defined functions, or UDFs, in SQL are custom functions created by users to perform specific tasks. Unlike built-in SQL functions, UDFs are tailored to meet particular requirements of your application or business logic. They can be used to encapsulate complex calculations or repetitive tasks, making your SQL code more modular and easier to maintain. Now, there are two types of UDFs. The first one is scalar functions. So these functions return a single value, such as an integer, float, or string. Then you have table-valued functions. These return a table, which can be used like a regular table in SQL queries. Now, the next question is, what is an alias command in SQL? So an alias in SQL is a temporary name given to a table or a column in a SQL query. This helps to make your SQL queries more readable and easier to understand. So think of it as a nickname for a column or table that you use just for the duration of the query. So here's how you can use alias with columns and tables. Column alias. You use a column alias to rename a column in your query result. This is useful for making column names more readable or for when you want to rename columns in your output. So the query you can give is select first name as first, last name as last from employees. So in this query, first name is given the alias first and last name is given the alias last. So the result will show these aliases as the column headers. Now we have table aliases. You use a table alias to rename a table in your query. This is particularly useful in complex queries involving joins where it can help shorten the query and improve readability. So for example, you have this query. So in this following query, the employees is given the alias E and department is given the alias D. This makes the query shorter and easier to follow. So hope you understood this. Now let's move on to the next question, which is, what is ETL in SQL? So ETL stands for extract, transform, and load. So it's a process used in database management and data warehousing to move data from one or more sources to the destination system, usually a data warehouse or database, where it can be used for analysis and reporting. Let's break down each part of ETL. First one is extract. So this is the first step where data is extracted from various source systems. Then you have transform. So once the data is extracted, it needs to be transformed to fit the structure and format of the destination system. So this step can include cleaning the data, aggregating it, and performing calculations or conversions. And at last you have load, which is a final step, which is loading the transformed data into the target database or data warehouse. Now the next question is, how to copy tables in SQL? So copying tables in SQL is a common task. Whether you are duplicating data for backup purposes, testing, or creating a new table based on an existing one, there are a few methods to copy tables, and I'll guide you through the most straightforward ones with examples. So the select into statement is a simple way to copy the structure and data of a table into a new table. So for example, you can give this query. So this command creates a new table called new table with the same structure and data as existing table. Now, what are union, minus, and intersect commands? So these commands are used to combine the results of two or more queries in different ways. Let's dive in and understand each of them with examples. The first one is union. So the union command is used to combine the results of two or more select queries into a single result set. It removes duplicate rows between the combined results. So for example, this query combines the first names from the employees table and the customers table into a single list, removing any duplicates. Next, we have minus. So the minus command, also known as except command in some SQL dialects, is used to return the results from the first query that are not present in the second query. So for example, this query returns first names that are in the employees table but not in the customers table. Next, you have intersect. So the intersect command is used to return the common results from two or more select queries. It includes only the rows that are present in all queries. For example, This query returns first names that are present in both the employees table and the customers table. Now let's move on to the next question, which is what is a SQL injection? So SQL injection is a code injection technique that attackers use to exploit vulnerabilities in an application software by injecting malicious SQL code. So this can allow attackers to read, modify, or even delete data in the database without proper authorization. So SQL injection typically happens when an application takes user input and inserts it directly into a SQL query without proper validation or sanitization. So let's look at an example to understand this better. So imagine you're having a simple login form where users enter their username and password. The application might use a SQL query like this to check the credentials. So if the application directly inserts user input into the query, an attacker could input something like the second query. So since 1 is equal to 1 is always true, the query returns all rows in the users table, potentially giving the attacker access to the system without a valid password. Now, what is auto increment? So auto increment is a feature in SQL that automatically generates a unique number whenever a new record is inserted into a table. So this is particularly useful for creating primary keys where each record needs a unique identifier. So when you define a column with an auto increment attribute, the database automatically assigns a unique value to that column for each new row. The value usually starts at 1 and increments by 1 for each subsequent row, although you can customize the starting point and increment value. So let's look at a simple example to understand how auto increment works. So imagine you are creating a table to store information about employees. You want each employee to have a unique ID. So in this example, the employee ID column is a set to auto increment. This means that when you insert a new employees into the table, you don't need to specify the employee ID value. The database will handle it for you. Now the next question is, what is the default constraint? So the default constraint in SQL is used to provide a default value for a column when no value is specified during the insertion of a new record. So this helps ensure that your table always has meaningful data, even if some fields are left blank during data entry. So when you define a column with the default constraint, the database will automatically insert the specified default value if no other value is provided for that column. So let's look at an example to understand how the default constraint works. So imagine you are creating a table to store information about products and you want the default stock quantity to be 0 if not specified. So in this example, the stock quantity column is given a default constraint with a value of 0. This means that if you insert a new product without specifying the stock quantity, it will automatically be set to 0. Now let's move on to the next question. What is the difference between the between and in operators in SQL? So both between and in operators are used to filter query results based on certain conditions, but they serve different purposes and are used in different contexts. Let's break it down. The between operator is used to filter the result set within a certain range. It can be used with numbers, text, or dates. The range specified includes both the start and end values. So imagine you have a table called sales with a column sales amount. You want to find all sales that are between $100 and $500. So in this query, between filters the results to include only those records where the sales amount is between 100 and 500, inclusive. So in operator is used to filter the result set based on a list of specified values. It allows users to specify multiple values in a where clause. For example, let's say you have a customers table and you want to find customers who are from either New York, Los Angeles, or Chicago. So in this query, in filters the results to include only those records where the city is either New York, Los Angeles, or Chicago. Now let's move on to the 19th question. What is the difference between a primary key and unique constraints? So both primary key and unique constraints are used to ensure that data in a database remains unique, but they have distinct characteristics and uses. So let's explore each of them in detail. So a primary key is a constraint that uniquely identifies each record in a table. It's a column or a combination of columns that ensures all rows in the table are unique and not null. Then you have unique constraints. So a unique constraint also ensures that all values in a column or a set of columns are unique. However, unlike a primary key, a table can have multiple unique constraints, and columns with unique constraints can contain null values. Now, what is a join in SQL and what are the types of joins? So join in SQL is a way to combine rows from two or more tables based on a related column between them. Joins are used to fetch data from multiple tables and present it as a single result set. So there are several types of joins, each serving a specific purpose. Let's dive into the main types of joins with examples. Inner join. So an inner join returns only the rows where there is a match in both tables. Left outer join. So a left join returns all rows from the left table and the matched rows from the right table. So if no match is found, null values are returned for columns from the right table. Then you have right outer join. So a right join ensures all rows from the right table and the matched rows from the left table. If no match is found, null values are returned for columns from the left table. And at last you have full outer join. So full join returns all rows when there is a match in either the left or right table. So if there is no match, null values are returned for columns where there is no match. Now the 21st question is, what is an index? So an index in a database is like a roadmap that helps quickly find specific information in a table. So normally data is stored in a specific order on a disk, making it efficient for sequential reading. However, when you need to find specific data quickly, like searching for different values, an index acts like a shortcut. So it's akin to having a quick reference guide that allows database to pinpoint relevant data without scanning every single entry. So this makes searches fast, similar to how a binary search operates. So although indexes require extra disk space and can slow down data writes, they greatly enhance retrieval speed for commonly accessed data. Now, what is the on-delete cascade constraint? So an on-delete cascade constraint in MySQL automates the deletion of related rows in a child table when corresponding rows in the parent table are deleted. So this ensures that all dependent records in the child tables are removed without requiring manual deletion, maintaining data integrity and simplifying database management. Now, what is a cursor? So a cursor in SQL is a temporary storage area allocated by database serving during DML operations like select, insert, update, or delete. So cursors allow you to process each row in a result set individually, making it useful for row-by-row data manipulation. So you declare a cursor with a query, open it to execute the query, fetch rows one at a time for processing, and close the cursor when done to release resources. So the next question is, what are the various types of relationships in SQL? So in SQL, relationships between tables are crucial for organizing and structuring data. Here are the different types of relationships. The first is one-to-one. So each row in table A is linked to one and only one row in table B, and vice versa. So example, a table of employees and a table of employee addresses, where each employee has one unique address. Now the next one is one-to-many. Here, each row in table A can be linked to multiple rows in table B, but each row in table B is linked to only one row in table A. For example, a table of departments and a table of employees, where each department has multiple employees, but each employee belongs to only one department. Now the next one is many-to-one. So it is a reverse of one-to-many, where each row in table B can be linked to multiple rows in table A. So for example, multiple employees can be linked to one department. And the last one is many-to-many. So each row in table A can be linked to multiple rows in table B, and each row in table B can be linked to multiple rows in table A. For example, a table of students and a table of courses, where each student can enroll in multiple courses and each course can have multiple students. So these relationships help maintain data integrity and facilitate complex queries by properly structuring how tables interact with each other. Now the 25th question is, what is the difference between SQL delete and SQL truncate commands? So the delete and truncate commands in SQL are used to remove data from tables, but they operate differently and have different implications. SQL delete removes specific rows from a table based on a condition. SQL truncate removes all rows from a table, resetting the table to an empty state. Now, what is the difference between cluster and non-cluster index? Clustered index. A clustered index reorders the way records are physically stored in a table based on the indexed columns. There can only be one clustered index per table. It organizes data rows in tables based on the indexed columns. It changes the physical order of the table data to match the index order. So typically, it's used on columns that are frequently used for range queries, example, where, order by, etc. Now, a non-clustered index does not change the physical order or the table rows and creates a separate structure for the fast data retrieval. So multiple non-clustered indexes can exist on a single table. Does not affect the physical order of the table data. It stores index entries separately from the actual data rows. So it is typically used for columns that are frequently used in join, where, and order by clauses. Now the next question is, what is a live log? So live log happens when multiple processes are actively running but are stuck in a repetitive cycle of interaction. So each process responds to changes initiated by others, causing a loop where no meaningful progress is made. So unlike a deadlock where processes are all waiting for resources, in live log processes remain active and continue to react to each other without achieving any productive outcome. This can occur in concurrent systems where processes are trying to coordinate actions but end up in a state where their actions hinder each other's progress, leading to a persistent loop of interactions. Now the next question is, name different types of case manipulation functions available in SQL. So these are the three useful functions in SQL for manipulating the case of strings. The first one is lower. The lower function is used to convert a string into a lowercase letter. It accepts a string as inputs and returns the same string with all characters converted to lowercase. For example, if you have a string hello world, applying lowercase, it would result in a smaller case hello world. Now next we have uppercase. So conversely, the uppercase function converts a string into uppercase letters. It also takes a string as input and returns a string with all characters converted to uppercase. And the last one is initCap. The initCap function is used to capitalize the first letter of each word in a string while converting all other letters to lowercase. So this function is handy for formatting names or titles. So these functions are helpful for standardizing text data or formatting it according to specific requirements in SQL queries. Now the next question is, what are local and global variables? So local variables are declared within a specific scope, such as within a function or a block of code. So they exist only within that scope and cannot be accessed or modified from outside it. So local variables are typically used to store temporary data or values that are only needed for a specific task or computation within that particular scope. So once the scope of the function or block ends, the local variables are usually destroyed or no longer accessible. Now the global variables, on the other hand, are declared outside of any specific function or block and can be accessed and modified from anywhere within the program or script. They have a wider scope and persist throughout the entire execution of the program. Global variables are useful for storing values that need to be accessed by multiple functions or parts of the code. However, excessive use of global variables can lead to potential issues like accidental overwriting of values or difficulty in debugging. Now coming to the 30th question, name the function which is used to remove spaces in the end of a string. So in SQL, the trim function is used to remove spaces or other specified characters from the beginning and end of a string. It helps clean up data by eliminating unnecessary white space that might affect the comparisons or display. The syntax for trim is straightforward. You provide the string inside the parenthesis and SQL will trim any leading and trailing spaces for default. Now, what is the difference between truncate and drop statements? The truncate statement quickly removes all rows from a table. It deletes data while keeping the table structure, indexes, and permissions intact. Now, the drop statement completely removes a table from the database. It deletes the table structure along with all its data, indexes, constraints, and permissions. Now, so define SQL order by. So order by arranges fetch data based on specified columns, defaulting to ascending order. But by adding DESC command, you can reverse the order for highest to lowest prices. So it's a simple yet essential feature for organizing data exactly as needed in SQL queries. Now, explain SQL having statement. So the having clause in SQL is used to filter data based on conditions for group results or aggregate functions used in select statement. Unlike the where clause, which filters rows before grouping, having filters rows after data has been grouped together. This means you can use having to apply conditions to summarize data, like finding groups with a total sum about a certain value or averages that meet specific criteria. It's important to remember that aggregate functions like sum, count, average can only be used with having, not with where. This helps SQL manage and analyze data effectively, whether you are looking at individual rows or group results. Now the next question is, explain SQL AND OR statement. In SQL, the AND statement combines conditions where both must be true for a row to be included. For example, this query retrieves employees older than 25 who work in the IT department. Now, the OR statement is used when at least one condition must be true. For instance, this query retrieves products in either the electronics or clothing category. Both statements allow for flexible data filtering based on specific criteria in SQL queries. Now, let's move on to the next question, which is, why do we use commit and rollback commands? We use commit in SQL to finalize and permanently save changes made by a transaction, ensuring they are visible to other users or applications. And rollback is used to undo changes if a transaction encounters an error or needs to be cancelled, reverting the database to its previous state. So these commands are essential for managing transactional integrity and ensuring data consistency in SQL databases. Now let's see what the next question is. What are asset properties? So asset properties are a set of 4 essential characteristics that guarantee the reliability and consistency of transactions in a database system. So the first one is atomicity. It ensures that all operations within a transaction are treated as a single unit. So either all operations are successfully completed, or if any operation fails, the entire transaction is rolled back to maintain data integrity. The second one is consistency. Ensures that only valid data is committed to the database. Transactions take the database from one valid state to another. Constraints, triggers, and validations are applied to ensure data consistency. I stands for isolation. It ensures that the execution of transactions concurrently does not interfere with each other. Each transaction is isolated from others until it completes, preventing them from accessing uncommitted changes. And the D stands for durability. Ensures that once a transaction is committed, its changes are permanent and survive system failures. The changes are stored in non-volatile memory disk and remain intact even in case of power loss or system crash. Now the next question is, are null values the same as 0 or a blank space? So no, a null value in SQL are not the same as 0 or a blank space. So null represents a missing or unknown value in a database column. It indicates that the value for that particular record is undefined or not applicable. It is distinct from 0 or an empty string. 0 represents a numerical value that is explicitly defined as a number 0. It is a numeric value and not the same as null. Now, blank space or empty string represents an absence of characters in a string field. It is different from null, which is specifically used to denote the absence of any value, including numeric or other data types. Moving on to the next question, what is the need for group functions in SQL? In database management, group functions, also referred to as aggregate functions, are used to process multiple rows of data together based on specific criteria, resulting in a single meaningful value. These functions operate across groups of rows rather than individual rows, allowing for calculations and summaries at a higher level of abstraction. So various group functions are, the first one is count function. So it calculates a number of rows that meet the specified criteria, such as counting the number of orders placed by customers. The next one is sum function. It adds together the numeric values in a column for all rows that meet the criteria, like totaling the sales revenue for a specific period. And then you have the average function, which computes the average value of a numeric column across all selected rows, useful for finding the average salary of employees. The next you have min function. It retrieves the minimum value from a column for the selected rows, such as finding the earliest date in a transaction history. And then you have the max function, which retrieves the maximum value from a column for the selected rows. For example, identifying the highest sales figure achieved in a month. Now the next question is, how can you fetch common records from two tables? So when we have data spread across different tables in a database and want to retrieve information that relates across these tables, we use the join statement. This SQL feature lets us specify which columns from each table we want to include in our query results. Now the next question is, how do we avoid getting duplicate entries in a query without using the distinct keyword? So when dealing with SQL queries, the distinct keyword serves to filter out duplicate rows from the result set. So while useful, it can sometimes impact query performance because it requires the database engine to sort and compare the result set to eliminate duplicates. So alternatively, there are several methods to remove duplicates efficiently. The first one is using row numbers. So by assigning new row numbers to each row partitioned by the columns that define uniqueness, you can filter out duplicates by selecting rows where the row number is 1. The next is using self-join. So joining a table to itself based on a columns that define uniqueness allows you to filter out duplicate entries, selecting only those rows where corresponding values match. And then by using group by. So grouping rows based on columns that define uniqueness and aggregating the results helps in eliminating duplicates, as each group represents a unique combination of values. Now the next question is, what is the difference between a coalesce and is-null function? So the coalesce function returns the first non-null expression from its arguments. This means if you have multiple expressions separated by commas, this function will evaluate them in order and return the first non-null value. If all expressions are null, then the function returns null. Now in SQL Server, the is-null function serves a different purpose. It replaces null values with a specified replacement value. Now the next question is, what's the difference between rows and range? So rows specifies the window frame based on a physical number of rows before and after the current row. And the range defines the window frame based on rows with the same values as the current row. This is useful when your data is ordered by values that can have duplicates. Now the next question is, what is a CTE, also known as Common Table Expression, and how is it different from a subquery? So a Common Table Expression, or CTE, is a temporary result set that you can reference within a select, insert, update or delete statement. It is defined using the with clause and is easier to read and maintain compared to subqueries. So unlike subqueries, CTEs can be self-referential and recursive, which allows for more complex query. Moving on to the next question, explain the difference between cross-join and full outer join. So cross-join produces a Cartesian product of two tables, meaning each row from the first table is combined with each row from the second table. And the full outer join returns all records when there is a match in either the left or right table. It combines the results of both left join and right join. Now, as the 45th question, we have, what are Windows functions? So Windows function performs a calculation across a set of table rows related to current row. Unlike aggregate functions, they do not cause rows to become grouped into a single output row. Common window functions include row number of, rank of, and dense rank of. So this is how the query will look like. Now, what is the difference between the rank of and dense rank of functions? So a rank of function assigns ranks to rows within a partition with gaps in the ranking sequence when there are ties. And the dense rank of assigns ranks to rows within a partition without gaps in the ranking sequence when there are ties. How do you perform a recursive query in SQL? Recursive queries are performed using recursive CTEs. They are defined using the with clause and include a union all to combine the anchor member and the recursive member. So this is how a recursive query looks like. Now, as the next question we have, write a query to find the top 5 customers with the highest total order amounts. So this is your query. Now this SQL query selects the customer ID and calculates the sum of order amount for each customer from the orders table. Now it then groups the results by customer ID using group by, ensuring each customer's total order amount is aggregated. The order by total order amount DESA arranges these totals in descending order, placing the customers with the highest order amounts at the top. Finally, the limit 5 restricts the output to only the top 5 customers with the highest total order amounts. Now, how can you optimize a slow running query? So there are several techniques, including use appropriate indexes. Indexes help retrieve the data faster by organizing it efficiently. Second, avoid unnecessary joins and subqueries. Simplify your queries to minimize the amount of data processed. Third, use efficient functions and operators. Choose functions and operators that perform tasks with minimal overhead. And then analyze execution plans. Review query execution plans to identify and address performance bottlenecks effectively. Moving on to the last question, what is a partitioned table and why would you use it? So a partitioned table is a large table divided into smaller, more manageable pieces called partitions. So partitioning improves performance and manageability, especially for large data sets, by allowing queries to scan only relevant partitions rather than the entire table. For example, this SQL statement creates a table named sales with columns sale ID of type int, sale date of type date, and amount of type decimal 10 to. It partitions the table sales based on the sale date column using range partitioning. Two partitions, which is P0 and P1, are defined. So P0 includes values less than 2022-0101 and P1 includes values less than 2023-0101. This setup allows data in the sales table to be divided into separate partitions based on the data ranges.
That concludes our Advanced SQL Full Course for 2024. If you found this course helpful, please give it a thumbs up and consider sharing it with others. Thank you for joining us on this journey.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.